to lead us in prayer. May this invocation set a tone of wisdom, harmony, and purpose for the proceedings ahead. I request everyone to kindly rise and join in the solemn moment.
मुदाकरात्तमोदकं सदा विमुक्तिसाधकं कलाधरावतं शतं विलासिलोकरक्षकम् अनायकैकनायकं विनाशिते भटेत्यकं नताशुभासुनाशकं नमामि तं विनायकम् नमामि तं विनायकम् नचेतरातिभीकरं नवोदितातभास्वरं नमः सुरारिणेचरं नतातिकापतुधरं सुरेश्वरं निधीश्वरं गजेश्वरं गणेश्वरं महेश्वरं तमाश्रये परात्परं निरन्तरम् परात्परं निरन्तरम् अकिञ्चनातिमचनं चिरं तनोऽपि भाजनं सुरारिपूर्वनन्दनं पुरारिगर्वचर्वनं प्रपञ्चनाशभीषणं धनञ्जयातिमोचनं कपोलतारवारणं भजे पुराणवारणम् भजे पुराणवारणम् निदान्तकान्तदन्तकान्तिमन्तकान्तकात्मजम् अचिन्त्यरूपमन्तहीनमन्तराय कृन्तनं निरङ्करे निरन्तरं वसन्तमेव योगिनं तमेकदं विचिन्तयामि सन्ततम् विचिन्तयामि सन्ततम्
Thank you all for joining in the solemn moment of prayer. You may now kindly take your seats. Ladies and gentlemen, let us take a moment to experience the beauty of art in motion. Dance is a language that transcends words, an expression of grace, culture, and emotion. Every song carries a story, a rhythm that speaks to the soul. Welcome Song is about a flourishing field of geophysics, written by our esteemed alumni, Professor S.K.G. Krishnamacharyalu, retired Dean, School of Earth Sciences, SRTM University, non-date, hailing from batch 1979 to 1982. The music was composed and sung by Dr. M.R.K. Prabhakar Rao, retired Chief Scientist, National Geographical Research Institute, who is also our alumni of batch 1974 to 1977. The chorus was supported by Professor Prasad Rao and Sri Ramanamurthy, who are brothers of Dr. Prabhakar. The dance for this song is choreographed by Sri VVS Jagannath Rao Garu, a disciple and student of Venkati Satyam Kuchipudi. It is with great pleasure that we present before you a captivating dance performance by Sugana Reddy and her team. Please join me in welcoming the performers with a great round of applause.
భూభౌతిక జ్ఞానకని భారత వైజ్ఞానిక విద్వన్మణి ఆంధ్ర విశ్వ కళా పరిషత్ నందనం మన భూభౌతిక శాఖకు వందనం వందనం వందనం. నందనవనం నందనవనం మంచి కార్యదీక్ష రాధాకృష్ణ విధుల రక్ష రామ కష్టఫలం భూభౌతిక నందనవనము మంచి కార్యదీక్ష రాధాకృష్ణ విధుల రక్ష సుందర రామ కష్టఫలం భూభౌతిక నందనవనము సగటు మనిషి అవసరాలు దేశం వినిమయాలు విశ్వశక్తి విధి విధాలు 15 వత్సరాల ఉత్సవాలు అద్భుతమ ప్రగతి విరామాలు శతమానం భవతి శతమానం భవతి శతమానం భవతి శోధన సంశోధన శోధన పరిశోధన వీక్షణ సర్వేక్షణ పరిరక్షణ భూమి పొరల అమరికలు అంతరిక్షాద్భుతాలు భారత భూ సంపద భాగ్యము సౌభాగ్యము భారత భూ సంపద భాగ్యము సౌభాగ్యము తేజస్వినావలీయాసు మాయిద్విషావహై నియమాలు విద్యుత్తర కీచికలు కంపనాలు గణన సూత్రాలు అనువర్తిత అంశాలు గణిత గణన సూత్రాలు అనువర్తిత అంశాలు ఎవరైనా లేవైనా ఎవరైనా దేవైనా లేని శాఖ సాటి లేని శాఖ మన శాఖ శాఖ సాటి లేని శాఖ మన భౌతిక శాఖ नमो भगवती 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 नमो भगवती
A heartfelt thank you to our incredible performers for a truly mesmerizing performance. The grace, the rhythm, and the expression have left us all spellbound. Let's give them another round of applause as a token of our appreciation. Thank you. Ladies and gentlemen, esteemed guests, distinguished scientists and scholars, it is my honor to welcome you all to the inaugural event of the National Seminar on Advances in Geophysics for Sustainable Future, Energy, Environment, and Natural Resources. This prestigious event is organized by the Department of Geophysics, Andhra University, as part of its Platinum Jubilee celebrations. Today, we have the privilege of hosting some of the most renowned scientists and experts from different parts of the country. We are delighted to see such a gathering of brilliant minds, all united by the passion for geophysics and its. The seminar's theme, Advances in Geophysics for a Sustainable Future, Energy, Environment, and Natural Resources, reflects the critical role that geophysics plays in addressing some of the most pressing challenges of our time. From exploring new energy sources to mitigating the impacts of climate change, geophysics has the potential to provide innovative solutions. Over the next 2 days, we will have the opportunity to engage with cutting edge research, share knowledge, and exchange ideas with experts in the field. We will explore the latest advances in geophysical techniques, their applications, and their potential to contribute to a sustainable future. Before we begin, I would like to express my heartfelt gratitude to our esteemed guests, speakers, and participants for joining us today. Your presence is a testament to the importance of this seminar and the impact that geophysics can have on our world. Now, without further ado, I humbly seek the presence of our revered principal, Professor M.B.R. Raju, Principal, AU College of Science and Technology, on the dais. As a token of deep respect and admiration, I invite Professor C.V. Naidu, convener of the seminar and head of the Department Geophysics, to join us on the dais. As a gesture of deep appreciation, I now request Sandhya to extend a floral tribute to the convener and HOD, Professor C.V. Naidu. Thank you, sir. I am deeply honored to request the august presence of our chief guest, Honorable Vice Chancellor, Professor G. Sasibhushan Rao, a paragon of academic brilliance and an epitome of excellence and erudition, to kindly grace the dais with your presence. With great honor and reverence, I request Kavita to extend a floral welcome to our esteemed chief guest, Honorable Vice Chancellor Professor G. Sasibhushan Rao. Pride that I acknowledge the presence of the legendary scientist, Dr. Prakash Chavan, a towering figure in the realm of scientific excellence, Director, National Remote Sensing Center, Hyderabad, to ascend the dais and take their esteemed position. As a humble expression of gratitude, I invite T. Devi to offer a bouquet to our distinguished guest, Dr. Prakash Chavan. Thank you, sir. With deep admiration and respect, I earnestly request our distinguished guest, geologist par excellence, Shri Sujit Kumar Tripathi, a visionary explorer who deciphers the narratives of the sea floor, to step forward and assume the place on the dais. To extend sincere appreciation and warm welcome, I now invite K. Swati to present a bouquet to our honored guest, Sri Sujit Kumar Tripathi. It is an extraordinary privilege to welcome and humbly call upon the eminent Professor T. Harinarayana, alumnus of the Department of Geophysics, and who made an indelible mark in energy studies, thus changing the scenario of solar energy in Gujarat to take their rightful place on the dais. As a mark of utmost respect and warm appreciation, I now request T. Devi to extend a floral welcome to our respected guest, Professor T. Harinarayana. To our esteemed Professor A. Lakshmipati Raju, retired Professor, Department of Geophysics, a guiding force in academia for over 3 decades, a mentor for excellence, a beacon of wisdom, and an architect of countless successful futures, to step onto the dais and bless the occasion. With due respect and admiration, I request K. Nandini to present a bouquet as a token of her appreciation to Professor A. Lakshmipati Raju. I now invite Professor P. Rajendra Kumar to come onto the dais. P. Rajendra Prasad. As a mark of utmost respect and warm appreciation, I now request Navya to extend a floral welcome to our respected guest, Rajendra Prasad, Professor Rajendra Prasad. Now I request President of the function, Professor M.P.R. Raju, to take up further proceedings.
Good morning, everybody. I request all the dignitaries on the dais, please come forward and write.
Most respected learned dignitaries on the dais, respected Professor C.V. Naidu Garu, Head of the Department, most respected Dr. Prakash Chauhan, Director, NRSC Hyderabad, respected Sri Sujit Kumar Tripathi, DDG, GSI Visakhapatnam, respected Professor T. Harinarayana, Osmania University, respected Professor A. Lakshmi Patraju Garu, my beloved Vice Chancellor, and today's Chief Guest, Professor G. Sashibhushan Rao Garu, and dignitaries of the dais. It's my privilege to share my teaching, clinical, and research experience towards the national seminar on advances in geophysics for sustainable development, energy, environment, natural resources. Basically, I belong to psychology department. I am specialized in health psychology. That today, my brief presidential speech application with today's national seminar. The psychology aspects of sustainable energy adoption. One of the critical challenges in transitioning to sustainable energy sources is public perception and behavioral change. Psychological theories such as the theory of planned behavior, AGSEEN 1991, suggests that an individual's attitude subject to norms and perceived behavioral controls significantly influence their willingness to adopt renewable energy solutions. The behavioral inventions, including awareness campaigns, incentive-based programs, and community engagement, can encourage sustainable energy practices. Moreover, the cognitive biases such as status quo bias and discounting the future benefits often hinder the people from investing in sustainable alternatives. Overcoming these biases through nudges, persuasive communications, and environmental education is essential for large-scale adoption of clean energy technologies. Coming into environmental psychology and conservation behavior, environmental degradation and climate change are pressing concerns that require an in-depth understanding of human behavior. Environmental psychology examines how individuals perceive and interact with their surroundings. According to M.A. Raju, says that fostering a strong environmental identity and connection with nature can promote pro-environmental behavior. Interventions such as feedback systems providing the real-time data on energy usage have been shown to enhance conservation efforts. Additionally, social norms play a crucial role. When individuals perceive that their community values sustainability, they are more likely to engage in eco-friendly behavior. Coming to end, mental health implications of climate change and resource scarcity. The depletion of the natural resources and environmental instability contribute to psychological distress, a phenomenon referred to as climate anxiety. Individuals facing climate-induced disasters often experience increased levels of the stress, anxiety, and depression. Addressing these concerns through psychological resilience training, community support, networks, and policy frameworks can help mitigate the mental health consequences of environmental changes. Additionally, sustainable urban planning that integrates the green spaces, clean energy solutions, and resilient infrastructure contributes to the overall well-being by reducing the stress and improving cognitive functions. Thank you, one and all. Now, I invite Dr. Prakash Chauhan, Director, NRC, Hyderabad. Please address to the landed delegates, sir. Okay. Sir, please 1 minute, sir. Okay. Small modification. Now, I invite Professor C.V. Naidu Garu, Head of the Department. Please address to the gathering, sir.
Used to be earlier.
Honorable Vice Chancellor, Professor G. Seshibhushan Rao garu, and beloved NRC Director, Dr. Prakash Chauhan ji, DTG of GSI, Sujit Kumar Tripathi ji, Harinarayan Garu, Lakshmi Patral Garu, M.V.R. Raj Garu, our beloved principal. Dignitaries, esteemed guests, distinguished alumni, faculty, delegates, students, and scholars. Good morning to all. It is with immense joy and gratitude that I extend a heartfelt welcome to all of you on this momentous occasion, the National Seminar and Platinum Jubilee celebrations of the Department of Geophysics. Today, as we gather to commemorate 75 glorious years of excellence in geophysics, research and innovation. We are overwhelmed by the enthusiastic participation of scholars, researchers, students, professionals from across the country and beyond. The Department of Geophysics is known for great teachers and researchers. This grand event has been made possible by generous contributions of distinguished alumni, esteemed funding agencies, ONDC, MOS, NGRI, IMD, NRSC, INQUIS, NABARD, CGWB, AMD, AHI, IIGM, and Andhra University, and well-wishers who have shown unwavering commitment to the growth and success of our department. Their support has enabled us to organize a platform for knowledge exchange and meaningful discussions. The Department of Geophysics has played a pivotal role in advancing scientific research and education over the past 75 years. Through its pioneering work in seismic studies, mineral exploration, groundwater research, and environmental geophysics, the department has made significant contributions to both academia and industry. Our faculty and researchers have been at the forefront of innovation, fostering a legacy of excellence that continues to inspire generations of students and professionals in this field. In this connection, I am honored to mention that many stalwarts from the Department of Geophysics made Department of Geophysics famous at national and international levels. The students graduated from this department are doing exceptionally well, and all of them got good placements and pursuing higher studies. We're also delighted to share that we have received nearly 110 high quality abstracts from scholars and researchers across various institutions, reflecting the depth and diversity of ongoing research in geophysics and allied sciences. The sheer excellence of these submissions highlights the ever expanding and frontiers of knowledge in our field and sets the stage for engaging discussions that will contribute to significant advancements. A special mention that must be made of this exhibition, particularly which showcases the cutting-edge advancement in geophysics and allied sciences. The dedication of our faculty members, organizing committee, and colleagues have been instrumental, has been instrumental in bringing this vision to reality. We are deeply grateful for their relentless efforts. We also extend our sincere thanks to our university administration, particularly to our Honorable Vice Chancellor Sri Bhushan Rao Garu and Registrar Dhananjaya Rao Garu, our Principal MVR Raj Garu, for their continuous encouragement and assistance in making this celebration a grand success. The esteemed presence of VVIPs, renowned academicians, and leading experts further enriches the significance of this gathering. To our students and scholars, your enthusiasm and participation are a testament to the bright future of geophysics. We look forward to engaging in insightful deliberations for the coming days, paving the way for groundbreaking research and collaborations. Once again, I extend my deepest appreciation to each and every one of you for making this event truly remarkable. Let us celebrate our past, engage in the present, and together shape the future of geophysics. Thank you. Thank you very much. Namaste.
Thank you.
Thank you, Sivan Naidu Garu. Now we have video message by Dr. M. Ravichandran, Secretary, MOS.
Honorable Vice Chancellor, respected Principal, Head of the Department, faculty members, esteemed guests, distinguished alumni, and dear students. Greetings from the Ministry of Earth Sciences. It is both honor and a privilege to participate in this momentous occasion as the Department of Geophysics, Andhra University, is conducting national seminar and celebrates the 75 years Platinum Jubilee celebrations. My apologies that I could not be there in person, and big congratulations to all faculties for their immense contribution in building the capacity in the field of geophysics for our country. This celebration marks a significant milestone in the department's rich and illustrious history. We have gathered here not only to celebrate the achievements of the past, but also to look forward with renewed enthusiasm to the future of geophysics education and research. The Department of Geophysics at Andhra University was established in 1949 under the visionary leadership of Professor Suri Bhavantam. This was a time when the field of geophysics was still in its infancy, and the world was beginning to realize the importance of geophysical studies for both academic and practical applications. The establishment of this department was a bold and forward-thinking move, setting the stage for groundbreaking work in the field of Earth's physical properties. The department is offering diverse and cutting-edge programs like the MSc Tech and MSc degree in geophysics. Over the past 7.5 decades, the department has become one of the premier institutions in India for geophysics education, producing some of the brightest minds in the field. The department's contribution to both the scientific community and industries has been profound thanks to the dedication and hard work of faculty, students, and alumni. One of the most gratifying aspects of this department's journey is the success of its alumni. The achievement of the graduates of this department are a testament to the high standards of education and the nurturing academic environment provided by the department. Alumni have gone on to occupy key positions in a range of renowned organizations both in India and abroad. They are serving with distinction in prestigious institutions such as the National Geophysical Research Institute, the National Institute of Oceanography, the National Center for Polar and Ocean Research, the Indian National Remote Sensing Center, and the Geological Survey of India, India Meteorological Department, Department of Science and Technology, ONGC, and among others. They are contributing significantly to research, policymaking, and the advancement of the geophysical sciences in both the public and private sectors. These accomplished individuals serve as role models for our current students, showcasing the potential impact of geophysics education from Andhra University. Their continued involvement with the department through guest lectures, mentorship, and collaborative projects enriches the reading experience and strengthens the bonds between the past and present members of the geophysics community. Andhra University, which is a pillar of excellence, has played in shaping the Department of Geophysics. Established in 1926, Andhra University has a long-standing reputation for academic excellence, and it has been a cornerstone of our success. The university stands in the top ranks of Indian universities. The recent NAC accreditation of 3.74 over a scale of 4 points showcases its imprint. Over the years, Andhra University has been a place where disciplines like the geophysics, along with the other scientific fields, have flourished. The university's commitment to research, industry collaboration, and global partnership has further enabled the Department of Geophysics to evolve and stay at the cutting edge of scientific advancements. The continued support from the administration, along with the resources allocated to the improved infrastructure and facilities, ensures that the department remains a leader in geophysics education and research. The growing importance of geophysical sciences in addressing global challenges makes this an exciting time for both aspiring students and seasoned professionals. The future of geophysics is interwoven with the global need for sustainable resource management, environmental protection, and disaster prediction and mitigation. With the growing concerns about climate change, the demand for expertise in monitoring and managing natural resources is on the rise. Geophysics will play a key role in understanding Earth's processes and developing solutions to safeguard our blue planet. From earthquake prediction and the study of natural hazards to groundwater exploration and environmental monitoring, the potential for growth and impact in this field is vast. In the coming years, we anticipate that emerging technologies such as artificial intelligence, machine learning, and advanced data analytics will revolutionize the way geophysical data is collected, processed, and interpreted. The integration of these technologies with the traditional geophysical methods will allow for more accurate and efficient models of Earth's subsurface, which will be crucial for resource management, environmental protection, and even space exploration. Sincerely encourage Andhra University to continue producing highly skilled professionals who can meet the challenges of the future and contributing meaningfully to the advancement of the field. Together, we will continue to push the boundaries of knowledge and contribute to the global advancement of geophysics. Thank you, and I look forward to celebrating many more milestones with all of you in the recent years to come. Jai Hind. Thank you. Honorable Vice Chancellor.
Thank you very much, Dr. M. Ravichandra Garu. Elaborately explain about the development of the Andhra University as well as the growth and development of the geophysics research. Once again, I thank you, sir. Elaborately explain about the present development of the geophysics. Now I invite Dr. Prakash Chauhan, Director, NRCS Hyderabad. Please address to the gathering, sir.
Namaskar. Good morning to you all. Most respected Vice Chancellor of Andhra University, Professor Rajendra Prasad ji, dignitaries on the dais, my colleague Sujit Kumar Tripathi ji, DDG, GSI, Professor T. Haray Narayana ji from Osmania University, Professor A. Lakshmipati Raju ji, and then, of course, Professor MBR Raju sir, the principal of this college. First and foremost, many congratulations from my side, on this, and the Honorable Vice Chancellor sir, Professor G. Shashi Bhushan Rao ji. First and foremost, I would like to thank the organizers and especially Professor Rajendra Prasad ji and Vice Chancellor sir for giving me this honor and privilege to be part of this Platinum Jubilee celebrations of one of the oldest geophysics department of this country. So thank you very much, sir, for inviting me here. I really feel humbled and honored to be part of this August assembly. Dr. Ravichandran, he just spoke about the genesis of this department. Let me just tell you some brief history which was shared to me by Professor Rajendra Prasad ji. Somewhere in December 1946, many of you may be aware about the most respected luminary which was produced by this university, Professor Suri Bhagwantam. Professor Suri Bhagwantam, he was the student of Professor Professor Raman, C.V. Raman, and he used to work with him. He was an eminent meteorologist, and he floated this idea in 1946, that there is a need to start a department of geophysics in Andhra University. Incidentally, he was one of the youngest professor. At the age of 29 or 30, he became the full professor in Andhra University, Professor Suri Bhagwanta. Some of you young people should be really proud of such kind of luminaries, those who have been the founding figures of this university. And then, it was decided that two courses, essentially meteorology and oceanography, and then the physics of the earth, two departments should be started, or two courses should be started simultaneously. And that led to the start of the Department of Geophysics. And from 1949 December onwards, I think the Geophysics department started functioning here in Andhra University. In fact, if you look back in hindsight, that was such a visionary, decision, because the education capacity development in very important areas of earth and geosciences, which are directly linked with the socio-economic development of the country, requires trained manpower. For a country like India, who became just independent at the time, the energy security, mineral security, resource utilization, all these questions were very pertinent. Today also, you can see for all our energy requirements, we heavily depend even today on the import of hydrocarbon resources. Minerals, critical minerals, they fuel the economy of the country. So departments like Geophysics department in Andhra University, and at that time, many other departments, like I belong to Geophysics, the Science department of Roorkee University, and then in Dhanbad, then later on IIT BHUs, IIT Bombay, many other places such departments came. But the early capacity building in terms of providing trained manpower in the field of exploration, geophysics, and meteorology, oceanography came from departments like Andhra University. So that has helped in producing so many brilliant alumni. Many of you are present here, and I can name so many of them. Many of them have even retired because we are celebrating 75 years of the department. And they have done so exceedingly well, and many of them have risen to the highest positions in government sector, in various departments of Ministry of Earth Sciences, Department of Space, Geological Survey of India, ONGC, Oil India Limited, wherever the exploration theme is prevalent. Many of these alumni of Andhra University has contributed in a significant manner. So that's the great achievement of this department, which all we should cherish. And I think we should clap once again for all the great faculty members, as well as professors, your mentors, for having done and put that foundation stone so that we could achieve whatever has been achieved in terms of the, that vision which is started in 1946 to realize the overall overarching goal of national development. But today, as we speak and as we celebrate this function, it is also very important to look at what kind of the future beholds in front of us. As Secretary Ministry of Earth Sciences told, there are new challenges in terms of dealing with the threat of climate change, and geophysicists and earth scientists community is playing already a vital role. Today, the geophysics is not only limited to conventional ground-based surveys. I come from Department of Space, and being one of the early geophysicists who joined in Department of Space, I already spent 34 years. Today, I can say with pride that we are using geophysical techniques and technologies, even from satellite platforms, to understand various dynamical behavior of our Earth, our climatic systems, how oceans have been changing, how sensitive ecosystems like glaciers are responding to the threats of climate change, how sea level rise is happening, how the seas are becoming warmer, what is happening to the polar regions of the planet, North Pole as well as South Pole. All this knowledge is coming from the use of geophysical technology from satellite-based platforms. So that technology has also evolved over a period of time. A lot of advancements in oceanography were possible only because of the satellite, oceanographic sensors which have been put, and they utilizes classical geophysical principles to understand the overall health of the planet Earth. Having conclusively, established that climate is really changing by these observations which came from the field-based measurements as well as from space-based, the next few decades will be very important to understand the impact of this climate change on various sensitive ecosystems. I'm sure the department as well as the young students will take very important topics for their research in terms of understanding the adverse effects of this changing climate on ecosystems like Himalayan glaciers, our coastal areas, coastal inundation, sea level rise, warming of the oceans itself is going to lead to the extreme climatic events. It's already happening, and probably it may become much more frequent in times to come in terms of cyclones and heavy precipitation events. How we can generate early warning systems by utilizing this technology. All these areas are going to be very critical. And if we have to manage the threats of sustainable development, we also have to look now towards alternate and new sources of energy. Geophysicists have contributed significantly in finding new oil resources by doing gravity, magnetics, as well as seismic surveys. But the time has come to look forward for new and alternate sources of energy. Today, India is doing fairly well in the field of solar energy utilization. Using satellite data and ground-based measurement, today we have a good inventory about how much solar energy potential is available at different parts of the country and how it can be harvested. We have now rediscovered that our coastline, which we used to say 7,500 kilometers long, has basically become 10,890 simply because of high-resolution satellite-based surveys. So having 10,000 kilometer long coastline, how we can harness the energy of the seas in terms of the wave energy, in terms of the wind energy, or in terms of the thermal gradient which is there in the ocean. These are the new and emerging areas of geophysical research, which probably the department should look keenly as far as the future generations and the future aspects of geophysical training and knowledge is concerned. Apart from that, it is also very important to keep updated with the new computational methodologies. See, many of you know that geophysical inversion requires large amount of understanding of mathematical problems and solving and doing inversion of mathematical data. But today, artificial intelligence and machine learning is coming in a big way, and AI models are becoming so powerful that some of the even weather forecast model, the conventional numerical weather forecast models are now giving way to AI-based weather forecast modeling technique. In the broad field of geophysical data analytics also, the computational schemes driven by the machine learning, deep learning approaches are going to be the key of the future. So I urge that I think department also should start, if not yet started, to start some courses in these emerging parts of the computational schemes, which are going to be very critical for the students of geophysics. With these words, once again, I would like to congratulate each one of you present here in this hall, including entire faculty members. They are the backbone of the departments and the founding fathers of Geophysics Department University for having attained so much in the last 75 years. And we wish that for the next 75 years, you will continue to have the glorious journey which we are cherishing today. And this department will continue to provide most brilliant geophysicists to the country in times to come. Thank you once again, and many congratulations to each one of you.
Thank you.
Thank you very much, sir. Elaborately explain about sustainable technology, about the space, understand the adverse effects of the environment, look towards sustainable development, and also start talking about the alternate energy and update the new alternative methods and even technology. Once again, I thank you, sir. Elaborately explain. Dr. Prakash Chauhan, Director, NRCS Hyderabad. Now I invite Shri Sujit Kumar Tripathi, DDG GSI, Vishayapatnam, sir. Please address to the delegates, sir.
Okay, so good morning, distinguished chief guest, respected all other dignitaries and professors, and my dear young friends, ladies and gentlemen. So it is indeed a great pleasure to be part of this wonderful 3-day national seminar on advances in geophysics for a sustainable future. And on the occasion of 75 years of this department, completion of 75 years of this department. So at the very outset, I congratulate the Department of Geophysics for 75 long years of research and innovation. It is indeed a very remarkable achievement as far as the geophysics education in India is concerned. And as I came to know that this department, has seen many stalwarts and many luminaries of geophysics and pioneers also. And they roamed around in these hallowed halls and classrooms, and they gave lectures to students. So, like, I do not know many of them, but Professor M.S. Krishnan, Professor Mahadevan, Professor B.S.R. Rao, and then I came to know about Professor Murthy, Professor Radhakrishnan, and many stalwarts and luminaries. So, congratulations. And yes, I would like to say one more important thing over here. I'm from Geological Survey of India, and there has been a very consistent stream of geophysics students who have joined Geological Survey of India and who did remarkably well in their professional career and did great contributions as far as geological survey and geophysical survey and research is concerned, and they retired from very high positions. And still to this day, I think there are many geophysicists who are alumni of this department. In my Vizag office, in fact, there are at least 5 or 6 officers who are part of this university. So a big job done. Is never easy to, it's actually a very great service to the nation to educate the young mind and make them ready for the professional career. As for myself, I'm a little of an outsider. Initially, when I was sent an invitation to be a guest in this August gathering for this seminar, I politely said no and accordingly informed the organizers also, because all my schooling, my training is in geology for more than 3 decades, but not at all in geophysics. So I wanted not to dilute the gravity of this meeting. But anyway, Friday evening, once again, Professor Trinath Rao and Professor Naidu once again requested me, and I could not say no, and now I'm in front of you. So it is it is indeed a little bit overwhelming, and I'm deeply honored and humbled to join the league of very great geophysicists and scientists and engineers and people who who excel in their career. And yeah, so that is one thing. And yes, about the one more thing I would like to say that is very important. This seminar is a very timely one and a very useful one, and because the emphasis is on the sustainable future, on climate crisis and all those things. So personally for me, I always feel excited to talk about this particular topic. We all know, although we all know, but still we need to possibly remind ourselves again and again and re-emphasize this point that the single most important problem before the human race is climate crisis. Human race is indeed facing a very grave existential threat, and because of climate crisis, because of our carbon-based economy, carbon-based civilization, we have generated enormous amount of greenhouse gas, and we have inflicted a lot of danger. The greenhouse gas emission is actually the highest in 2 million years. And as a result of that, the surface temperature of the earth has increased by more than 1.1 degree compared to the pre-industrial times. And as a result of that, as already elaborated well by the previous speaker, that yes, there has been polar ice melting and sea level rise and inundation of coastal areas. And then there is ocean warming and ocean acidification. We lost almost half of our coral reefs, and ocean circulation pattern also had changed. And there are, floods and famines and fires as well as cyclones, everything related directly or indirectly to climate change. And there are some positive, this is one thing I would like to say, there are some positive feedback mechanisms also that has been established. And they say that the sea ice, the polar ice is not so white. I mean, it does not reflect whole of the sun's energy. In fact, it has changed its color and it has started to absorb some of the energies. So therefore, it is melting even faster. So that kind of a positive feedback mechanism loop has been established. And they say that possibly by 2040, we'll be able to sail to the North Pole. Such is the grave situation. So unless this is possibly one of our last chances, we are at a tipping point unless we put a very collective and concerted effort and do our bit, every single person, we are in for something very apocalyptic. So I congratulate the organizers for having taken up this particular issue about climate change. And I am from Geological Survey of India. And as you are celebrating 75 years of your department, Geological Survey of India is also going to embark on 175th year of its official existence. Geological Survey of India, it was established in 4th March 1851 officially, although we had our presence even before that. And now, in 2 weeks' time from now, we will be celebrating our 175 years, and 4th March that is. So, Geological Survey of India, that has been the major driver, you all may agree, for mineral discovery. And initially it was established for in search of coal, but later on, thanks to the foresight and dynamism of our founding fathers, so we did many remarkable things and diversified into all other explorations, including iron ore and manganese and chromium and base metals and limestones and all those things. And later on, of course, we changed our focus. And we are starting to, we have for the last one and a half decades or 2 decades, we are now focusing our attention towards the critical minerals. There is a list of about 30 minerals which have been identified with the government as critical minerals. They are necessary for adoption of the clean and green technologies. For the permanent magnets and the high-end electronics and EV and all those things, the special alloys, etc. So we need minerals of the rare earth elements and rare metals like lithium, cesium, and niobium, and maybe some titanium and graphite and cobalt and chromium and those kinds of elements we do need for adoption of clean and green technologies. And at this point, I'd like to say one thing, that GSI, of course, has changed its focus a lot, and GSI has understood the importance of geophysics also, because the superficial deposits, the deposits for which the geologist has access to sample, those deposits are nearly over. We possibly cannot search those minerals. So we have to search for deep-seated minerals now, and for that, geophysical input is a must. So GSI also has changed its focus, as I told you, and GSI on a large scale has been taking Project Uncover and regional mineral targeting and the national ground geophysical mapping and national aerogeophysical mapping. And we have been giving out many blocks for 150 blocks we have identified with the help of this national geophysical mapping and national aerogeophysical mapping. Also, we have been able to identify some deep-seated alkaline complex in South India. And we are also taking up national empty survey. And this morning I was listening to Professor Rao, and he was talking about the marine empty survey also. We certainly would look into that. I think I should not speak any further. Only thing I would like to say that one thing we got to possibly, because I am from geology, earlier times during our initial years in GSI, for mineral exploration, geophysics was not taken very seriously because the mineral deposits used to be rather complex and very irregular. So geophysics was mainly used to find out the hidden faults and terrain boundaries and deep-seated structures, so that way. But nowadays things have completely changed. In our marine also, I actually look after the operations of marine operations here. So for marine, geophysics is most important, as you know, because there is a water column of few meters to few thousand meters maybe. We cannot directly sample except from right from the seabed. So marine geophysics we have been doing right from the early 80s, and we produced some wonderful maps as part of the baseline data generation. And nowadays, we are once again, as part of the Blue Economy Initiative of the Government of India, we are again giving out blocks the marine mineral commodities are also there, and they're very important. I mean, the lime mounts, then phosphorites, and especially the manganese nodules, which contain this cobalt, chromium, nickel, and those kinds of elements. So what I mean to say that the opportunity is there for geophysics people to grab. I mean, they should take on the mantle and take the momentum, because now it is all hidden deposits. And yes, so with all my best wishes for a very profoundly successful seminar, I thank you all. And yes, I also put on record our sincere appreciation for providing us this stream of content. Very good geophysicists, and I hope that in future also we'll get all those things. So best of luck.
Okay. Thank you, Shri Sujit Kumar Tripathi, DDG, GSI Vishakhapatnam, elaborate explain about the geological survey of India. Now I invite Professor T. Narayan, Usman University. Please come forward, sir. Please address to the gathering.
Thank you, the organizers, especially Professor Naidu Garu, who has made a tremendous arrangements. I don't know whether he slept yesterday or last week, how many sleepless nights he has been doing. Respected Vice Chancellor, Honorable Chief Guest of this function, Sashbhushan Rao Garu, Dr. Prakash Chauhan, Director, NRSC, Sujit Kumar Tripathi ji, Shrimati Raj Garu, my teacher, and also Rajendra Prasad Virra Garu, and most importantly, the audience. They're all my seniors and also my colleagues. And on the right hand side, I can see juniors and students who are here. 50 years back, I was part of the student. I was participating in Silver Jubilee celebrations of the same university in 1975. I belong to 74 to 77 batch. So I was fortunate to be in the thing. I'm sure I would like to come back, sir, if you invite me for 100 years. Then my age will be 95 that time. Hope God will permit me. But somebody should help me because I may not walk that time. Thank you. Right, thank you. Just for a message, if you see our society, there are many doctors. So out of several MBBS doctors, we find 10 to 20% only will become MD doctors, MS doctors. Out of that, there will be super specialty doctors, like 5% from that. So our geophysics subject belongs to super specialty. Because every year, there are many graduations, but out of that, geologists or geophysicists are very special brand. So I suggest our Vice Chancellor to encourage this department in a big way with all types of infrastructure. I am sure And because the geophysics subject requires in all fields. Now, Prakash ji is telling that we have gone even to space. So space needs it. Our Tripathi says that they need water and ocean needs it. And definitely GSI is also looking at minerals. So we need land. So geophysics on demand on land, ocean, and also in space. Because they are super specialty, not either subject. Because there are many graduations, but geophysics in the whole India is very small. The second thing I would like to tell you to recall, in 1960s, if you see, how many IITs are joining from Andhra and Telangana? Very, very few. But there is a transformation after 60s because one of the major training issues have come, especially I can say Dr. Ramaya training issue. There are many 100 students from Andhra used to join IITs. So I'm sure our geophysics department of Andhra University and also Usmania University, where I'm presently working, will change the scenario of entering into competitive examinations like CSER NET, UGC NET, and also several competitive examinations and enter into that. These are all for people who are bright and who are excellent in academics. But you remember, I'm heading the startup companies. Majority of the startup companies in Usmania University, where 20 companies are working with me, they are backbenchers. They are highly successful. So whether you are a front bench in the class or backbench in class, doesn't matter at all. Success is yours, provided you increase your skill and increase your talent and then prosper. Thank you very much.
Okay. Thank you, Professor A. Lakshmi Mitra, sorry, Harinarayan Garu. So me and Vice Chancellor is supposed to leave as early as possible. We have some urgent meeting is there. We try to close it as early as possible. Now I invite Professor Lakshmi Mitra Garu, please come forward. Please address to the delegates, sir.
President of this meeting and the respected principal, Professor M.V.R. Raju, and respected Vice Chancellor of this university, Professor Sesibhushan Rao Garu, and the department, Professor C.V. Naidu Garu, and Dr. Prakash Chauhan ji, Dr. Sujit Kumar Tripathi ji, Professor Harinarayan, Professor Rajendra Prasad. Finally, the day has come to celebrate the Platinum Jubilee. But now I am feeling nervous to speak because this is not a classroom with innocent students. You are all great achievers, highly great people. So that is the reason. And there was mention of Bhagavantam Garu in the video message and other speakers meeting in Allahabad University for starting geophysics courses in the country. And also that the course was started in 1949. In the early years, there were only 4 faculty members. One, B. Janakramaya Garu, who went to Japan and did his PhD. And Professor B.S.R. Rao Garu was deputed to do research in England. Then V. Bhaskar Rao Garu went to Australia and did his PhD. Then V.L.S. Bhimsankram Garu went to England and did research. So these 4 people went to different parts of the world and brought in knowledge and expertise to the department. So in such a simple fashion, the department was started and the department grew. It was started in 1949, and then I was 3 years old. But by the time of Silver Jubilee, I was in the department, and I was also appointed as lecturer in the department in the same year, that is 1975. We celebrated the Silver Jubilee in coincidence with the retirement of Professor P.S.R. Rao, the first professor of geophysics. And thereafter, we have Golden Jubilee 1999 and 2000, Diamond Jubilee 2009, 2010. But those three jubilees are very different from the present Platinum Jubilee. There is no comparison at all. The Platinum Jubilee is going on a very, very high level and scale because of 2 or 3 reasons. One is WhatsApp connectivity. Earlier, the alumni are not connected among themselves. There was no WhatsApp. And the second reason, the faculty of the department headed by Professor C.V. Naidu have worked very well to prepare for this celebration. And Professor Naidu Garu gave liberty to everyone who works. So they have done a great deal. And I see that there is a lot of donations from the alumni, not only for this celebration, but also for creating laboratory facilities in the department for the use of students. Really, I am very, very happy to see the flow of funds from the alumni and elsewhere. Really great. So that's why this Platinum Jubilee celebration is very much different from the other earlier ones. And I was following the WhatsApp group. Many students, many alumni are coming to this seminar, and some of them are my students. I'm very eager to meet them, but there is one drawback on my part is that in recent times I lost my memory to a large extent, and I cannot identify them unless they are introduced. I already met many students, many alumni, and I'm very happy to see the love they extended towards me. I'm very happy about it. And later also I'll meet some more people. So after 3 Jubilee celebrations, the remaining one is the centenary. So I feel that all of you will participate in the centenary celebrations, and Professor Harinarayan also will come. So I wish you all the best. Thank you.
So thank you, Professor Lakshmipathraj Garu. Now I invite my Guru, Professor Rajendra Prasad Garu, please come forward and address to the delegates, sir.
Honorable Vice Chancellor, sir, and Professor Sesibhushan Rao, and our principal, Professor Raj Garu. He brought psychology when he was made as the principal of the Science College. He made justice to make sure that science and psychology are inevitable. They are integrated part of science. That's great. And similarly, our Professor Vice Chancellor is unique. Maybe most of us originate from the academic institution and then end up in the academic institution. And we always talk about academia-industry relation. Professor Sesibhushan Rao is an example to make sure
that industry came to academia and made the academia in a slightly different way. Similarly, one of our guests today, Professor Chauhan, I think he's the one who, with the basic training in geophysics, made a big dent, made sure that space is equally important. We talk about other subjects, geophysics plays a much bigger role. And I think the way in which he made it more practical in NRSC is a testimony to see that geophysics really flourishes in everywhere and it's a part and parcel of life. We always say water is elixir of life, but geophysics is elixir of life. That's where I think. And similarly to Tripathi ji, see, he's also really good in this particular aspect. So thank you very much, sir. And then I have all my friends here, Narayan, and Felicitation, Mr. Naidu, and then we also have Professor Salivahan, and then all other friends who are sitting here. Thanks a lot for giving me this opportunity. Sir, I think I'll just take 2 minutes. I know the time pressure. One of the basic things that this particular department was focusing right from the beginning was on exploration. And this department has developed a lot of love and affection to really see the earth with the eyes so wide open. We still remember Professor Mahadavan used to say that while you are in the field, you should keep your eyes wide open. That doesn't mean that you are in the field closing your eyes, but that really makes a sense that the way you should really examine or observe the earth was being very perfectly defined in those days. Similarly, all the teachers who have been in this particular department for right from Professor PSR or have been working very hard to make sure that field observations and using instruments for observing the field and trying to develop the information or numbers out of it and try to make modeling and then try to do the theoretical interpretations. All this was really integrated. That's where department as really distinctly different from many other departments where you have specializations in a unique way. But here it's an integrated way. That's one of the things which all of us, the alumni, has really got benefit. And the second benefit that we really have as of today is that the department's growth has really made us in the field observations, as I said, number one. But other observations, other fields, today we started with energy, we started with water, we started with so many other things. And sustainability became one of the major issues now. And from that particular point of view, I'm sure the younger generation should be focusing more on all these sustainable aspects of geophysics and its courses. And I'll not take much time. The only thing that we should really focus, the younger teaching staff as well as the students, should focus on the application of geophysics for sustainability of all the resources and the systems and the processes. So I think with these few words, I'll not be here maybe with taking too much of time. And I thank all the organizers for giving me this opportunity and the great galaxy of our alumni visiting this department after 75 during this occasion of these 75 years of its celebrations. Thank you very much, sir.
Thank you so much, sir, for Sarajamata. Now we are moving into seminar release. I request all the learned delegates, please come forward and release this album song. Now I invite my beloved Vice Chancellor, Professor Sajibhushan Rao, please come forward and please address to the delegation.
distinguished guests, respected dignitaries on the dais, retired faculty members, proud alumni of Geophysics department, scholars, students, members of press and media. Good morning to everyone. A warm welcome to Andhra University, a 100-year-old institution that will celebrate its centenary in 2026. This university is a historic university with rich legacy spreads over 100 years. It's wonderful that we are also celebrating the Diamond Jubilee of Department of Geophysics this year. Delighted to see all students, faculty, retired faculty, alumni, renowned professors, esteemed professors who are all retired. Other departments also, GR is also professors of MC. Together here today to discuss some important aspects of geophysics advancement techniques in the geophysics area. Here I would like to mention only one point here, as we are running short on time. We all know that in the coming years, artificial intelligence, machine learning, and augmented intelligence will play a significant role across industry, service sector, and in all disciplines, starting from engineering to politics, public administration, history departments also. Please remember. So it is very important for us to gain skill sets in this area to stay relevant and competitive. Please remember. I would like to mention one more point here. In the past, if you see, we have supercomputers. They were not able to distinguish or identify between two things, tiger and cat. Even if you cascade the performance of several computers, they were not able to identify a particular cat or a tiger. They cannot say which one is cat and which one is tiger. But now if you see, a small computer is able to say that which one is cat and which one is tiger. The reason is, can anybody tell me? The reason is, before I tell the reason, I will say the importance of our human brain. Human brain has got 100 billion neurons, and each neuron will act like a tiny computer. Almost you can say a small piece, with a powerful i5 or i7 processor. That many computers you have got in your brain. And they all these neurons, you can call it as a computers, they process the things in a parallel way. And we have a trillions of connections inside to connect these neurons. And it's a big network which will process all the things in a parallel way. That means it's a parallel processing concept. So what happened to this supercomputer to distinguish between the cat and tiger nowadays only? You all know that ChatGPT, ChatBot, everything has come up now. Why now only? Earlier also there were supercomputers. The reason is mimicking of human brain functions introduced recently only into the supercomputer. That was made possible in recent times only. And please remember this, we were able to introduce these techniques into the supercomputer, that is mimicking of human brain functions into the supercomputer, 1% of the brain capacity only. You may wonder if it is increased to 10%, what will happen? So such a powerful things are going to come. Please remember, to stay relevant and competitive, it is very important for us to gain skill sets in AI, GANs, augmented intelligence, whatnot, everywhere. Okay. And Andhra University is going to introduce dual degree programs and double degree programs in science and arts colleges also. The concept is, as per the new education policy 2020, a geophysics student can acquire physics degree also, MSc degree. 50% credits he can acquire in geophysics and 50% credits he can acquire in physics department. So that he will get, in 2 years' time, he will get 2 degrees. One is physics department, physics degree, MSc physics. Other one is the MSc geophysics also. Or if you want some MBA or MCOM degree also, you can go. Cross field also, it is possible. And one more point is, he need not stay in the university for the entire 2 years period. Within 1 year also he can complete his degree, or within 3 semesters also he can complete his degree. So that flexible time period flexibility also we are introducing. And this flexibility has been already introduced in our engineering college. So every engineering graduate, other than computer engineering, is getting 2 degrees. A civil engineering student is getting computer science degree, and a computer science engineering student is getting ECE degree also. So that facility, that scheme has been introduced already in engineering college. So same thing we are going to introduce in other constituent colleges also, science and arts also. I look forward to insightful discussions and productive ideas over the next 2 days. Since we are already short on time, I will keep this brief. I hope you all have wonderful learning and enriching experience. I wish the event a great success. Thanks to you, HOD, principal, and all other dignitaries who have come here. And thanks for having me here. Thank you.
Thank you so much, sir. Now, felicitations to the guests announced by Blissy. Please, Blissy, please pass to. We're supposed to leave, please.
Now we come to the most awaited part of this inaugural session, the felicitation ceremony. I quote Helen Keller, "The best and the most beautiful things in the world cannot be seen or even touched. They must be felt. Thank you is one among them." I unquote. It is a privilege to honor the distinguished personalities one by one to receive the token of our gratitude. It is indeed a moment of great honor and privilege to felicitate an extraordinary leader, a visionary academician, and a guiding force in the world of education, our Honorable Vice Chancellor, Professor G. Sasibhushan Rao. I now request Professor M.B.R. Raju and Professor C.V. Naidu to kindly do the honors and felicitate our Honorable Vice Chancellor, Professor G. Sasibhushan Rao, with a token of our highest respect and appreciation.
చెప్పేసి పంపించి నా దగ్గర వచ్చారు. వాళ్ళు కావాలంటే నా దగ్గర తీసుకురండి. ప్రిన్సిపల్ హౌస్ తీసుకురండి. ఇక్కడే ఇక్కడ వచ్చి మనం
Ladies and gentlemen, let us extend the deepest gratitude with a grand, resounding applause. It is my honor to invite Sri Sujit Kumar Tripathi for felicitation. I now request the dignitaries to kindly do the honors and felicitate Sri Sujit Kumar Tripathi. I earnestly invite Professor M.B.R. Raju and Professor C.V. Naidu to felicitate Professor T. Harinarayana, Osmania University. Ladies and gentlemen, let's recognize their efforts with a well-earned round of applause. It's a moment of great honor to felicitate Professor A. Lakshmipati Raju, retired professor, Andhra University. It is my honor to invite eminent Professor P. Rajendra Prasad for felicitation. It is my privilege to invite the Robert word of thanks by Dr. Anand Gajapati Raju.
He's supposed to the host.
So good morning, all of you. I'm Dr. Anand Gajapati Raju, Assistant Professor in Geophysics. It is both an honor and a privilege to extend our profound gratitude on behalf of the Department of Geophysics and myself as we formally conclude this inaugural function. Today, we have assembled to commemorate the Platinum Jubilee of our esteemed department and to partake in the National Seminar on Advances in Geophysics for Sustainable Development, Energy, Environment, and Natural Resources, AGSEEN. This significant occasion has been enriched by the presence of distinguished dignitaries whose valuable insights and participation have greatly contributed to the success of this seminar. At the outset, we express our deep appreciation to Professor G. Sasibhushan Rao, Sir, Honorable Vice Chancellor, Andhra University, Visakhapatnam, for gracing this occasion as a chief guest and for his esteemed presence and encouragement and message. We extend our special gratitude to Dr. M. Ravichandran, Sir, Secretary, Minister of Earth Sciences, for his invaluable message conveyed through video for the Platinum Jubilee celebrations and the National Seminar. We are profoundly thanks to Dr. Prakash Chauhan, Sir, Director, National Remote Sensing Center, NRSC Hyderabad, for inaugurating the Platinum Jubilee celebrations as our distinguished guest and for sharing his invaluable expertise. Our sincere gratitude to Sri Sujit Kumar Tripathi, Deputy Director General, Geological Survey of India, for inaugurating the National Seminar and for his esteemed presence as a distinguished guest. So we also express our heartfelt thanks to Professor Harinarayan, Sir, Usmani University, and Professor Rajendra Prasad, Sir, Department of Geophysics, Professor Lakshmipati Raju, Sir, Department of Geophysics, for honoring our invitation as a guest of honor and for their significant contributions to this event. A special thanks, special acknowledgement to Professor M.V.R. Raju, Sir, Principal, A. College of Science and Technology, for presiding over this seminar as a president of this national seminar and for his unwavering support. We extend our sincere appreciation to former professors of the Department of Geophysics and esteemed faculty members from the Department of Andhra University for their gracious presence and encouragement. A special thanks to our Professor Jagannath Rao, Sir, former Vice Chancellor, AKNU, for valuable guidance to our geophysics students. Our heartfelt thanks to all the scientists, academicians, researchers, and students from esteemed institutions and organizations including CSIR, NGRI, NRSC, GSI, State Groundwater Board, IIP, IAG, ISR, ONGC, Minister of Earth Sciences, IMD, NIO, NABARD, INQUIS, All India, IITs, and AMD and private geophysical and geological organizations for their enthusiastic participation, which significantly contributed to the success of this seminar. We are deeply grateful to Minister of Sciences, IMD, Inquiries, NABARD, IAG Mumbai, AU Geophysics Alumni, Association of Hydrologists of India, CSIR, NGR, ONGC Rajahmundry, CGWB, and NCMR, WF, NRSC, AMD, and Andhra University for their generous financial support, which played a crucial role in making this event possible. A special note of gratitude to Professor Sri Naidu, convener, and other co-conveners for their remarkable efforts and outstanding support in ensuring the smooth execution of this event. We also extend our sincere appreciation to the media representatives for their extensive coverage and broadcasting this seminar, ensuring wider outreach for the discussions and deliberations. Finally, we express our deepest gratitude to the Andhra University administration for unwavering support, financial assistance, and for providing the Dr. YVS Murthy Auditorium at the, as the venue for this prestigious seminar. Once again, we extend our sincere thanks to each and every one of you for presence, participation, and invaluable contributions in making this event a grand success. We eagerly look forward to continued collaborations, engagement in the future. Thank you. After the tea break, keynote addresses Dr. Prakash Chopal sir, first keynote. National level.
Now let us conclude the inaugural session with the national anthem. I request everyone to kindly rise for the national anthem.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल गंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
We welcome you all to the keynote address by Dr. Prakash Chavan on satellite systems for sustainable development. Dr. Prakash Chavan obtained his postgraduate degree in applied geophysics from University of Roorkee and PhD in physics from Gujarat University of Ahmedabad. Prior to joining National Remote Sensing Center, Hyderabad, he was a director at the Indian Institute of Remote Sensing, Dehradun, since April 2018. He joined Indian Space Research Organization in 1991 at Space Application Center, Ahmedabad, as scientist and since then working for the applications of space technology, including remote sensing technology for geosciences, atmospheric and oceanic process studies, natural resources management for ocean and land resources. He initiated research activities for planetary remote sensing to study solar system objects, mainly Earth, Moon, and Mars, through Indian planetary missions. His major achievements are in the area of Earth observation applications, including development of algorithms for ocean color parameter retrieval, aerosol remote sensing for space-based air quality monitoring, climate response to various ecosystems, and disaster risk reduction. He has done lead work in using the hyperspectral satellite data for Indian planetary missions such as Chandrayaan 2 and Chandrayaan 1 for lunar surface composition mapping. He had been the principal investigator for infrared imaging spectrometer instrument on board Chandrayaan 2 mission. His work on Chandrayaan 2 IIR spectrometer data has resulted in unambiguous detection of H2O and OH on the surface of the moon. His findings have conclusively established presence of water molecules at different locations on the moon. He is currently serving as chair of the working group of whole at STSC of UN Committee on Peaceful Uses of Space. He has also served as chair for CEOS working group on capacity building and data democracy for the year 2018 to 2019. He had also been member of prestigious NASA ISRO Planetary Science Working Group. He has been awarded with Asia Pacific Region Excellence in Space Award 2023 by Asia Pacific Regional Space Agencies Forum, Professor P.R. Pisharki Memorial Award for the year 2004 by Indian Society of Remote Sensing, Hari Om Ashram Prairie Dr. Vikram Sarabhai Research Award by Physical Research Laboratory Ahmedabad for 2009, ISRO Merit Award by Indian Space Research Organization in 2010, and Satish Dhawan Award by ISRS Dehradun for 2016. He has published more than 150 peer-reviewed papers in national and international journals. He is elected as corresponding member of International Academy of Astronautics 2024 and is currently fellow of the National Academy of Science, Allahabad, Indian Society of Remote Sensing, and Indian Social Science Academy. With immense pride, I invite Dr. Prakash Chawal to come onto the stage and deliver his address.
Somebody will change slides. Good morning, good afternoon to you all. You will change. Good afternoon to you all. I think you are all going to just settle down after the nice inaugural function and a tea break. Nonetheless, I think since we are running out of time, I would like to just share some thoughts for next 30 minutes or so on this very important topic, which is development, which happens to be the theme of this particular talk, where we are going to talk and listen various talks on sustainable development of energy, minerals, and then of course environmental conservation. As I told in the morning that space systems also plays a very important role along with the in situ data collection mechanism in terms of achieving the goals of sustainable development. So I will just tell you and share that some of the experiences which we have gained over the years as far as space-based applications for sustainable development is concerned. Next slide. Now, just for the sake of young people, that when we say sustainable development, what is sustainable development and why we have to use space or satellite-based technology? So sustainable development is the development that meets the need of the present without compromising the ability of future generations to meet their own goals. So it is very pertinent that whatever resource utilization we are doing today, we need to leave it to our future generations. So classical case is groundwater exploitation. In many of the states in this country today, we have situation where groundwater depletion is a real concern. And if we don't wake up today and do water conservation strategies, it is going to be really difficult for future generations to get and to use this resource of groundwater as far as the future availability is concerned. So to meet such kind of challenges, United Nations has come up for most of the countries. The sustainable development goals have been identified. There are 17 such sustainable development goals, and many of them pertains to some of the work which we are going to discuss in this particular conference. I will not go into details of that, but the major thrust areas are in terms of achieving socio-economic security for food, water, energy, health, shelter, infrastructure, and information. Then, of course, disaster risk reduction. In the morning, we talked about changing climate, and which is leading to new kind of disaster scenarios. So, preparedness, early warning, response, and recovery. In all these phases, we need to take decisions based on the data sets which are at our end. And of course, in terms of providing the proper governance using data-driven approaches for planning, monitoring, evaluation, and decision support system. So in all these aspects, the satellite-based Earth observation data, or popularly we call remote sensing data, is going to play a very important role. And I will give you certain examples in case studies. And of course, the another satellite system called GNSS, or Global Navigation Systems. Typically, one of the system popularly called GPS system, which is an American system. India is also planning its own, or already we have put up our own system called NAVIC, which is a regional navigation system. Without navigation, also today, you cannot achieve many of these sustainable development goals because you need precise positioning for doing any mapping, surveys, as well as resurveys of various, for various purposes. So GNSS also becomes a very important aspect. So both Earth observation and the GNSS technologies are providing key inputs for sustainable development in various aspects. Next slide. Now, if you look, morning itself we were talking that we are having ambition to become Viksit Bharat. So if we have to become developed country in next 25 years or so, there are large challenges which we are facing, and some of these challenges needs to be addressed in terms of achieving the SDG goals. Essentially, we are going to have a larger population than what we have today, with 50% of people are going to live in urban areas. Food grain production has to be around 345 million tons. Rate of depletion of groundwater is also likely to deteriorate if we don't take corrective actions today. And that we need to contain the temperature rise up to 1.5 degrees Celsius or so. But friends, let me tell you that we have already crossed, around 1.5 degrees Celsius. So containing the temperature rise, especially for a country like India, which already is now touching around 1.3 to 1.35, is really going to be a challenge. And we have already, declared that India wants to achieve net zero emissions by 2070 or so. So that's a very critical goal which we need to, put amongst ourselves. And of course, increasing disasters are also going to be a cause of concern for a lot of issues related to, economic development. So we need to prioritize. We have to have enhanced agriculture production, water availability, minimize land degradation, bioresource conservation. Improved weather forecasting and disaster resilience is one key aspect where space is providing critical data. As morning people were talking, I just told that we have to cut our GHG emissions by 43% by 2030 and make it net zero by 2070. Clean air, clean water, and of course, providing internet connectivity to all, high-speed connectivity to all the citizens of the country, even in the remote areas, is a key priority area. Without connectivity today, earlier in our age, when we were growing up, we used to listen slogans, roti, kapda, and makan. Aaj roti, kapda, makan, or internet. Without internet, you cannot live. So that is also very much required as a resource. But none of this will be possible without securing our borders also. So we have, on both eastern and western sectors, challenges, and of course a long coastline, as I told you, around 10,000 kilometers plus maritime zone to, secure. And for security and sustainability, security is linked with sustainability. For that also, space systems provide critical inputs for our defense installations. So overall, to better understand Earth as a system, its processes, and to combat the upcoming challenges of climate, along with the ground-based data systems, space systems becomes very important in achieving some of these SDG goals in futures to come. Next slide. Now, just in a very short time, I will give you the glimpse of India's space program. See, we started our space program in '69 or so. Today, we are one of the fourth or fifth largest space agency in the world. We have complete self-dependency in launching satellites, building satellites, as well as operating those satellites in various orbits around the Earth. We can launch satellites into the low Earth orbit. We can launch satellites into geostationary orbit. We have demonstrated that we can go to the moon, we can go to the Mars, and we can also go to the Lagrangian point to study our solar system, like some studies being done by Aditya L1 Observatory. With all these kind of missions, I will not go into detail. This all has been achieved because of our policy, which was adopted by the forefathers of Indian space program, like Professor Vikram Sarabhai, what we call today as Atmanirbhar Bharat. That Atmanirbhar concept we started almost 70 years back. That has led to the totally indigenously developed space program, well within the framework and budgetary constraints of Government of India. So that's, I think, a very great achievement, and it needs some applause also, I think, from this audience. But these satellites and the space systems which we are sending into space is not to show to the world that we have developed this technological might. Ultimately, these satellites are sent for some purpose. And in most of the cases, when they are sent around the Earth's orbit, they serve basic purpose. And many times, people are not aware that after launch, what happens to the satellite and how their data is being used. That story I would like to just tell through this another 25 minutes or so. Next slide. Next. So today we operate around 55 satellites, 25 satellites in Earth observation. That's for remote sensing, observing Earth in different part of electromagnetic spectrum. 18 communication satellites. Most of them are in commercial domain. You get all your DTH, services, television channels, news feed, and all. And if you are in high seas, many of your oceanographers, if you are in Antarctica, you need to talk to your home. You have to connect through satellites only. Then, of course, 9 navigation satellites for providing PNT services, position, navigation, and timing services. It includes, the new mobile sats will also come with Narwhal-enabled chips. So in your mobile phone also, apart from GPS signals, you are also likely to get now the Navik signal, Indian PNT services. And of course, space exploration mission, much hyped missions like Chandrayaan 1, 2, 3, and of course, upcoming Chandrayaan 4, 5, Mars mission, exploration missions for Sun, etc. That's another domain of work. But today I won't talk much about it. I will be mainly focusing on the Earth as a planet. Next slide. So all these satellites which we are launching today, they have varieties of societal applications in all spectrums of life: communication, monitoring natural resources, meteorology, environment and climate, strategic services, geospatial services for mobility, for companies which are sending even pizzas and stuff to your home. You may not realize, but they use space technology today. If you give your location, a person who is going to deliver pizza, he has to track you on your map or a digital map. All maps are digital. And every 6 months in a country like India, which grows 6 to 7% rate, some new building comes up. So you need to have, there are a lot of people who are updating these maps, and that is done using satellite data. So to a new building, if you shift, that building has to come up on your map. That happens through space, and that person reaches through this navigation system to your home. So even a picture delivery needs space technology today. So that's the level of penetration of space technology as far as user space is concerned. Next slide. So as far as the Earth observation or remote sensing is concerned, India operates their remote sensing satellites in 4 categories. The natural resource inventory satellites, they are what we call as the medium resolution satellites, which provides you capability of 3 meters to up to 100-meter resolution. That means one picture elements corresponds to that much of ground sampling distance, so that you can see the details. We also have large scale mapping, that is very high resolution satellites, which is having imaging capability of 30 centimeters or so. I will show some examples from space. Then, of course, oceans are very important because 70% of the oceans, the planet surface is ocean, and ocean is not only very important in terms of biological or geological resources, it also basically regulates the climate of this planet. So we need to understand. So we have ocean color monitor, which measures the reflected energy from the ocean surface in around 13 wavelengths. As of course, we have another instrument called scatterometer, which basically gives you measurements of the wind speed from space, which can be used for assessing the potential cyclones and how the wind flows are happening over the oceanic surfaces. And of course, we have 3 satellites to monitor weather, and which long term becomes the climatic data. This INSET series of satellites, they operate from 36,000 kilometers. Today, every 15 minutes, we can observe weather patterns over India, and using this data, we can derive 20 various meteorological parameters using these satellites from imager and sounder kind of capabilities. So this is the overall capability today, and various applications we have listed in that column, but I'm not going to read that. I will show you some of those examples. Next slide. So one more thing which has happened in last year or so, that many times earlier, the accessibility to the satellite data was very limited. Many of you must have also experienced and complained that you don't get data from NRSC. NRSC was, many times, you must have hated also. But what has happened, it was not NRSC, it was because of the policies of the government of India. Now, last year, India announced what we call the new space policy of 2023, which has enabled now the availability of all the satellite data 5-meter coarse resolution from Indian satellites without any restriction to anyone. Anyone means even a private citizen, government entity, private citizen can access this data freely from NRSC's portal called Bhunidhi portal. And now we have enabled it. Last year itself, maximum data downloads have happened, and the growth, significant growth has happened in the academic sector. The student community and the academic community, tenfold increase in the users has happened because, earlier they may have to pay money, but now things have become free. So naturally they can use it for their research purposes. So all of you not only can download concurrent data, but archive 35 years of old data to understand land use, land cover changes, how things have changed over India is also accessible through this portal, thanks to the new space policy which was announced last year by Government of India. Next slide. So these are some of the examples of this high resolution data which we get from our satellites. So this is over Delhi. You can see the new parliament over there, besides the old parliament, and you can see the cars which are moving on the Rajpath and the details which are amenable. This is a 30 centimeter satellite image taken in color from space at an altitude of 500 kilometers or so. Next slide. This is another example. We take this, what we call as the black and white panchromatic imagery and color imagery courses. We merge them using certain image processing technique, and this high resolution pan sharpened 30 centimeter images from space. They are basically available to many of you today because of this new space policy. Next slide. Apart from this optical imagers, they basically the imagers which you see in the optical range and the infrared range of electromagnetic spectrum. There are difficulties during clouds and all, you cannot see through. So we have also developed microwave synthetic aperture radar satellite systems which can see through cloud. They have day and night imaging capability. So one such satellite is currently operating. It is called RISAT-1A. This data is also can be accessed. And these are some of the examples of this RISAT-1A data in the radar imaging domain. Next slide. Apart from this two-dimensional beautiful photograph of the Earth, we also have capability to derive the third dimension, that is the topography, using the satellite system. So using one of such satellite system called Cartosat-1, now entire India Cartosat digital elevation model at 2.5 meters spatial resolution is available from NRSC. And then you can discern, the topographic variation using this data. We also have aircrafts and UAV. So if you want even 50 centimeter contour, we can generate it using our UAVs and the aircraft depending on your need basis. So that's one of the topographic information over a mine just across border in Pakistan around Jaisalmer area. And you can see those red colors are sand dunes, but that blue thing is basically a coal mine where large amount of excavation is happening and overburden is dumped at that red spot. So that is the capability. This mine is, by the way, 200-meter deep, just across Thar Desert. They found lignite with the help of Chinese. Next slide. I thought sitting in Vizag, using this three-dimensional data, I will take you to glaciers. Gangotri, you can have a virtual darshan. Today is the virtual world. So now we are flying over Gangotri Glacier. And this is the 3D, fly through as if you are flying in a helicopter. Now you are reached Gomukh. And you can see the morphology of a glacier. This is Gangotri Glacier, how it looks like. You can see the different crevasses patterns, and then as you fly towards the upper reaches of Gangotri Glacier, you start seeing the fresh snow accumulated at higher reaches. So not only these are beautiful three-dimensional, fly-throughs, we call them digital twins. This technology helps you in generating digital replicas of many ecosystems into your computer. You can calculate the slopes, you can calculate the hindrances. If you have to lay telephone towers or communication towers, this data becomes very important in doing line of sight studies. Many applications are there for digital elevation model. If you do a flood routing, you need to know the slopes, where the water is going to flow. All this, applications of hydrology, disaster management, stuff like this gets solved with the help of this type of three-dimensional digital twins, which are generated with this 2.5 meter Cartosat digital elevation model data for entire country. Next slide. So those high resolution and medium resolution images which I showed, they are just not pretty images, but when you combine them with some algorithm, some methodology, they become basically information source for extracting large information about food security, water, energy, information, and various aspects of life today, leading towards what we call as the Sustainable Development Goal achievements. Next slide. So there are specific examples of applications in agriculture. Today we are using to use this data to monitor the agricultural droughts. We are basically mapping 11 major crops of this country. How much area every year is there under a crop, let's say a rice crop or a wheat crop. If there are deficiencies in the crop, the sown area, which will lead to crop productivity, export-import decisions by government of India is done through these data sets. There are, schemes of government of India called Krishi, Pradhan Mantri Krishi, Bima Yojana. So the crop insurance settlements, are getting settled through knowing that how much crop damages have happened post-cyclone or post a hailstorm or post any severe weather event. All that is now put in place with the institution which ISRO has institutionalized in Ministry of Agriculture called MNCFC, Mahalanobis Crop Forecasting Center. They do all these activities on a systematic basis. Next slide. So there is a big program of Government of India is called Digital Agriculture Stack Generation. At parcel level today, that in all 29 states, they want to generate the digital stack of all land holdings in India. And this shows you, this is the satellite image over which we have overlaid the land parcels and the revenue numbers of in the state of Gujarat. A big exercise by the Department of Land Reform is going on to do this kind of digitization of land records of India for agriculture fields across all 29 states, and NRSC is providing this high resolution data to the people. By the way, there is one small story with this image. This was basically done for income tax department. Many of you may be finding it very funny that why income tax and remote sensing of satellites has to do. So one day we got a call that commissioner wanted to take our help. It's a bit scary to get a call from income tax people. That took he told that a lot of people in our country, they use this, agriculture income exemption business, for doing some hanky-panky things. So he gave us these land parcels details and asked us to monitor them for 1 year, just to tell whether any kind of cropping is done or not done. In most of the cases, they are all lying barren, no color. And they all were caught, their income tax claim got rejected. So in case of income tax also, satellite data is being used today. That is another way of looking at a sustainable revenue generation model. So this is the kind of, penetration of space technology. And as they say that Upar wala sab dekhta hai. So nowadays Upar wala is also satellite. Is also there. So that light, nothing is hidden with the eyes of satellite today, including your income tax business. These are some of the key areas. I will not go into details of this. The slides are available. If some of you wants to take a copy also, you can take it. Next slide. This is another very important aspect. Some of you, all of you are eating rice, but many of you may not be knowing from where this rice is coming to your plate, especially today's young generation, those who don't go to villages. I'll tell you, just see this map. This is 2023. The total rice production in India, as mapped from satellite data, this all yellow color dots, all yellow color areas are the rice producing regions in the country. Maximum production of rice happens in Punjab, Haryana, Western Uttar Pradesh, Eastern Uttar Pradesh, Bihar, Chhattisgarh, West Bengal. Then, of course, you have Orissa. Then, of course, where we are sitting now, your famous belt of Kaveri and Mahanadi and Krishna Godavari Delta in Andhra Pradesh, and then of course Kaveri Delta in Tamil Nadu, and some small patches in Karnataka and all. So using this has been done by combining thousands of satellite images, processing in an automated manner on a completely self-driven process, no manual intervention. So such type of algorithms are being developed today to extract this information by realizing billions of satellite images and to produce this maps. Once you have these maps, you know how much a crop is going to be there, how much is likely to be the productivity, and this becomes very crucial for food grain management in the country. Next slide. Similarly, these are examples of yield estimation, how much crop production is likely to happen at the Gram Panchayat level. Today, this data is becoming very important for, as I told, for crop insurance works. Next slide. Water, food is there, then you need a water also. Without water, nothing is possible. So water resources is another very important area. Many of you are hydrology students. Today, satellites provide you information about irrigation potential, water transport, surface water storage, dynamics, snow cover, snow melt, reservoir inflows. All these spheres today, space technology provides key inputs as far as decision making is concerned. Next slide. I'll give you one example here. Next. This is basically, we have developed what we call the water spread meter. All major reservoirs of the country, every 15 days, we provide the water dynamics, how the water availability in the surface reservoirs are changing. This is available online. You can see on Bhuvan National Hydrology Program, any status of any reservoir, how it is changing. You can see how it depletes and how it, grows up after monsoon. This is the story of last year in 24. There was a big problem in Bangalore city. Bangalore city gets water from this Krishnaraj Sagar reservoir. And in August 22, it was having 10,000 hectare water. But by the time February 24 came, the water spread reduced by half. And that led to large amount of deficiency of water availability in Bangalore city. And this data becomes very crucial for the people, those who are managing those reservoirs and alternate water sources. So this water spread meter provides a very critical decision-making support for water managers across various states in the country. Today, this is an operational service. Next slide. Similarly, snow melt runoff, is very important because most of the North Indian river in Bhagirath, in Indus, in Ganga, and in Brahmaputra river, they get their water by melt of the snow. And this is very important for many hydropower plants in that particular area because a lot of electricity generation happens. So we have a modeling scheme which tells you that in which particular basin, how much snow melt water is going to be there. And this data is being used by a lot of small and mini hydropower electric companies on an operational basis. Next slide. Another threat which is there due to climate change in Himalaya is the expanding glacial lakes. I am showing you an example of one of this glacier lake. These are all glaciers. All this blue color thing which you are seeing rapidly expanding is a glacial lake imaged over 30 years, but put in 30 seconds, what we call is the time-lapse imagery. So you can see that how rapidly these glaciers are melting. The glacier is going back and the solid ice is basically leaving way to the water. So we have mapped around 26,000, 28,000 such glacial lakes which are having area of 0.25 hectares and above in the entire Himalayan basin. NRSC has produced these atlases river-wise, basin-wise. But it's not that inventory. We are also monitoring them periodically and found that many of these glacial lakes are vulnerable to what we call the glacial or lake outburst flooding, GLOF events. Next slide. And one such GLOF event happened next in 2023 in Sikkim, the South Lonak Lake. This is how the South Lonak Lake setting is. And over 30 years, the South Lonak Lake has tripled in size. The area of the lake has increased consistently because of the melting of the glacier, South Lonak Glacier. And on 4th of October last year, there was a breach of this glacial ice into the lake, and half of the lake, as you can see, got filled with this debris. And all that water got spilled out, and it created a flash flood, which has led to more than 200 people losing their life in the Tista River basin there in Sikkim. So that night itself, we started getting calls. Luckily, we had a satellite imagery that day, that too microwave imagery, because it was cloudy, and we could tell to the government that what really has happened, as you can see yourself. And then, of course, a lot of analysis has been done on the cause and post-mortem of this event. But the lesson which this type of things have shown that we need to develop an early warning system which can tell us that, and monitoring of this glacial lake. So now in 9 Himalayan states, 190 such lakes based on this data have been identified by different governments along with the NDMA, where now early warning systems are going to be set up with the help of satellite imagery as well as ground-based instrumentation to give any forewarning about some of these potential GLOF events. Next slide. Water underground is also very important. Many of you are geophysicists, you are all experts of this, doing resistivity surveys, stuff, etc. But in areas like Rajasthan, where you cannot blindly go and do resistivity survey, satellite data helps you in identifying, what we call as the prospect zone. So what you see in this blue line is an area, what is called as the paleo channel area, which has been demarcated on a satellite image. Paleo channels are the past conduits of groundwater flow, and typically they will show the vegetation anomaly. There is a sparse vegetation over this channel, and that becomes very important to pinpoint and then go to the ground and do the geophysical survey. And this is the resistivity survey was done on that area, and precise location of the groundwater points were done, which leads to substantial reduction of cost in terms of doing these surveys. So this tells you the role of satellite data itself in finding out the prospect zones and then doing the geophysical survey for very accurate delineation of groundwater. So for students, those who are working in this field, you can integrate various technologies so that you can optimize this resource and then get sustainable use of different technologies. Next slide. Next. As I told in the morning that we need to move away from hydrocarbon-based economy to renewables. So we are now mapping the solar irradiance. Using these satellites, we can map that how much amount of solar irradiance is falling at different places. So this is the solar irradiation map in different seasons. So what you see in the red color is more solar energy, and in blue color is basically less solar irradiance. It can happen due to cloudiness and all. You will see in monsoon period, you get the low solar irradiance. So based on this data analytics, we have come out with what we call as the solar potential zone of India. All these blue color regions are throughout the year consistently high solar irradiation you get. And in the yellow regions and all, you get the lesser, especially northeast area and all. Based on that, we have developed what we call as the solar calculator. If I want to install a solar plant here in Vizag in your campus, by using this app and link with this data, it will tell you that how much solar potential every month you will have at that location, which helps a lot of people to develop now the solar parks, etc. And then use of this geospatial data in energy applications is also enhancing. Similarly, India is also, working extensively on what we call is the, we have our Honorable Prime Minister has declared a mantra called Panchamrit. Here, one of the key elements to generate energy is the residue or the bioenergy. Every largest producer of the crops actually, and huge amount of residue is produced in the country. In Punjab, Haryana, after kharif crop, they are burning it also. But if we can harness this residue for energy uses by putting industries and then by doing palletization and then converting into controlled, uses, this is what is the energy potential or bioenergy map of India looks like. In the violet color, you see the maximum potential of bioenergy states. Of course, states like Rajasthan, Kutch and the central area, they don't grow much vegetation. So based on this data, now with the Principal Scientific Advisor's Office, we are working out on strategies of bringing private sector people to harness this, residue for bioenergy generation. Next slide. Next. This is another interesting application of remote sensing data and machine learning I was telling you. This is how a solar farms looks like in a satellite image. This is one of the solar farm in Badla Solar Park, 56 square kilometer area, 2,200 megawatt power is going to be produced. This is how it, periodic images. In 2016, when the plant just work started, very small patches, and this is how you can monitor, or the industry themselves is monitoring the growth on the ground, how the solar park is developing. And based on this type of high resolution images, training a machine learning approach, we have now calculated the total installed inventory of solar parks in India. All in blue color, you see solar parks which are greater than 10 hectares are plotted based on machine learning approaches. So in one shot today, I am able to show you using satellite data that where are the large solar farms are there. So you think of Rajasthan, you think of Gujarat, but maximum solar parks have come up in Telangana. This is a discovery. It's a news and good news for this region that this is the inventory looks like. What you see in the background color is the potential, the solar potential which is available in different states. Of course, Northeast, as I told you, has less potential because of the cloudiness, more cloudiness in that region. But still, based on this data, there are a lot of gaps, and people can, NRSC has also produced wasteland atlas of the map. So wasteland data, along with this solar potential data, and then the gap analytics, still we have a huge potential to generate solar energy. India is doing fantastically well, but using this type of, data sets, we can enhance our production of solar energy in a significant manner. Next slide. Of course, disaster is one such area where, a lot of inputs we are providing from space. I will not go into details of it. Next slide. For cyclones, floods, forest fire, drought, there are operational, products which are going from NRSC today for various stakeholders. Next. This is the flood maps. So, near real time and within 3 hours of data acquisition, we provide flood inundation maps to various stakeholders. This is the floods of Punjab in 2023. Next slide. Then, of course, we can also map what we call for many of you geophysicists, the deformation, which is associated with the tectonic activities, like, the events of what has happened in Joshimath. So we have mapped using interferometric SAR, the entire deformation pattern of the Joshimath town. What you see in the red color there is the areas where the ground subsidence was very high compared to the surrounding areas. And there was a GPS receiver also in that region. So you can see this black line is basically the GPS measured deformation rate in Joshimath, and that the other lines, what you see is basically the satellite derived. GPS will give you only a point location, but we can give you a picture of around total area. This data becomes very important now. Any future rehabilitation, reconstruction in this area, they should use this for doing the risk analysis for possible future, subsidence related activities. So this work is happening on various cities today, including the groundwater-based deformations, which are happening in multiple cities across the country. So this becomes a very important aspect as far as the geophysical or the geoengineering technologies are concerned. Next slide. Of course, meteorology, many of you are into meteorology also. As I told you, we have this, satellites which can give you 15 minutes images. and 30 geophysical parameters, wind, rainfall, surface temperature, etc., etc. Next. So using this our radar, we can map, when the cyclogenesis starts. Every 2 days we have this, satellite data availability. 5 days in advance, we can predict now when a cyclone is emerging or likely to get developed in Bay of Bengal or in the Arabian Sea using this type of radars. We are going to launch one more satellite so that we can have everyday coverage from space as far as the wind patterns are concerned. Next. Of course, blue economy, morning people talked, we are generating a lot of inputs to understand biological productivity of oceans. Next slide. This is the most interesting, the recent work which NRSC has done to produce phytoplankton map of the globe, of the full world, using our OceanSat-3 satellite data. This is monthly composite, and how the phytoplanktons are the most productive zones in the world. They dances with the sunlight. So during the winters in the northern hemisphere, the chlorophyll pattern shifts, and then similarly when the sun is there in the southern, sun is not there in the southern hemisphere, the productivity changes. So global productivity change and hotspots of the ocean region can be identified, and same data at a daily basis is also being used for applications like potential fish zone mapping, etc. And you can see the beautiful pattern of Amazon River, how from the river the water comes and then produces huge amount of productive zones in different river basins also. So at a planetary scale, you can understand beautiful ocean processes using this data sets. All these people, Damini and all, they are sitting here, they are being responsible for doing this wonderful work. Thank you. Next. So PFZ, anyway, many of you are aware, we are providing a operational service to fishermen. Next slide. Based on these data sets. So all these examples which I showed you, there are only few because time is not much. Most of this data is not simply data which is there in our drawers. All of them is being put on ISRO's actionable geo portals. So there are portals like Goan, there are portals like Vedas, National Database for Emergency Management. They are accessible to each one of you thanks to the National Geospatial Policy. And many of you can access these data sets today without any hindrances. Next slide. Of course, Navik, I will not tell much, but many of you are aware about this constellation. Next slide. Using this Navik data, many applications of mobility are being done today. Next slide. They are also having a lot of services for disaster management for fishermen based on two-way messaging services for fishermen in the coastal as well in the high sea regions using combining this SATCOM services. Next slide. Of course, we are now planning new satellites also. I told you about what is available. But the most important to this community, which is going to be launched in April itself, is NASA ISRO Synthetic Aperture Radar Mission, which we are building with the NASA JPL. It will have two radars in L-band, 1.275 gigahertz and 3.2 gigahertz. S-band is being developed by ISRO. And this will provide unprecedented capability to see Earth and its dynamic components. Next slide. So, a lot of science themes which are going to come and to get data about the Earth, like dynamics of ice sheets, glaciers, and sea level, ecosystem and biochanges, solid Earth deformation. It will make very precise centimeter to millimeter level measurements of deformations, either of tectonic nature or because of the groundwater depletion, or let us say coastal, inundations or coastal depletions. So that theme is going to be very useful for geoscience scientists to make measurements of these deformations which are related to solid earth processes using this NISR deformation products. And of course, cryosphere and various geological applications. So look forward for this launch. This is one of the costliest satellite ever built by, and then two big space agencies of the world that come together. Satellite is now fully developed, integrated, and a likely launch of this satellite on the GSLV mission will be there sometime in April this year, after 2 months or so. NRSC will be providing all the data from NISR mission through our Bhunidhi portal, from the portal which I talked about, and many of you, those who are interested in these themes and to use this data, can contact us. Next slide. So with these words, of course, we are also working our next generation in meteorological satellites. Time is not much to provide details, but if you have some questions, you can discuss with me after this talk. And the last one is about that what is on horizon. A lot of stuff is happening. Private sector also, a lot of things is happening in space after the opening up. A lot of people are now planning their own private constellations, their own ground stations, and of course, high throughput satellites for communication and providing internet services. So what you will see in times to come, huge impetus of satellite data for supply chain and transportation, food and beverage industry, state-sponsored defense program, consumer goods, electronics and lifestyles related applications, media, entertainment support, and of course, things related to climate monitoring and climate change response assessment also are going to emerge in times to come. With these words, I would like to thank each one of you for your patient hearing. Thank you.
Thank you, sir. Dr. Chauhanji. Very nice topic, the keynote address, that is the remote sensing. Really, we are fortunate as we invited you, and we are sparing our time with you, sir. Very nice, sir. The token of respect, I would like to invite Professor Rajan Prasad Garu to felicitate our Chauhanji. Thank you so much, sir. Thank you so much. Sir, now the plenary session starts.
From now onwards, we will have a plenary session, which will be chaired by Professor T. Harinarayan Garu. I request him to come onto the dais, please. And it will be co-chaired by Dr. Satyavali, NGRA. Please come onto the dais, please. So, in this session, we will have 5 speakers. The number 1 speaker will be Dr. T. Harinarayan Garu. The second one will be B. Prashant Kumar Patro. And third one will be KSR Murthy Garu. And the fourth one will be Professor A.J. Salman Raj Garu. And the fifth one will be Professor Singham Jain. So I request Professor T. Harinarayan Garu to start his plenary session. Before he starts, let me introduce him. So let me say a few words about Professor T. Harinarayan Garu. He is presently working as an advisor at Osmania University, and he was recently chosen as a task force committee member to promote geothermal energy by MNRE Government of India. He received doctoral degree from IIT ISM Dhanbad and also from University of Edinburgh, UK. He was a director, BSARA, Crescent Institute of Science and Technology, Chennai,
recognized research institute, Director General, University Ahmedabad, Gujarat member, Research Council of PDPU, Gujarat, and many, many more. And if I just go on, it will be a very long record. So I would request Professor T. Harnaran to say a few start his talk. Thank you. The time is very short, so I request my co-chairman to control my time. Okay. Just raise one hand, madam, so that I will start. I think we'll give 15 minutes each speaker. So after 12 minutes, please raise your hand, madam, so that I will rush through the other slides. I was planning actually for 20 to 25 minutes. Now I reduced. I will go a bit fast because you have already heard the today's talk from eminent speakers, so you don't need to know all the things. But I request our right-hand side people, these youngsters, to pay more attention because this is meant for you, not for others. Okay? Thank you. Next one, please. You are spending time 15 minutes with me. So what you are going to get is in which direction the industry is going now, so that you can plan your future better. In which direction our technology is growing is also being discussed. I think today our chief guest and other people have already mentioned, our vice chancellor mentioned that artificial intelligence is coming in a big way. So knowing only one subject, like I know only geophysics, I studied geophysics, is not enough, because artificial intelligence is coming in a big way, is going to enter in all sciences. So you should be aware of it, and you should know how to handle yourself. How to tune yourself is to only way is to improve your skills to meet the industry expectations. Next one, please. How to improve your skills? There are. I'm going to show you many online tools are available, freely available. When I was at your age, these things are not available. So we are at the receiving end. Now you are already equipped with many technologies which are freely available. Just now our previous speaker talked, Dr. Chauhan was telling that so much of data NRIC has released to the public and freely available. So you have plenty of data available. What all we need is new ideas from you. That's the only thing we need. Next one, please. If you see the industry is going in 3 directions: artificial intelligence, data science, and energy. These are the 3 sectors which industry is moving very, very fast. That means you need to orient yourself to one of these technique and which are interest to you. Most thing is what is interest to you is more important. Next one, please. If you see data science and artificial intelligence, time series analysis is coming in a big way. Any place, any geophysical data, most of the geophysical data is time series data. So how to analyze this, whether it is a seismics, electromagnetics, magnetics, gravity, everything based on the time series data and also spatial data. So this, how to handle it in an efficient way to get a better output from that is very important. Whoever is knows better, they are the winners. Next one, please. In energy sector, if you see, there are many aspects of energy sector: storage technologies, renewable energy, efficiency of energy, and transportation. In all these things, we require geophysics. How they are required? For example, renewable energy. So you need to have a geothermal energy. Where it is find out, it is the duty of our geophysics. Say, for example, storage. That means you need to know the reservoir characteristics. You should know subsurface structure so that you can increase the air pressure storage, compress the air. So like that, there are many other sectors which geophysics is very much essential. Next one, please. In geophysics, again, if you see the various like artificial intelligence, energy, water, hazards, minerals, and we can go even to startups. I just tell you, the startups coming in a big way, so anybody can do it. In Usmania University, we are promoting already 20 companies. Now, if you are very much interested in bright idea, you are welcome to join our center. I'm sure Andhra University should also have entrepreneurial development. See, you can go and talk to them, start your own company. Government of India and UGC
is encouraging all students to start their own companies. Next one, please. 5 ways to succeed at Geophysics. You start thinking differently, use and you will try to use the online tools which are already accessible to you. You need to develop new skills from that. With critical minerals, our today morning our DDG of GSA is already talked about the critical minerals are coming in a big way. Hydrocarbons, of course, our ONGC and other companies are looking for you. Next one, please. Job availability. If you see the job availability in critical sector, you have a lithium and cobalt is the upcoming technology. They are very critical now because of energy storage issues. Trump was telling that okay, I will stop Ukraine, but I want all rare earth elements of Ukraine to on my hold. See, that is important. That means political system is also coming in a big way. Major hiring companies is India. If you see India rare earth elements, international, Linus Corporation, Canada and Australia, they are waiting for Geophysics to come for mineral sector. Next one, please. If you see Canada, they have already identified and they are working towards 30 critical minerals, which is the list of these things. So why this thing is, if anybody had a very good idea that I can find, I am the only person who can find where the titanium is with some new technology, you are the winner. Next one, please. Oil and gas, our ONGC friends are here, they will tell you more about it. So oil and gas will remain going to be critical, although renewable energy is coming in a big way, but oil and gas is going to remain as a critical energy in the near future. So business area is startup companies like geophysics-based exploration services, gas fields, with a focused attention is required for resource extraction. So technology is seismic imaging and also data processing techniques, machine learning. These are the things which are required by the oil and gas. Next one, please. If you see the job availability, if you see the research, IITs are doing, NGRI is doing, ONGC is doing in research sector. So public sector companies are and private sectors are there. You can see ONGC and oil and the public sector, Reliance and Cairn Energy. These are the sectors looking for high quality skilled geophysics. Next one, please. If you see the international sector, Middle East, Saudi Arabia, North America, USA, Canada, all these major hiring, which is Saudi, Aramco, in ExxonMobil, these are the companies looking for a high quality skill. They are not getting. So they are waiting for you to join them. Next one, please. You can see the number of jobs in mineral sector, 300 to 400 positions by GSI. In globally, 1,000 to 1,500 jobs for geophysics. In critical mineral sector also. So what I want to say, the number of jobs are really available. Only they are not having is skilled geophysicists. So you have to improve your skill. Next one, please. So if you want to become a good geophysicist, either in India or abroad, you need to increase your technical and communication skills. Some people are very good in technical, but they don't know how to communicate. So this is very important. Soft skill is important. Next one, please. In 3 examples of online tools which are easily accessible to you, I have listed out TensorFlow, Google Colab, and IBM Watson. These are the 3 AI tools already available to you. Next one, please. And another examples of already doing time series analysis. I'm just giving a only sample of this. Only time series analysis of it. You can see OBSPY, MATLAB. You should all know this MATLAB, how to operate and how to execute MATLAB software. And Google Earth Engine, like GIS and other softwares should be expertise. GIS is very, very important as per the remote sensing data analysis concern. So you can directly join NRS. I was talking to some scientists from NRS. They are not getting the skilled person who knows GIS very well. Next one, please. So 10 essential geophysical software tools I have identified. One is GeoActive, GeoSoftware, Mira Geoscience. These are all things, tutorials are available freely for you to learn yourself. Don't expect that your teachers will teach you. It was not told in the class. No, you need to learn yourself and increase your skill. So these are all 10 things. I will leave my copy with your people so they can touch any of these. They'll get tutorials out of this. Geophysics, SGG, Wiki, and then PMLI, and Mira Geoscience, AAPC Toolkit. These are all the various platforms accessible to you freely. Only thing is you need time and your mind that you need to learn. That's all. If you have it, then you can do it. So please. So my suggestion is learn basic through open source platforms, through online tools. Okay? Take up a small project. Now summer is coming, so don't waste your time in sitting in the house. Do a small problem through internship and produce a report. That's your gate pass to get a better job. So through your own project report with a small problem, that shows that you are already skilled in that particular aspect of your choice and your passion. Start thinking innovatively with your own new ideas and become an expert in any of the tools of your choice. Next one, please. Thank you very much. So these are all my previous institutions where I gained my knowledge and experience. I'm thanking them. Because of that, we got all this information. Thank you.
Thank you very much, sir.
Thank you very much, sir, for the exciting talk. I request Professor M. Jagannath Rao to felicitate Professor T. Jagannath Rao. Sorry, T. R. Narayan. Professor Jagannath Rao is ex-Vice Chancellor, Alumni University, and now he's working in Andhra University as an emeritus, and he's teaching geology for the first years. Yes. Thank you, sir. Thank you so much.
Let us ask the audience. So we want second speaker is ready, or shall we wait for a break? It's up to the choice of the audience. Second, I think the speaker is ready. Please come. So after his talk, very interesting talk from Dr. Patro from NGRI. Patro, only 10 minutes. People are already hungry. Okay. So 10 minutes, 9 minutes, I'll raise my first hand. You should stop it, okay? Thank you, Dr. Patra. Now the floor is yours.
Let me introduce Dr. Prashant Kumar Patro received his BSc from Berhampur University, Odisha, MSc from Andhra University, Visakhapatnam. After completing his master's, Dr. Patro has worked in NGRI. He's currently working in NGRI, and he got his PhD from Osmania University, Hyderabad. And currently, he is a chief scientist at NGRI. Dr. Patro has been studying the resistivity structure of the crust and upper mantle using magnetotelluric method, which uses electromagnetic induction in the earth. Since the resistivity is a physical parameter which is sensitive to existence of fluids and minerals, Dr. Patro's study has given important information on seismotectonics and resource explorations. He has applied magnetotellurics techniques, employing the state of air powerful tools in processing, composition of magnetotelluric tensor and modeling approaches to study a variety of problems encompassing both solid earth geophysics and exploration aspects. For example, diversities in the crust and lithospheric electric structures of the geotectonic units of South and Central India, the Deccan volcanic province, and the southern granular terrain has been brought out with particular focus on the DVP and its seismotectonics. In the recent times, Dr. Patro research is focused on Himalayan tectonics and Cascade subduction zone. So that's it about Patro. I request him to start off his talk. Thank you.
Yeah, thank you, Srinivas, for such elaborate introduction. Thank you, Chairman Dr. Harnan Garu and Vani. Okay, my name, I'm from 93 to 95 batch category I wrote there, and then came at NGRA. I'll be bringing out some glimpses of MT studies. See, since morning we are talking about this renewable energy, sustainability, and this is the time that we talk about geothermal energy, which will play a major role in achieving those targets. I've chosen two regions for purposefully. One is Puga, and one is in Himalayas, that is in Puga, and second one is in Tatapani, which is in Chhattisgarh. So we'll see in these two regions how the signature, the geophysics signature that we're getting will be helpful for us to characterize the geothermal field. Next. Before I go forward, I say Guru Brahma, Guru Vishnu, Guru Deva Maheshwaram, Guru Sakshat Parabrahma Tasmai Guru Namaha. The picture, what you see is Dr. Sharma, my supervisor. I am blessed that he is my supervisor till today. We work as a friend, and he's a teacher, as a friend, everything. He conveyed his greetings to all of us. So I also I take this opportunity to go myself to all my teachers here, all my seniors, because of them I'm here today. And I thank Professor Naidu Garu for giving me this opportunity to stand before you, and my director for all kind of support to me. Next. Okay, so let's move to geothermal energy. So why we need geothermal energy? Because this is a thermal source that originates deep underground, and it is a form of primary energy. It can be directly a heat, and we can create electricity directly from this heat. And unlike the solar and wind power, it can be used at any time of the day. At 24/7, you can use it. So this makes it fairly reliable and allows to use a base load power provider to the electric grid. The very important thing which I marked the red line is that geothermal electricity is a renewable energy source, and there is relatively low CO2 emission in electricity production. So this is why it is very, very important for us. Next. So basically, when we talk about the geothermal system, we need to have a heat source, we need to have a reservoir, and we need to have a fluid. The left cartoon shows the typical geothermal mechanism. You need a source and the default system to get the pathway to come up, and also recharge mechanism, the meteorite water which get into the system to get heated up and comes out. So you see the two kind of origins. One is volcanic origin and non-volcanic origin. And volcanic origins are mostly active regions, subduction volcanic regions. Non-volcanic regions are mostly fault-related or granitic origin. Next. So when in the title I said high enthalpy, low enthalpy. So high enthalpy regions generally they are mostly in the active regions, in volcanic regions and the subduction regions. And so left figure, what you see, a electrical signature of a geothermal system. You see the smectite illuminate with the cap layers and the fault zone and the heat source. They are characterized by a specific resistivity property. This important property. And that is where I want to bring magnetotelluric here. Because the proxy is to measure the resistivity property, and if you understand this mechanism, you can easily map a geothermal system, an active geothermal system. Next. In the case of low enthalpy, they said the main reason is the fault zone, granitic origin. That also should have a hot reservoir sitting down, and these kind of scenarios are mostly in Indian case. So what we see in our case, and the source could be naturally increasing temperature of the earth with a natural gradient. So mapping these hot aquifers are become important in the fluid pathway. And for this, we don't have any good conceptual model. What I saw in the previous slide, there was a conceptual model for active regions, for high enthalpy regions. Next. So what are the applications of this? The high enthalpy zones are used for production of electricity,
and they can be used for cement block curing, lumber washing, wool dyeing, etc. And the less than 100 degrees Celsius temperature utilized for food processing. Okay, so it has got numerous applications. Next. Yeah. So this is a very important figure that I thought I'll bring to your notice. The left figure, what it shows, the electricity generation in India. If you see large amount of electricity generated through coal, and next is hydro, small, large hydro, wind power, solar power, but we don't see anything on geothermal energy. So, but by 2030, the government of India intends to phase out thermal plants and replace them with renewable energy. Okay? And geothermal power is one of the alternative sources to reduce the need for petroleum-based electricity. So this is where I think the need of geothermal energy comes, and GSI studied from some studies that did, whatever studies, they say the potential is more than 10 gigawatt capacity, and that we extracted from geothermal energy for this country. Next. And if you see that throughout the world, so this is a map, the top 10 geothermal countries, and we don't figure out that. So this is the right time that India should gear up and identify these zones. And in this context, last few years, in India, a lot of activities are happening. Government agencies are actively encouraging for the development of geothermal things. In ONGC has started looking into Puga field. They have tried to go for drilling last season and last season in Puga. And one thing in Managuru, we have a pilot plant developed by Signatory College with the GSI. So things are moving now. So this right time that we also do in Geophysics, we should gear up our plans. Next. Coming to the India. So the left one is the geothermal map of India. See, we have got many promising fields. They are lying. Some of them are in Himalayas, and some of them are in North NSL zone, and some are Godavari belt, Godavari basin, or Mahanadi basin. So, but I will be talking something in Ladakh and this Tadapani, which is in close to NSL. Next. So, when you talk about geothermal, various techniques, geology, geophysics, geochemistry, everything has to be done together. So if you do geophysics, we may try to identify the density and magnetic properties, and through electrical, we'll find the resistivity properties of surface, and velocity we can go for seismic, and most important thermal, very important for us to know the temperature gradient, thermal conductivity, mapping of the area. And another important thing is hydrogeological studies. This is an important study which is very essential when you go for drilling purposes. Next. And the geochemistry, we need to know the age of the water, is helium content, meteorite origin, or what is the origin of this water, and then we should develop the conceptual model and then talk about the sustainability. So altogether, this is an integrated study which is required to map the geothermal field and go for production. Next. So what are the questions we need to answer? We need to find the reservoir, we need to get the boundaries of the reservoir, and we should provide the drilling location, and we will say the cap rock and everything. Next. So these answers we can answer, these questions we can answer by using microtelluric technique. Okay, this I'm skipping because this I wanted to say that how the resistivity property is directly proportional to your geothermal targets. I just characterize different resistivity with different zones. So this is just to motivate to use for MT. So I'm going to take more time. What is MT? It is a natural source method where you use X magnetic field as input field, which interacts with the subsurface structure, and it derives the secondary EMF, and which again you measure on the surface. So it's we talk about a broad range of frequencies which are emanating from ionosphere and also thunderstorm activities. So that is the power of MT, that we talk of a huge broad band of frequencies. Next slide. So this slide I skip, but just tell you that the two frequencies, the low frequency part we get from interaction of solar wind with the magnetic field, and then they generate the induced field which reaches to the earth. Next. And the high frequency part, what you get from worldwide thunderstorm activities. This image, you say any given point of time, we have thunderstorm activities, they emanate this source. Next. This is a basic principle. I just took 3 cases, like you have 100 ohm meter subsurface, you have high frequency, middle frequency, low frequency, and you have 20 kilometer surface. You can imagine this whole surface if you measure these frequencies. Yeah, how do you measure this signal? This is how we measure any location, like we have the magnetic sensors, the red ones are the magnetic sensors, and the blue ones are the dipoles. We measure the electric field, this is the magnetic field, and they keep this system in a place for few days to few weeks to get the signals. Can you press on this? Okay. Can you press on this image? No, okay, go ahead. Okay. So this is the cartoon showing that how the interactions with subsurface happens, and how we do is that these are the sensors. They are kept below the surface, and we measure the signals. Next. It's a very brief thing about the MT method, like the source field, and then we do the calibration instrument. We get the MT data, all kind of data. We do the quality test, and then we do the analysis of the data, and we model them, and integration is done. This is left side image is how a cartoon of MT installation, and the applications are the applications. Next. These are the instruments they are used for MT data, but very important here is that practicing MT, that the data means you have to get good quality data. The left one I'm showing the poor data, and you have to really spend. See, today morning even Dr. Hydrocarbon told about AI. This is where the role of AI comes in today's thing, and we have been doing that because this kind of data, huge data set, you have to deal with them. So apply some kind of AI techniques, and this is one of the cases we use some AI techniques to get good quality data. Okay, now I'm bringing you to one place, Tatapani. Tatapani is in Chhattisgarh district. This red dot is Tatapani, which is very promising from previous studies and all. Maximum temperature is at 112.5 degrees Celsius. And this work was done earlier when Dr. Haridana was at NGRA. He started doing this. But again, we visited this area because of the recent interest of Government of India. So again, went there, we get additional sites. So this, all the pluses are the empty sites. We have analyzed this data, and we get the 3D inversion for this data. This is how the data looks like. Sorry for the bad picture. And this is one of the geyser in Tatapani. Next. Okay, this is the final product that you get once you do a 3-dimensional inversion of these data sets. What you get here, the red line is a Tatapani fault, and this is model cut we have taken. The red ones, what you see below this fault, these ones, that you find that you can coinciding with the Tatapani springs. So we find that this has got the system and which is deeply connected. You see the red one below 4 kilometers. So this is telling us that a huge reservoir sitting in Tatapani which is feeding to the spring. So this also tells us the confidence about sustainability of the reservoir. But we have a problem. In NT, getting the lower boundary of a structure is a problem because of the conductiveness. So this data was done with a broadband up to 1,000 seconds. We wanted to understand how much deep we can go. But coming to the another section, you can see clear boundary, the red and the green and the blue one, this clear boundary. That is showing the granitic, the gneisses and the Gondwana's. Next. Yeah, this is another study we did in the same Tatapani region to understand the depth extent of this conductor. Can you run it? So once you do the 3D inversion, as all of us know, why 3D is important, because you can have a volumetric presentation and you can see how best these conductors are connected to the deeper reservoir. This gives us very much confidence, and probably this is one of the information that GSI has and our agencies have. They are going on with doing conducting more number of studies there. Next. Yeah, coming back to Ladakh, I am talking about the Puga. See, the right image that I have shown is the normal gradient is this, the 10 degrees Celsius, this is normal gradient. But in these regions, the normal gradients are at least 3 to 4 times more than normal gradient. That is why this is a very important region. The right side image, what is, this is Puga and north of that is Chumatang. So the Puga is expanded here. The right side image, what you see is from Dr. Harinarayana, what he did in 2001. He has identified very good manifestation of thermal. You can see, and he said that we visited that again, and we took additional site, and also we studied Chumatang region. The reason behind this, because the two are closely back. So if you understand that this reservoir is connected down below, then the government can make a good strategy. Instead of looking for only one field, they can see that both fields are connected. So, but the problem, logistic problem is that we cannot travel between Puga and Chumatang in a vertical direction because of the hill. But nevertheless, we went there. Next. So you can see the C1 is the Chumatang and C4 is the Puga. So what you see at the same depth, the same anomalies are appearing at both the places. So the question comes, are they connected? So to us, it looks like they're connected because we saw it through gravity also, into other geophysical method. It looks to be connected, but we don't have clear evidence because of the data gap there between C4 and C1. Next. Well, I talked a lot about MT and its applications for geothermal energy, but this is a place to be very careful on interpreting this data. So this is a classical case where at the point on the rig, which they drilled one, but they missed the target. The background image is the interpretation from MT studies, but they missed the target. Next one. So now they use proper interpretation that analyze properly. The second one, they could really hit the target. So the bottom line here I want to tell you is that whatever data, whatever thing we get, if interpretation goes wrong, maybe we don't give proper. When we go for drilling, we will find some failures. Next. This is another thing to know. Many methods, like I told you, lot of methods are posted, but I can say MT one, you can see all reds. So for geothermal studies, I can at least say MT is a unique tool which can answer many of the questions that are asked by all the planners in geothermal exploration. So to summarize, I think almost I covered everything. It is the importance of MT is logistically very simple, and it doesn't require huge machinery, huge things. But the important thing to remember is that incorrect use of MT method leads to error in determining the drilling targets. Thank you so much. Yeah. As I told you, Manuguru is a very promising area. Right now, GSI and Singalini has established a plant there, which is, I think, some kilowatt, 20 kilowatt, some plant, demonstrative plant. They are going to expand it. So there's a lot of scope for geothermal exploration. Thank you so much. Yeah, Manuguru Telangana.
So it's so great to have both the big scientists of India who are working in magnetotel rigs. Any questions?
Yeah, please. Yeah. You can hear. Yeah. Could you get me, please? Yeah. How do you relate the resistivity, which is a function of the salinity of the fluid in the rock, to the either structure or the heat energy reserve?
Yeah. Thank you, sir. In fact, I have one slide where I show you. I thought I'll show you the resistivity variation with different rock types. Okay. If you tell any rock type, it will have a certain kind of resistivity assigned to it. Coming back to the fluids and all, naturally, when there is a fluid, interacting with some kind of salinity or some kind of chemicals, then it will show a conductive nature. So whenever there is a fluid, you will identify through resistivity property. But talking one image I am showing you that the distinction between the Gondwanas and the granitic crust. So the very good distinction comes because resistive crust, you don't have any granite rocks. So there is no way that you can get a conductor there unless the pores that are getting connected through some minerals or the pores are filled with fluids. Otherwise, even the fluids will be there. If they are not connected, we don't get a bulk resistivity. If they are connected, only you get a bulk resistivity.
Okay.
What is the range of resistivity from?
Yeah. So that is the range. I mean, I just can you go back to my slide where I have characterized for the see, for example, if you are finding out I try to find a cap of this geothermal system, then it should be around 10 ohmmeter or so. This particular value how we got because this was studied in a system. They've calibrated it and they found out this thing. Okay, so you may say that exactly 10 ohmmeter may not come here, but we say a conductivity property. 10 could be 20 or something. Exact thing you cannot say. It depends with the background resistivity also. Yeah. For example, in our model, now we go back to our model like in Tatapani.
I think we can discuss during the lunchtime. That may be better. People are hungry.
I will show that.
Yeah.
Next. Go on. Go on.
Okay. Something going on.
Go.
It takes time to locate Patro.
Go on.
You want to see the model, no?
Yeah.
This is the model.
Sir, no.
This one.
Yeah. Sir, here, what you see the background, there are thousands of ohmmeter. Okay? But what you see the red and yellow one, they are tens of ohmmeter. This is the order of contrast.
In any geophysics, we need a contrast. Okay. Yeah, either gravity or susceptibility or resistivity. Thank you very much. I think now give to the organizers.
Thank you very much, Patra sir. Thank you so much. And it's so great to have you here. And at we have two scientists from magnetotellurics, Professor T. Harinarayana and Patra on the same stage. And they have worked. I know that for the last 20 years working on this magnetotellurics. Probably they are the fundamental. They're working since fundamentals, and for the last 20 years. I request Professor K.S.R. Murthy garu, Dr. K.S.R. Murthy garu to felicitate Patra sir.
Photographer. After this lunch. After lunch. This one. Can be other side so that photographer will be more happy.
Thank you so much, sir. Thank you so much.
Okay, before we break for lunch, I think a person from NABARD would like to say a few. Yeah, Naidu garu, just for 2 minutes. Yeah.
Thank you, sir. It's a very, it's very tough job to manage. I will not take more than 2 to 3 minutes because all of you are waiting for a break today. See, now before me, 3 sessions has been taken place. Chauhanji has spoken, Narayana sir has spoken, and Patra sir has spoken. See, all these are the scientific inventions at various levels, at various organizations. I am Dr. Vaishu Naidu from NABARD, National Bank for Agriculture and Rural Development. Along with me, my colleague, this district head, Mr. Samant also is there. He is the head for Visakhapatnam and Kapil, and I am looking after Koanseema, East Godavari, and Kakinada districts. See, there are our alumni has settled in various scientific organizations having scientific various contributions, and ultimately we are going for mineral exploration and also gas exploration amenities. And in my interview, when being the alumni of Geophysics department, I went for an interview for my assistant manager when I was 15 years back. One of the professor asked me a question: being a geophysicist, how you will justify that your services are needed for NABARD? Means it's a Government of India developmental institute which is came from Reserve Bank of India. It is committed for the functions of agriculture and rural development bank. Then I gave an answer that, sir, we scan the subsurface of the earth. NABARD invests thousands of crores of money for irrigation and water resources projects, irrigation projects and minor irrigation projects, where hydrogeological parameters are needed, and also vegetation related and forest related information is very, very crucial for finalizing the decision making on the various rural connectivity bridges. And because basement is very essential, at the same time, regarding irrigation structures also, we need the subsurface information like that. Geohydrology, this geophysics will help us. That's the question they told, very good, and they started. Later I came to know that the professor is from geophysics background, from BHU campus somewhere. See, let me just say about NABARD, how NABARD will work out for the farmers, and how the scientific information can be utilized by NABARD during the investments for the development of agriculture and rural development. NABARD is the national implementing entity of climate change. Many of us don't know that NABARD has been, because NABARD has vast experience in taking up watershed projects and rural connectivity projects, natural resources management related, and ecosystems related to the natural resources management in the sense not only water, that vulnerable communities that are associated with the these climatic factors that come out, like, so for example, if you take agriculture, in the agriculture we are having drought heat situations, and horticulture crops are being under drought heat situations, and the fisherman community and the vulnerable community of the coastal erosion. So these are all the ecosystems connected with the climate impact, and so that the international community, because of the vast experience of NABARD, has identified national implementing entity for routing the climate change projects for international funding, like National Adaptation Fund for Climate Change, Green Climate Fund, Adaptation Fund Board, like this. NABARD, being the NABARD, we invite suitable proposals from the geophysics and also sister departments like geoengineering, even meteorology, oceanography, geophysics, water resources, geology. Like these departments, we can have a separate meeting on this. What are the how NABARD can help us? What sort of projects we can submit to NABARD, so that such type on the lines of climate change, which will directly address the vulnerability of various communities connected with the climate change. So these are the small inputs I would like to do, but at the same time also we are running short. For this, I request the head of the Department of Geophysics, if in the future any AGSEEN related meeting is going on, I request my colleague Mr. Samant will be there in the district only. You please invite him. He will brief. He will give insights on the in-depth information with regard to NABARD schemes, how scientific community can utilize the services of NABARD. Thank you very much for giving. And also, I am very thankful to being the alumni of this Department of Geophysics. I am very happy to coming here, and my organization has deputed me here to come here. And thank you very much. I visit the mother Geophysics. Thank you.
Thank you, Naidu Garu. Excellent example of communication skills. See, he's a geophysicist, and he went for a bank job, and a tricky question, and how nicely he converted his knowledge to get the job. So give a big hand to him to correct good communication skills. Number two, now NABARD is rich. I have forgotten to put a bank, also geophysical demand is there. I mean, next slide, I will include banks also in my slide. So they are in great demand. So it is a good opportunity for all the youngsters to make a small problem of NABARD and do internship. And I think Naidu will absorb you for get a job. Yes? Thank you very much.
Thank you, Naidu Garu. It was such a great talk from you. So we would like to felicitate Dr. Naidu Garu. I request Prabhakar Garu to come onto the dais and felicitate. Thank you. There are many surprises to come. Now we will have a lunch break after this.
I want to save time for you all.
Prabhakar is the person whom you have heard about geophysical song. He is the person, he is my classmate. Huh? So now I think we can break for lunch. Thank you. Thank you. Thank you.
The lunch is outside, just outside the hall. Please have lunch, and we will retrieve the session at 2:30. Please. Yeah.
Yes, sir, Murthy. Hello all, welcome back after lunch. Our next speaker is Dr. KSR Murthy Garu. I request him to come up to the dais, please. And before he gives his talk, let me introduce you. Murthy Garu was born on 17th April 1948 at Rajahmundry, and he did his doctorate in Geophysics from Andhra University. Worked as a scientist in several capacities for nearly 41 years, initially at CSR, National Geophysical Research Institute, Hyderabad, and later CSR, National Institute of Oceanography, Visakhapatnam. Main area of research on tectonics of passive continental margins, published nearly 80 research papers on continental margins, interplate deformation, Indian Ocean tsunami, natural hazards, etc. He worked as a deputy director and scientist in charge of a regional center of CSR NIO in Visakhapatnam for more than 11 years. And is an expert member in Andhra Pradesh Pollution Control Board, Central Pollution Control Board, New Delhi, etc. And currently, after his retirement in 2008, he is actively associated with social activities related to residential welfare associations. He recently got an award too. I request him to start his talk.
Chairman ji, how much time I have got?
15 minutes.
15 minutes. I'll try to complete before 15 minutes. So before I start my lecture, let me thank the organizers, Professor Naidu Garu and his team for giving me this opportunity, and also thanks to the chairman and co-chairman. And just let me take a few less than 1 minute about myself. I belong to 1968-71 batch of Geophysics Department of Andhra University. Now I'm about 76 years old. So whatever I am telling now, whatever I am presenting, it may not be purely completely geophysics, because I retired in 2008, continued for another 5 years as emeritus, another 3 years as MOS project scientist. But simultaneously, for the last 30 years, I am associating with the residential welfare associations and the related social activities. Several aspects of residential welfare associations, whether it is solid waste management, plastic reduce, recycle, and plastic management, granary development, and rainwater harvesting. Out of these, rainwater harvesting is a little close to the geophysics subject and also geology, and to the concept of sustainability of this theme of this conference. So somebody, when Naidu asked me, the only thing I can present at the age of 76 years about my social work. So this is socio-scientific work. Whatever is scientific experience I got, I have made use of in my social level, both at the very colony level, city level, state level, and the national level. Because now I am not only president of a colony, associate president of a Andhra Pradesh Federation of Residential Welfare Associations, and also chief convener of Confederation of Residential Welfare Associations, Delhi. So with this slight introduction, now let me go to my talk. As you all know, I need not overemphasize this morning also. There was the chief guest and also Harnarayan Garu. So many people told about the impact of global warming. Global warming is taking us to a tall. Resources are dwindling. We are facing temperature-wise pollution. And then also, of all the things is the water deficiency. Even India, it has got only 4 to 5% of its required water resources for a 160 crore population. There are countries internationally in the entire world which are facing severe water crisis, and some cities have been already declared as zero water cities. So even if you take India also, there is a paradoxical situation. The same cities which are fighting severe crisis, water crisis in summer, whether it is Chennai or Bangalore or Hyderabad or Pune, the same cities are completely, you can even swim in the rainy season because of water flooding or improper urbanization, occupation of lakes, and deforestation, and so many ill effects of development, urban development. So for the last 10 to 15 years, I have concentrated on this problem. And for any, think global and act local. For any global problem, solution lies to at the ground level, ground truth level. Whether we observe, so from satellite data to space to, let me go take you back to the ground level, where we have worked, how we have worked, and it has given us some. This work also has given us some national level awards also. This is what I am going to present. Next slide, please. So first phase, the earliest primitive stage, what we have started is in my own colony, which is a 5 acres land, which has got about 20 to 30 apartments, about another 50 houses. There is about 2,000 population is there. And in that area, for example, this is the location of that area called Jayar Nagar. These black dots are the location of the rainwater harvesting pits. In Telugu, we call it as Inkudu Puntalu. All around the colony on the roadside, first what we thought is we have to design, we have to install the rainwater harvesting pits so that in case of rain, what is happening, whenever there is an excess rain, the water used to go to all the way into the drainage channel and finally enters the sea. Without being, the runoff is not properly utilized. Even the apartments and flats are also not there properly in making use of their either terrace water or user water and all that. With that idea, we have started this procedure. Next one, please. This is the simple, typical cross section of a rainwater harvesting pit. It can be, need not be 7 feet. It is about 6 feet height, 3 feet width, and you will have different sizes of gravel. And so you have to dig a pit like this and fill up these layers, and then finally you have to connect it to any outlet from the, either it can be from the apartment or it can be from a roadside runoff rainwater and all that. If you connect like this, ultimately before without getting wasted, this water reaches the, and it will what you call recharge your groundwater table. Next one. So the fundamental, what is the, how to select a fundamental criteria for selection of the site is that it should be able to capture maximum runoff water, downslope area, select the location based on general topography, roadside locations, parks, apartments, these are ideal locations. But only thing you have to take care is that these pits are not destroyed due to any expansion activities like underground cable construction and all that. And each pit costs nearly 12,000 rupees including the material cost. What we did is, either we used to meet this from our association funds, or sometimes we will approach some donor so that they will help us. Suppose if one person donates 1 lakh, you can nearly go for 8 to 10 RWH pits in your colony. And I can tell you for the information, in Vizag itself, we have got about 150 residential welfare associations spread right from Kormanpalam near steel plant to Madhurwada in the north. So all these residential welfare associations are actively working in all the activities what I told, rainwater harvesting, greenery development, vector and dry waste segregation, compost making, green development, anti-pollution, anti-plastic, all these works they are doing. So what we have thought is, why not we extend this small work in the colony to the city of Visakhapatnam, so that the RWS in the city can help to expand this work at a city level. Next one. So this is the entire process of going for a pit. starting from a coconut breaking to getting the material, getting the ring and getting the digging the pit, filling the material. Finally, the last side with a label, that is your ground. 5 to 6 days. So the top 3 are examples of rainwater harvesting pits constructed in apartment premises. They are connected directly to the terrace water so that any runoff from the terrace directly goes to the pits. These are all the roadside pits. You can see with the label and all that. Some examples of this is only in my colony. Next one. So see, a typical decorated rainwater harvesting pit looks like this, and this is the inlet pipe where the runoff rainwater enters directly into the pit. To avoid any blockage due to garbage and all that, you can have a rectangular wall also over that, so that there won't be any something like your maintenance will be less. That is also one example of pit. And this is my colony. And this is where generally all the apartments are constructed out of an individual house. So individual house will have a well, which is subsequently abandoned. We have connected the terrace water to that abandoned well. So that abandoned well also acts like a rainwater harvesting pit. Next one, please. So next we have gone to second phase of rainwater harvesting. That is, we have expanded this work to the entire city of Visakhapatnam. Next one. So this is what one of my press release. We suggested that why don't you go for rainwater harvesting pits for the entire city, so that slowly and steadily with the help of GVMC and other organizations, you can expand this RWH program to cover wider area of the city. Next one. This is the that blue boundary is the location we have selected. You can see the north somewhere near Teneti Park, Yandada, Madhurwada and all that. Here something like Simhachalam, that is Simhachalam. This is Gazuaka. This belt, in this belt we have got about 150 RWS. We have assigned them this job of constructing the rainwater harvesting bit for the city of Visakhapatnam. Next one, please. So this is how we have divided. Zone 1 is Bhimli, still we have not, our RWS activities are not expanded to Bhimli. Similarly, Zone 7 is Ankappalli, we have not expanded to that area. The remaining zones, we have defined our coordinators. These are our coordinators of Andhra Pradesh Federation of Residential Welfare Association. These people have taken the responsibility to contact the RWS of that particular zone and then select the suitable locations and go for the rainwater harvesting pits. Next one, please. That is how, in a matter of about 1 to 1.5 months, you can see each pit belong is an example of one zone. Zone 2, Zone 3, Zone 4, Zone 5, Zone 6, Zone 7, Zone 8, like that. In all the 8 zones, you have established the rainwater harvesting pits, and each pit is labeled, and also it is the sponsor of that pit also will be, his name also will be written there, so that the people remember that who has contributed for the construction of these pits and all. So these are the rainwater harvesting pits. Now, this activity is spread for the entire city of Visakhapatnam. Next one, please. So these are the, what not only that, each RWH pit is a GPS location. That GPS location is connected to GVMC, so that in the city, wherever new RWH pit comes, automatically it goes to the that particular database. And if you click these links, you will find there's a pits live, how water is entering during a rainy season. Luckily for us, we have completed this project in May, June, and July to this September, October, we have got a lot of rains in Visakhapatnam. So we are benefited. Next slide. Just click, no, go to previous, click on that slide. Put one more click. You see, whenever rain comes, this is how the water enters the pit, and then next one. Again click. No, previous one only click. This is the advantage of the location advantage. All the water downslope side we have constructed a pit. This is in Keralampudi area. You see how the water during the rainy season without being Keralampudi is a hilly, it's an elevated area, and So this is the rainwater harvesting pit in Karlapudi area. Next slide, please. This is another in Daspalla Hills. Similarly, during the same rainy season, how rainwater is being collected during the rainy season. In all these about 100 to 150 pits we have constructed in 1.5 months in the entire city of Visakhapatnam, which is almost negligible. For the entire city of Visakhapatnam, you need thousands of pits, but we made a beginning and we are continuing. And as I said, because I am a national convener, in all our national conferences, whenever we meet, we discuss on focal themes, whether it is rainwater harvesting, solid waste management, or any other subject. Most of the RWS in Vijayawada, Guntur, Nellore, and even other state federations also now, they are taking rainwater harvesting, our RWS, as a priority task. So that bit by bit, drop by drop makes an ocean. If we can make this type of attempts, maybe we can get out of the water crisis with which we are facing severely. Next one, please. So, for example, 6.75 lakhs liters per annum we could save from about 16 rainwater harvesting pits in the Jayar Nagar itself. Similarly, in Tirumal Nagar, there is Vadlapudi near Gazuvaka, a much bigger colony. The quantity of water saved by 175 RWH pits is 47 lakhs liters of water per annum. This is how we are able to save. Next one. So naturally, when our work was recognized by Ministry of Jal Shakti, we got a cash award in 2018, and I got a water hero award in 2022. Tirumal Nagar got also this year from Ministry of Jal Shakti best RWA for water management. Other organizations like Water Digest and also India Water Foundation has given us awards for the contribution we have made towards managing water management in urban environment. Next one. He is the Minister of Jal Shakti at that time. Next. This is last year I got from Gajendra Singh Shekhawat. Next. 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 This is the Tirumal Nagar of Gazuvaka. They got this year, October 2024. They received Best RWA Award for the rainwater management from C.R. Patil, Minister of Jal Shakti. Next one, please. This is another award we got in Delhi from India Water Foundation. Next one. So the third phase is you have to create awareness to the public on rainwater harvesting. This we have done in 2-3 aspects: organization of rallies, awareness conference, distribution of pamphlets on how to save water, and also books on reduce, reuse, and recycle of water. So reduce, reuse, recycle of water, and also other aspects. I'll quickly go through this this list on next. These are the pamphlets we have prepared and we have distributed throughout the Raita Bazaars and public places. How public can save water in daily use. About 10 steps. Next one, please. Next one, please. The organization of some rallies. Previous slide. They are the vice chancellors of Andhra University and Bal Mohan Das and also GMC Commissioner. Next one. And we organize rallies. Students also with placards, they organize rallies on water management. Next one. This is some of my articles published on rainwater conservation. Next. These are the books I have written. For example, Reduce, Reuse, and Recycle, an RWA practical guide for water management, and rainwater conservation and harvesting role of RWS. Next. This is next one, please. These are the awards press notification. Next one, please. These are some of the colonies. Next. But this is, I think I have closed. Thank you. Thank you. This is the small work I was doing at the age of 76 years, mostly social, a little bit scientific, because I conduct seminars, conferences, awareness program, and all that. I lead them in this project. And thank you very much.
So this is a typical example of dedication that continues to work. Give a big hand to Mr. Murthy at this age of 76. I hope you will continue to, sir, up to 80 or 80, 90. Thank you.
Thank you so much, sir. I know you are 76 years old, but we would like to have a young person, a dynamic person from our staff. Would like to felicitate you. I request Dr. Israel to come on the dais and felicitate him, please. Yeah, please, sir. Question. Please, go ahead.
Only one small
Yeah. Let him ask. Let he is asking.
Small the volume of the film that can accumulate the runoff should be increased. Is almost the period up to the film. Anytime what will happen is the big rain comes down. This gets filled and then overflow.
Overflow.
That's why you have to keep at least 2 to 3 feet gap.
Much deeper.
Okay, let me answer the same question, sir.
Yeah.
In one way, what is happening in today's trend is that these, as he said, that it is not stopping runoff. Okay, it is getting filled after some time because the rain is more, so it is going on. So now the trend is they are drilling a borehole, identifying a fracture zone as much as empty. What I call mandatory is telling us the fracture, and they are drilling a borehole of a 6 inch or 8 inch, whatever. So that is 50 meters or 60 meters, and leaving the water there, it is reducing the runoff much.
This is actually this is a micro level program, colony level, and so that is a major.
Another 2 feet also is not going to stop my runoff. Okay. So the moment it rains for 30-40 minutes, all my feet goes up. Calculation is not that much.
Okay. Now the young man has come to facilitate the senior.
Thank you, sir. Thank you, Israel, sir. Thank you so much.
Thank you, Murthy garu. I will go to the next talk by Solomon Raju.
Yes, sir.
Yeah, sir.
Professor Salman Raj garu, is he here? Professor Salman Raj garu, he was here very recently. What happened to him? Maybe you can call him, sir. Just give him a call. Professor Salman Raj garu, we are waiting for you.
Otherwise, we can go to the next one, and then Solomon Raju can be last. Professor Singham Jayantu, please.
I request Professor Singham Jayantu to come on.
NIT Roorkela. Yeah, it's coming, right? You are noted, Professor? Yeah.
Professor Singham is from Department of Mining Engineering, National Institute of Technology, Roorkela, Orissa, and he was a National Mineral Awardee in 2000 and the Chief Editor, Indian Mining and Engineering Journal. Dr. Jayantu, in many of the projects as project leader, principal investigator, was actively associated with about 120 projects sponsored by various industries, Ministry of Coal and Ministry of Mines, Government of India, and the list of silent projects undertaken as scientist at CSR, CIMFR, Central Institute of Mining and Fuel Research, National Institute of Rock Mechanics, and as a professor of NIT Roorkela. So he has a lot of patents, and I'm so happy that he is here, accepted our invitation. I'm so happy that he is here, and I request him to start his presentation. Thank you.
Thank you.
అందరికీ నమస్కారాలండి. Very good afternoon to all.
who are online available, I think, on YouTube link and offline here. So this is always very difficult tasks are given to mining engineers. When it comes to presenting paper also, it goes to MN is the last as per alphabetical order. And when I was asked by our Naidu Garu, when we were there at NIT or some other event, then when he requested me to give plenary talk, I told him I may be an odd person out, but any good works need some break. So you can consider me as a break, so which may initiate something better. And that's what we are going for. That is disruptive technologies. Unless you disrupt something, which is a conventional practice, you cannot go for your artificial intelligence, deep learning, whatever it is. Some disruptive technologies are required. So this topic, why I have chosen this is, basically, when I was a scientist for 2 decades in CSIR as well Ministry of Mines, polar goldfields, Ash 123. So then later I shifted to NIT Rourkela. I was given a task of teaching geology for 2 years. Reasons are many. As HOD, I was there. And that also gave me some more confidence that yes, I can talk to some geologists sometime. But geophysics, as I have seen from inaugural session, is a very complex subject. It is very difficult to understand. That's why I was sitting in the last bench along with very senior person sitting there. 68 batch, Sriman Narayana Garu. I used to tell all the time that very intelligent people only sit in the last benches. I had that opportunity today because they can see everybody, nobody can see them. That is what is intelligence is. So this topic, coming to this without taking much time, how much time I can take, Narayana Garu? Okay, Ramayana can be told within 2 minutes. 2 days also not sufficient. Don't worry, I will do that. As a title. So title why I have chosen this is Advances in Design of Safe Blasting Practices. Already I told you, unless you disrupt something conventional, you cannot do something new. For protection of surface structure, this itself shows you that as a mines manager, I am standing as a damager of the environment. Okay, utilizing all your data, geologists, geophysicists, everybody, geoscience, awardees are given to. And that surface structures, how to protect due to blast-induced ground vibration. Here comes your geophysics. So now we did a lot of things in 1988 from IIT BHU. That was my master's thesis on ground vibrations, frequency, and all those things. It was the topic of my interest at that time. And I have been doing more than 150 projects till now throughout India for doing something on this. So especially I will be limiting myself to open cast mines because it is very difficult to understand underground mines. So I don't want to put you people under that much trouble. So surface mines only. So please, next please. So before I go into something, just I would like to say that here what I will be showing. Awareness to our geophysicists, geologists, and my right side, next generation, what I could see, they are, for me, they are looking like directors of NGRA after some time, CSIR labs, right, ONGC, and NIO. They were my very good friends before. Then, so related to that, I will show some clippings so that after taking good lunch, you should have some break. So you will enjoy, I don't know. It is going to damage, of course. Then some photos of whatever, no, they don't. So whatever, when I say next, then you do. Acha. Then some recent studies in our place. So I was a chairman of implementing NEP 2020 at our NIT Rourkela when it came, and for our mining department especially, I was there. So recent study, because we aim for local to global. It is not that I will go to America, do something and come back and do no. Unless I understand my local problems. That's what I used to encourage. I have more than 20 PhD scholars now working from different agencies, different disciplines, all disciplines. So where it should be like a local to global, whatever we are aiming for, as a very good, inspiration from our president of CSIR, because I was an infant scientist in 1980s. That's why I take him. And now president, of course, our Narendra Modi Garu. So that first you should develop try to solve the problems, try to understand your problem around your institution. If it is Andhra University, then around Andhra University, what are the problems? Of course, in the respective disciplines. So that's what is, I don't say whatever is given in NEP 2020 as a multidisciplinary, that is a limited scope, but I say 1-2 steps ahead. Transdisciplinary, translational, transcendental research, industry-oriented research and academics. That's what we have been promoting since 2006 from NIT Rourkela. And little bit I will show what is happening around you in Andhra, Telangana, some mines. Recently, we are doing a lot of projects on this blasting, how it is going to affect. And as a geophysicist, of course, what you can contribute, depending on your interest, I will tell. Then rock mass plot, based on that, whatever damage criteria and all principles, I will not go much into all that, which is already available in your fingertip Google, if you write. Those things I will not, but maybe there, we will simply pass on. Our Simakshi madam has been helping me, your student here. So ground vibration, then coming to that design guideline, and especially I would like to say more on what are the thrust areas identified. As a member of Ministry of Coal Apex body, R&D Coal Board Committee member, I used to encourage people to give from different institutions, multi-institutional, transdisciplinary projects, because as a mining engineer, core scientist for 2 decades, I try to solve something, of course, but it is not possible by only mining engineer. I need help of each and everybody from first row to the last row, right? So we need all that. And here just I would like to show some blasting clips are there. Simakshi madam, thoda open please. Right. Yeah. So till it opens, basically the issue here is whatever blasts you have been hearing other than mining blast time, because that may be a landmine blast for some other purpose, or from your Deepavali blasting, whatever. So, but here it is, we use even 50 tons, 100 tons of explosives to blast at a time. Now you can understand how difficult it is, because it is going to cause lot. Yeah, now you can see. So now you see the blasting in between. एक इतना प्रशांत में चल रहा था, बीच में ऐसा ब्रेक हो गया blast करके. So you go to the next clipping, please. These are all the mines which are nearby. I mean, in Telangana and Andhra Pradesh. Recently, I was doing something for them, investigations, and this is another. Some mines are my home, related to my home industries, Ramco Cements also, and your KCP Cements. One of these, I suppose, is in Andhra, that is in the border, Telangana and Andhra. This is another blast next. बहुत ज़्यादा नहीं दिखाने का, लोगों को ज़्यादा नहीं पहुँचेगा. This is another. Yes, go to almost middle. You see such a beautiful place. हम लोग as a damager आ गए या mining engineer, फिर उसको blast कर दिया. But unless we do blast, then how you are going to excavate? Of course, there are so many technologies. I am not going at present into that. Middle se ज़्यादा जाइए. Only blasting you should. So these are different chest blasts. Then involving so many tons, 40, 50, even 100 tons. That much big blast we do. So this is going to cause lot of damage. Then further, lot of studies were done. Yes, now you are seeing so much of fly rock, noise generated, even noise studies, then ground vibration studies. All these studies are required to, so that we will design a proper safe design. That's what I'm going to say, and what we have done, I will show. And those who are interested from first bench or last bench, we can discuss later also. And you can get involved. Now we have 23 mines ongoing projects now, which I am taking up, are already in progress. Now coming back to the PPT, please. Take a third. I take it, this fine. And go to the PPT. इसको escape करके बाहर आइए. Escape बाहर आइए. Yeah, as I was telling about. Okay, now when we say something, I used to give, already food is given by our organizers. Naidu garu manchi mutton biryani kuda tinipincharu, right? So I need not give a lot of food for you, but it is for the right side, right people here. So it is very pathetic situation, whether they are engineering side and other sides. I cannot comment on other all departments, at least we take mine or whatever. So 80% of graduates are not employable. So already from the first speaker today, skill development and so many things we have been discussing. Go to the next, please. Yeah. So what we wish is our next generation. They should be like when they come out of the college, institution, university, wherever they are. They should be something like a chicken, KFC chicken, right? So ready to be used by the industry, by who are the customers for them. But right, they should be like that. That means they should have not a degree on the paper and roaming on the roads with the paper degrees, but with the skills to solve the problems, not the problems in UK or Canada, but problems of our local, where you are, because you know better than anybody else in this world. So we should aim for that. And then if that is done, now if there may be some similar problems in other countries or other states, other districts, whatever it is, wherever they are, they should be able to utilize our norms, guidelines, what we do. That should be our aim for the students, especially. Next. So for that, already I said in the beginning, it is innovation-driven industry, and that's a transitional reduction. This is not my word. This is in the CSR policy. It was there already. Right, next. I'll throw fast as I can. Whether it is NEP 2020, since I am from mining, I try to give some national mineral policy also, but I am not going to discuss here. So I kept in a very elaborate way here. So already we have a lot of funds. That's what I was telling. And unfortunately, I'm a member for that coal R&D board, Apex committee. So where up to 5 crores we can sanction the projects. But that should be useful to solve not the problems in America to Trump, but our problems in our local area. We prefer to give funds to them. So ultimately, when it comes to blasting, the key is always with the blaster. That he is supposed to have, even the grassroots person who is loading the explosive, they should have proper knowledge, right? And of course, we are having geologists in almost all the mines. And geophysicists, especially, it is not there, but in the headquarters, we'll be having in that way. So this requires in future. So more and more specialized people are required, since we are going into more and more complex mineral deposits to extract. So these are the requirements in future. And of course, this is just, I said, there are so many guidelines, controls given by Chief Inspectorate. And now it is a PESO, of course, DGMS and other. So we have done a lot of research already, I said, in 1988 from IIT, BHU too. And so next, please. Using so many things in different mines, whether they are coal, copper, bauxite, limestone, whatever it is. So we have all that data. Now our geophysicists can utilize that. And recently we have conducted one international conference along with one of my good friend, Trilo. He's a director of IIT Patna, he's a geologist. And in that also we involved all these organizations. Mining Geological and Metallurgical Institution of India, Mining Engineers Association of India, Indian Mining and Engineering Journal, for which I have been a chief editor for a long time, 1.5 decades. All that, we involved all these people, geology, geophysics, everybody into that. Next, please, next. That is just to show some glimpse of that, sort of fast, some photos of fast. So these are our team of CMDs, directors from IITs and other places, NITs in that team. And of course, this is what just I wanted to show. Yes, sir. 2 minutes, right. These are some thrust areas already we have given in Ministry of Mines or Ministry of Coal website also. You can go through that. Only few I kept it here, not many. Right? That means application of IoT. All the time we say artificial intelligence and wireless sensor network, IoT and all. There are so many areas, including robotic technology and all. Next, please. Next. So I am dedicating that, as I have seen one of our speakers, to my teachers, because this is especially in our academic institution, I kept this, to my teacher, Professor R.D. Singh from Usmania University. Of course, he was HOD in ISM also. And my PhD thesis, Professor D.P. Singh Saab, then Dr. T.N. Singh Saab was the director and vice chancellor, like that. So this was just I have so many things, I am not going much into that, but we can discuss. And my main interest is to encourage and inspire those who are really interested to contribute something, not to US or Australia, but here, to solve the problem around your, since we are talking now, be Roman when you are in Rome, right? around the earth, we have so many problems. As long as geophysics and mining are concerned, if anybody is interested, we have no dearth of money in our ministry, coal and mines, that much I can say. And we can do a lot of things, multi-institutional projects. So thank you very much for giving me this opportunity. And at the outset, congratulations for achieving this milestone of 75 years with such an exemplary success that they are conducting this event. All the best to everybody, please.
Thank you for this excellent talk.
Thank you, sir. Sir, I request Professor SKG Krishnamacharyalu to come on to the dais in first state. Thank you, sir. Krishnamacharyalu sir is my teacher, and he worked as a dean at Andhra University. And he's the one who wrote the song today. What you have listened, he has written the song. We are so happy to have him here. Thank you so much, sir.
Thank you.
Thank you so much, sir. Thank you. Thank you.
Since our theme is related to sustainability, then I have just only 30 seconds to say about that. When it comes to fulfilling sustainable development goals, sustainable mining, I used to say that when you consider our Mother Earth as our own mother, and we are all taking minerals like a milk from the mother, all the public, it can be sustainable only when both activities are with pleasure and happiness and comfortability. That means when they are giving the minerals, her mother is giving milk, she is happy, no doubt. And when son or daughter, whoever it is, right, baby is taking milk, they are very happy. That is the reason it is sustainable, that we are getting these generations going. Even if there is any problem in this, we have no existence to continue. This is the simplest way of Mother Earth, babies, all the human beings, or anybody, of course, right? And milk, minerals. All the best.
Thank you. Thank you very much, sir. Now, Professor Solomon Raju is here by chance. Otherwise, I request my co-convener to provide all comments of all the speakers. Just a minute.
Thank you very much, sir. Thank you so much.
Yeah. First of all, I'd like to thank the organizers for giving me this opportunity to co-chair this very important plenary session, which is talking about energy sector, which is like order of the day. In this session, we had 5 talks, of which one Dr. Solomon Raju sir was not present here to some commitments, I believe. So in of all the four talks, we just started with Dr. Harnana's talk. It is very motivational presentation, I should say, because it gave insight into the various means and possibilities for here. This is the time for you to just follow whatever sir has said, and trust me, this is 1000% true what he has said. Without communication, without proper knowledge, it is going to be very difficult. And it is true for all subjects of science, especially for geophysics. If you really want to make a mark, geophysics being an applied science, you really have to gear yourself using the inputs given by sir. As sir has promised, I think he will leave the presentation with the department. So please go through that and pick up all the open source codes and the open data which is available. The next talk was given by Dr. BBK Patro, which threw light on the alternative energy scenario of the country. So in the present day, energy crisis is there everywhere, and government is having huge initiatives to look at the alternate energy sources. These days, there is very high emphasis on geothermal energy, and Dr. Patro's talk has covered the complete suite of things, right from acquisition, modeling, and probable exploration of geothermal energies. This is one very latest and emerging field which is going to have good demand, and I also this is one field which the young geoscientists who are coming from the department to just have a look into this field of science. The next talk, a little bit different from the conventional science, but still a very relevant issue, which was handled by Dr. Kesar Murthy Garu, pertaining to rainwater harvesting. This is a burning topic, the water crisis. It is there all through the country, and his talk has given us some light into handling this issue using simple but very effective ways, which will help water sustenance. It's also a very glaring example of local support, which will help in converting the knowledge for societal benefits. And it's very commendable at his age to take up this kind of initiatives which have social relevance. The last talk, yeah, all the time we are talking about energy exploration, finding, and all. That's all fine. But the last talk given by Dr. Singham Garu, it actually addresses a very key aspect, which is proper management of the exploration techniques. Finding resource is one end of the spectrum, and finding the proper sustainable exploration is the other end of the spectrum. Unless these two go together, there cannot be energy sustenance. Safe practices for protecting the mine sites is very important, especially in the mining sector, mining for coal, all the more, because they always are in the thin beds, and they are relatively delicate to handle. So this session essentially had all four talks covering from directions to present day situations pertaining to energy, water, handling, and everything. And with these few comments, I think this session, I think this session is closed for now. And I'm handing over this mic to Srinivas Garu for the next process.
Thank you so much, madam. Thank you so much, Dr. T. Harnaran Garu and Satyavani Garu. I request Dr. C. Shivaji Raj Garu to come onto the dais, please. Shivaji. Ex-Vice Chancellor, Tavera Institute of Medical Sciences. I request him to Felicitate.
Was also head of International Division in Department of Science and Technology, New Delhi. Please. Madam, you should be felicitated. I don't want more.
Very good afternoon, my dear colleagues and friends, my seniors and my juniors, all the respected alumni. It gives me a very immense pleasure to join this morning today. And it's a really very nostalgic moment for all of us, particularly me also. I have been visiting the department a couple of times before on official capacity when I was in the Department of Science and Technology, Government of India. And then we keep moving to various places. And as long as I was in Delhi, any person coming from not only from our department of AU, but anybody from the Andhra University, we used to entertain and we used to spend a lot of time and finding out and monitoring their activities and then mentoring them how to write and submit the research projects to the DST. And particularly, even if they are from the other, even arts department also, they used to meet me, and then we used to spend a lot of time. And thanks to the department head, Dr. Naidu, and his team, for their Srinivas and all people, who actually done a very commendable job of bringing all of us together in this very interesting platform. I think this is the first time that the department has organized this kind of alumni meet. And it is really very wonderful for all of us to keep in touch with each other, not only for the academic purposes, but also social purposes. Like K.S. Murthy and all, they have been doing a lot of work for the society relevant activities also. But we should, in order to keep moving within ourselves, as well as to know about the activities what one is doing, and we need to keep. I'm sure that when Dr. Harinarayana said 100 year celebration, also he wanted to. I'm sure it will happen. But I think every year we must meet on such occasion. Maybe next year also. It should be a continuous activity. So that people keep coming and then meeting, and also find out who are all there in the department, and not only that, we all have to take another responsibility of giving back the knowledge what we have gained through various positions we held at several departments or the national institutes like NGR and all. And the most beneficiary is the student. So when we are student, I'm sorry, I forgot to mention, I belong to the 1984 to 87 batch. And it was very joyful moment as a student. And then we used to do a lot of field works near MVP Colony and Setamadar and all other places. And now when you look back into the department, and the faculty, a lot of faculty crunch actually. So that's what really bothers me. And I don't know, this is very kind of a perennial problem. Socio-political, economic, whatever you say, is really a problem. And nobody is able to address the problem of faculty crunch. The day when we were studying, there used to be more than about 25 to 30 faculty members of eminent faculty members. In fact, in my personal capacity, I never used to read any textbook or so for the exams. So whatever my teachers tells in the class, we used to prepare hand notes and then study those things only. And it's really, when our library also very rich, the departmental library, and most of the reference books and all we used to get it from our central library. And the teachers are most important part of the academic institutions, particularly university systems, because we all come from degree after BSc, become or whatever it is. And there are a lot of difference in the teaching of faculties who work in the degree colleges and then university. When we enter into the campus of the university, particularly our university, it really gives a lot of pride when you enter the campus first time. And when we really used to hear the teachings by the eminent professors in our department particularly, what a wonderful experience it was. And I think we keep moving forward in this direction. Once again, I thank the department head, Dr. C.V. Naidu and his team for again bringing all of us together and meet each other and discuss the programs. So one thing I have a suggestion for the students. You never take back seats and come front and then hear whatever these people are actually making presentations. For example, when we consider Vani or Dr. Harinarayan or Patro or whatever. So this is a kind of lifetime presentations we are hearing. They throughout their life they dwelt in the magnetotelluric techniques or any geophysical interpretations. You can't find them in any textbooks, right? So whatever they are telling, it is their own work they have done. We must have read the G.V. Keller and Dobrin and all those books, Highland. But this kind of case studies, particularly from Indian continental, yeah, it's nobody would have actually made such presentations even if you invite the foreign geophysicists also. Therefore, my only urge to the students that you keep your ears and eyes on the people who are actually making presentations, and this is a very good opportunity to all of you. This is actually real geophysics. It's not a textbook geophysics. So this is experimental geophysics. They have done a lot of experiments on magnetotellurics and telluric studies, geomagnetic, gravity, and all those things. And then they are making the results here, including the interpretation. So that's what my request is. And once
Excellent.
again, I thank all of you to come here and then.
So I am sure you are still keeping connections with the DST International. So whoever wants to go abroad, contact him and take his guidance. He will give a good connection to DST through which you can visit outside countries also. So thank you for your very nice message. You can see yesterday, well today, our geophysics are in banks, our geophysics are in institutions, our geophysics are in organizations, and our geophysics are become vice chancellors also. So this is the thing. He has under his guidance in Savita Institute, no? Savita Institute of Medical Sciences. See how medical science geophysics they have chosen geophysics. See, we are in demand in every place. Thank you very much for your golden words, Dr. Shivaji. We wish that you will visit your department again and again, and then give a message and then guide us to our students. Thank you very much.
Thank you, Chairman.
Thank you, sir. Thank you so much. We will move into the next session where Dr. Patro will take over. He will be the chair for this session. Please come on to the dais, Dr. Patro. I request Professor SKG Krishnamacharya to come on and do the co-chair.
Hello, good afternoon. I think we are running quite late. Actually, in this session, there are 9 talks are listed, but I'm not sure how many talks are loaded here. If any authors are there, please load these talks. But still, we'll go ahead. In the meantime, people can come and load their talks. The first talk is by Dr. Imani Parmeshwar Garu. He will be talking on geophysical exploration for geothermal energy. In the meantime, I request all other speakers to load their talk so that we can conclude the session maybe probably on time. Yeah, the next GJ Rajbab is loaded. Yeah, and Dr. A. Venkatarao Garu. Yeah, another A. Venkatarao Garu. Same, okay. And Chandrababu Garu. Yeah, good. And Sovan Kumar Ray Garu. Yeah. K. Lakshminarayan. Okay. P. Satrana Garu. Yeah. Hasib Rahman ji. Okay. So I think most of the talks are loaded. Yeah. Sir, since we are already running late, I request to make the presentation in 10 to 12 minutes. And after this, yeah, I will announce you before the time. Just please go ahead. And after this, maybe we'll have a tea break. Yeah. Okay, sir, please.
Respected Mr. B.K. Patro and Sri Krishnamacharya and faculty members of Geophysics department and distinguished guests and expert scientists and geophysicists sitting in the assembly. I would like to submit that during a long service of 38 years in OITC, no geophysical party for the exploration of geothermal energy existed. With the result, I have no experience in the field work of geothermal prospecting. I prepared notes, it's not a paper, in the form of a PowerPoint after reading published papers by experts that I received in my mail messages. And it is funny to speak about this geothermal energy exploration by sitting near an expert already who is sitting in Mr. Patro. Anyhow, I request not to consider me as an expert in geothermal prospecting. The zeal of participation to be present in this seminar on the occasion of Platinum Jubilee celebrations of my parent Geophysics department sparked my interest to present this notes on geophysical exploration for geothermal energy. Kindly grant me the permission to go ahead. Before starting the presentation, I would like to read some of the things. Geothermal exploration essentially involves the application of a number of geological, geochemical, and geophysical techniques for reducing well productivity risk. The aim is to apply the most appropriate techniques to minimize uncertainties associated with the estimation of temperature, depth, productivity, and sustainability of the geothermal resource in the specific circumstances of each project. Selecting appropriate techniques at the correct phases of an exploration program is important for optimal efficiency and maximum risk reduction prior to the test drilling phase. Experienced interpretation of data collected with these scientific techniques enables a geothermal geoscience team to develop a conceptual model of the heat source and fluid flow geothermal system
No single exploration technique provides this key to a successful conceptual model. And uncertainty, no conceptual model can be confirmed except through pre-test drilling. Interesting to note that a recent review of drilling data for our 2,600 geothermal wells around the world found that the success rate for the first well drilled to test a new reservoir was about 50%. The average success rate rose to 59% over the first 5 wells, to 74% during field development, and averaged 83% for wells drilled in operating fields. A previously carried out survey on the majority of the more than 4,000 geothermal wells that had been drilled worldwide, widely different success rates were encountered during the exploration phase. Geological mapping. In geological techniques, a preliminary mapping of the selected prospect is performed, such as major geological units, tectonics, and volcanism. Thermal manifestations like hot springs, fumaroles, etc., and alterations are also mapped. The physical properties of surface manifestations like temperature, flow rate, conductivity, etc., are measured. Detailed surface mapping, structural analysis of faults, interpretation of satellite images, analysis and evaluation of mineral distribution, age dating of geothermal manifestations are essential for successful exploration. Three-dimensional geological models are the foundations of geothermal exploration. The majority help in the interpretation of geochemical and geophysical signatures of geothermal systems. The application of geological techniques can provide valuable insight into the behavior and evolution of active fracture-controlled geothermal system. Permeability distribution, fluid flow patterns, and distribution of fractures in the area are also evaluated in geological environments. Without a good understanding of the geology of a prospective area, exploration is a complete guesswork. The expected geological findings are summarized as follows: heat sources, magmatic intrusions, etc., permeability, possible fluid flow paths, reservoir, permeable rocks, fault pattern contacts, possible geohazard risks, conceptualizing subsurface conditions of an area. Importance of geochemical exploration methods are extensively used and they play a major role in preliminary prospecting of geothermal resources. No single method is universally superior, but electrical methods and geochemical surveys are usually useful to delineate geothermal prospect. The epitome of exploration is to determine the existence of a geothermal resource and subsequently identify suitable drilling sites based on integrated data obtained by all exploration methods. Geothermal exploration is normally carried out on a step-by-step basis, with each of the phases involved aimed at gradually eliminating the less interesting areas and focusing on the most promising ones. A dynamic approach is important for future investigation in area of geothermal exploration. Successful surface exploration will avoid unnecessary expenditure when the prospect of such kind enters in the development phase. Now I want to show the presentation now I have made it. Yeah. First one. Next.
Next. First one is an abstract. I don't want to read. Let me read anyhow. The increasing demand to develop renewable energy resources has driven a surge in interest in geothermal sources, both for power generation and for direct use of heat or a combination of both. The most economically attractive geothermal projects are those that exploit a naturally occurring high temperature hydrothermal reservoir. Finding such reservoirs requires a dedicated exploration effort. Geophysical techniques are principally used to map subsurface structures that help identify and define geothermal systems such as fracture work, faults, lithologic changes, heat flux, the presence of fluids and permeability boundaries. Geophysical exploration of geothermal resources deals with measurements on the physical properties of Earth. The emphasis mainly on parameters that are sensitive to temperature and fluid content of the rock, or on parameters that may reveal structures that influence the properties of geothermal system. Introduction. Geothermal energy is the form of renewable energy stored in the earth that can be pumped in the form of steam or hot water, which can further be used to generate electricity. Wide variation in earth temperature, ranging from room temperature to well above 300 degrees Fahrenheit, allows using geothermal energy for a wide range of applications. Depending upon the quality of geothermal energy, it can be used either directly in the form of steam to run a turbine or to vaporize a low boiling point fluid that can further be used to run the turbine. Geothermal energy is a proven technology for electricity production. By 2010, more than 10,000 megawatts of energy was supplied by geothermal energy in 24 different countries across the globe, serving more than 60 million people. Next one. First, geothermal power plant. Geothermal energy is derived from the thermal energy generated and stored in the earth. The origin of this word is from Greek. Geo means earth and thermos meaning heat. The term geothermal was coined by the Italian scientist Count Francisco di Lateral in the 1920s. Lateral was the first to successfully harness geothermal energy to produce electricity. He developed a geothermal power plant in Tuscany, Italy, which is still in operation today. Next one. Geothermal energy for generation of power. The geothermal energy is derived from the thermal energy generated and stored in the earth. The energy is accessible by heat transfer from rocks to the surface, either through boreholes or natural cracks and faults. Geothermal energy is a renewable resource because there is a constant heat flow to the Earth's surface and the atmosphere from the immense heat stored within the Earth. Geothermal energy is a commercially proven renewable form of energy that can generate power and provide the heat without additional consumption of fuel or other resources. A high temperature geothermal plant can directly use steam to generate electricity when the heat reservoir temperature is higher than 150 degrees centigrade. However, it requires a sizable geothermal reservoir at a certain depth and high temperature. What is a geothermal reservoir? The heat from the Earth's core continuously flows outward. Sometimes the heat as magma reaches the surface as lava. Well, next. When water is heated with the Earth's heat, hot water or steam can be trapped in permeable and porous rocks under a layer of impermeable rock, and a geothermal reservoir can form. The hot geothermal water can manifest itself on the surface as hot springs or geysers, but most of it stays deep underground, trapped in cracks and porous rock. This natural collection of hot water is called a geothermal reservoir. Surface manifestations. Magmatic place, next. Magmatic plays commonly show surface manifestations of an underlying geothermal system. Fumaroles, hot springs, mud pools, and geysers are all indicators of a possible high temperature geothermal system. The flow of gases and hot water inside these geothermal systems are controlled by small fractures and faults in the volcanic rock, where surface indications of an underlying geothermal system are observed along the fault planes at the surface. Last one, I will go for it. Title take, geophysical expertise. Yes. Last thing. Okay. 70 slides. This is actually, this is one of the heat reservoirs. We get some lava that is not coming out. It is stored inside and it becomes a reservoir, heating the water there. And another one is the previous one. This one is actually the lava comes out of this one onto the surface, eruptive magma chamber. This is another geothermal reservoir, which is actually 250 to 300 degrees centigrade. This is a relatively shallow magmatic intrusion, relatively hot volcanic gases. In Iceland, you find this type of geothermal reservoir. Now I go to geophysical, because the title itself is geophysical exploration. Direct methods, drilling and logging temperature and pressure, measured using sensors in wells are the direct methods. Porosity and permeability assessed using core samples and well tests. Fluid chemistry obtained from fluid samples. Indirect methods, geophysical surveys. Electrical resistivity and magnetotending indirectly estimate temperature, salinity, and fluid presence. Seismic surveys indirectly indicate porosity and fractures. Gravity surveys detect density contrast related to reservoir characteristics. Heat flow studies combine thermal gradients and conductivity measurements to estimate subsurface temperature. Gravity method. Gravitational field variations. The Earth's gravity varies slightly due to changes in the density of subsurface rock and geological structures. Denser materials produce positive gravity anomalies, while less dense materials cause negative anomalies.
Gravity measurements are conducted using highly sensitive instruments called gravimeters. Data are connected for effects like topography, latitude elevation, tidal influences to isolate the anomalies caused by subsurface density variations. Gravity method is a powerful tool for regional and structural analysis in geothermal exploration. While it provides valuable insights into subsurface density variations, its best results are achieved when combined with other geophysical methods for detailed subsurface characterization. This integrated approach helps reduce exploration risks and improves the identification of viable geothermal resources. Next one. In geothermal exploration, gravity method is used to map geological structure. Oh, I will skip this. Already gravity I have done. Next one. Magnetic method. Magnetic method for prospecting for geothermal energy. Magnetic surveys identify rock units with contrasting magnetic properties, such as igneous or metamorphic rocks, which often host geothermal reservoirs. Volcanic regions, common locations for geothermal systems, often have distinct magnetic signatures due to their composition and cooling history. Direct heat sources, high temperature geothermal systems are often associated with magmatic intrusions. These intrusions are typically composed of ferromagnetic materials like magnetite. Magnetic methods can identify these intrusions by detecting high magnetic anomaly zones. Next. Okay. Practical application of this also I will just actually this principle is very neat. Estimating the depth to the Curie point isotherm to infer geothermal gradients. Locating fault zones and hydrothermal alterations indicative of active geothermal reservoirs. Okay, I will skip this. Next one. Seismic method for geothermal exploration. Identifying reservoir structures. Seismic reflection and refraction methods can map subsurface layers and structures such as faults, fractures, and stratigraphy. These features often control the flow and storage of geothermal fluids. Faults and fractures act as conduits for heat and fluid movement, while impermeable rocks can act as cap rocks to trap geothermal fluids. Locating heat sources, seismic methods can help identify magmatic intrusions or high temperature zones that act as the heat source for geothermal system. High temperature anomalies often correlate with areas of low seismic velocity due to partial melting or high fluid content. Reduction. Okay, I will go to magnetotelluric. Already, Mr. Patra has dealt with magnetotelluric method. It's a geophysical exploration technique based on the principle of measuring natural variation in the Earth's electromagnetic fields to infer the subsurface resistivity structure. 24. Principally, the MT method utilizes naturally occurring electromagnetic fields from two main sources. Already Mr. Patra has dealt with it. Low frequency EM fields, high frequency EM fields, and electrical resistivity and geothermal systems. Interpretation already Mr. Patra has done, and next, the figure is so. Next one. Yeah. This is the actually 3D interpretation model done by NGRI, Hyderabad, in Ladakh area, in Kuga area, which is having lot of geysers and tumors. Next is radiometric methods. Next slide.
this because there is no time. Then ground-based radiometric surveys are also can be used for this. Electrical resistivity surveys are also very important, actually, because the resistivity soundings are one of the best prospecting tools for geothermal reservoirs. Resistivity of volcanic rocks. I'm skipping everything. First thing is, this is very important, the conductive zone that commonly lies above geothermal system has been shown to have a strong correlation with temperature between 70 and 200 degrees centigrade. The cause of this has been linked with the type of clay alteration that occurs in this temperature range. This is due to clay alteration. The pectite cap or clay cap typically displays resistivity of around 2 to 10 ohms, and the mixture layer a few tens of ohm meter. Oh, I will. Fine. This one actually is a factor that clay, this one, that is clay alteration, is having less than 10 ohm meters. A mixer layer is having tens of ohm meters resistivity. This is actually the principle for electrical resistive method to map the geothermal reservoirs. This is clay alteration. Lastly, method, topography method, there are so many transit electromagnetic methods. This is taken by the so 47. The collision of Indian plate with the Eurasian plate. This one. The resulting Himalayan geothermal belt runs from parts of India to Tibet, China, and Myanmar, China. The 150-meter wide region extending from 3,000 kilometers in length is believed to have hundreds of geothermal fields that can generate electricity. This can be, of course, identified by electrical resistivity surveys or active surveys and all. Now I want to conclude by two tanks, that's all. Some of the field examples are not there. Field examples. Our geothermal provinces. Take it. Yeah. These are the provinces of India where potential geothermal provinces. These are Himalaya, Campi, West Coast, Karnataka, Godavari. Next. Field examples are there in Mexico, regions of California. They are very much successful producing generating electricity with the help of geothermal forms. Thank you.
Thank you very much, sir. Thank you. Sir, 20 minutes, 25, 2 minutes, or 23 minutes we have given. 27 minutes, sir. Your talk was 27 minutes. Thank you so much, sir. Sir, we would like to felicitate you. Professor, I would like to call upon Professor P. Ramarao Garu to come on to the dais. State Parmeshwara Garu, who is a general manager, who was a general manager in ONGC. He retired in the year 2005. So, sir, we are very familiar with him because he takes gate classes for our students. See, all these notes he prepares, and this is what He loves physics so much, and he loves our students so much. And he has prepared so many presentations for our students. And I would call upon Professor P. Ramarao to felicitate Parmesh Rao.
Yeah, it's very great opportunity for me to felicitate Parameshwara Garu. I came to know him when I was the head of the department. He, I think, lived in Kakinada. Contact, and he himself offered that I will be coming and teaching your students. And if I am not wrong, he also used to teach students if they are interested, let them come and meet me, and I will seismic methods, many things, and even PPTs I think he sent me, and apart from that, donating books. And so, sir, really, you are very great, and I feel very honored, in fact, to felicitate you, people like you, and I thank you very much. Thank you.
I have got some disability. What insomnia? So I. Thank you.
What?
So we'll have a break now, break for tea. Maybe 15 minutes, and we should come back here in 15 minutes time.
Since there is a delay in T
Okay, okay. I think tea has come. Let's finish it. Let's finish it.
No, I guess tea has come. Tea has come.
Okay, we'll continue with our session. I request everybody to please come inside. We'll now begin our session. We'll continue the session. The next talk is by G.J. Rajbab Garu. He'll be presenting on imprints of nuclear magnetic resonance in hydrocarbon exploration. Hello, Babu.
Sorry to disturb you. Dear friends, see, in our department, we are arranging exhibition stalls. So, yeah, many stalls are there in our department. So, kindly visit our stalls and enjoy. Because number of organizers came over here and started a stall here. So, that is exhibition which will be open to all the degree college students of Visakhapatnam. So, our aim is we should know what is our geophysics. So we should have some clear awareness among the students of our Visakhapatnam Degree College, so that initially we started our exhibition, which will be there in our department from 17th to 19th. That is today just it's opened by principal of AU College of Science and Technology. Just now it's opened. Now 18 tomorrow and 19. Please visit, sir. Please visit. Thank you very much. Thank you very much. Yeah, tomorrow and after.
But I require it so that I can or hit them. G.
Respected Chair, Dr. Patro, Co-Chair, Charigaru, Galaxy of Geophysicists. I'm somewhere in between. You are from Paleozoic to the recent period of geological scale in geophysical department. I will not take much of the time. I promise you I will not talk irrelevant. I will not leave any relevant. The topic I'm going to talk about is nuclear magnetic resonance, its role, its usage in oil exploration. This is a tool, well logging tool. I'm going to touch upon measurement, petrophysics mainly, and a little bit of general what is nuclear magnetic, etc. Okay? Yeah, believe me that I won't bore you, surely, and I'll be on time, I assure you. Yeah, next please. So, needless to introduce myself again, Rajbab. This is my main agenda, general introduction to NMR, nuclear magnetic resonance. Basic theory, every one of you knows it, but I just want to brush. NMR measurement, what is this measurement? I'll bring it to the context before I go into that. And petrophysics. Petrophysics, everybody knows all of here. And I made it especially focused towards the students. So please be attentive. Maybe you may get a question on this in the interviews. Sometimes you will remember from subconscious nature. Okay, next please. Okay, next please. Anta telusan anukomokandi. That's what I believe. Believe in your own self. Now, the general medical fraternity, they use it. All of us, we know MRI. And then that is the spatial distribution of the hydrogen atom. That's what they see in our skull. They know the theoretical part. And if there is any damage inside, the hydrogen population gets or clusters in some places. So we make this NRI responsive to the spatial distribution. I'll just touch upon it when I see the theoretical part of it. Okay. And very recently in Eluru, most of us are Telugu in nature. So there is an unfortunate incident in medical history. This MRI was being done by an inexperienced, not at all experienced fellow, and the old lady, which is being subject of MRI, has a pacemaker, and the pacemaker, it's very high intensity magnetic fields are generated by these. I don't have a pointer on the top of it. That entire circle is an electromagnet. Very high intensity of static magnetic fields it produces. If you have any loose iron thing, it flies like a bullet. So that lady, she was really struggling, and the fellow, he said that, hold, and she died. Sorry, I don't want to just, start with a sad incident, but be aware of these technological advantages and go forward. Husband was saying, my wife is dying. But the fellow, okay, it's in the papers. It's in Eluru. I don't want to name the hospital. Okay, in chemistry, NMR is used in molecular structure. Suppose if hydrogen is attached to chlorine or carbon, its behavior will be different. That can be captured in NMR spectroscopy. We are not going to, in oil industry, we are not going to do NMR spectroscopy. It is called relaxometry. Difference I will tell you as I go forward. Okay. Material science, change of properties. Whenever an atom gives out a radiation, and being a part of the molecule, it changes the properties of the material. So that can also be taken care of, rather measured by NMR. And in petroleum exploration, of course, we do bottom something like a skull only. That's a rock. Grains are there. The intergranular porosity is there, where the oil and gas or water sits, and we activate that and see the responses and talk about the petrophysics. That's what it is. Next, please. Yeah, before where this tool is used, before I go to the tool, in fact, everyone knows we have upstream and downstream of oil industry or petroleum industry. And now there is a midstream. So the upper part, that is the upstream, all exploration and production, all ONGC stalwarts are here. This is for you, not for them. So I'll stand on the other side. I think I'm impeding you. Okay, next please. And there are two physical, geophysical branches in a nutshell. Everyone knows, but still I'm bringing it to the tool where we are using it. Next, please. What is the seismic? You know, we see through the subsurface by the seismic methods. Then the seismic waves get it reflected, find out the times, and then convert them into structure. So you know the possible places of oil, gas, and then water by doing this. This is seismic. Next. Oh yeah, this is logging. Once you know the structure, we go and drill it. Just click it, Babu. Just click. Okay. So this is drilling. I made it to make it, some image to that. That is, we have drilled through the well. Then a logging tool is brought. Please click again. This is the logging tool. Of course, I couldn't make it better than this. Made by my hand only. Next, please. The tool is lowered. And next, please. Now, this tool, it emits either electrical currents or gamma rays and etc. Activate the formation and get all the properties, which are each depth we record it, and this curve is called a log. Okay, so this is the NMR tool, what I'm going to talk about. Okay, one of the tools, it measures some properties. What properties I'll try to tell you. Yeah, as I say, it is more focused towards my students. I was told that, the nuclear physics students and geophysics students will also be there. So I try to focus it on to you rather than my seniors or my junior colleagues. Next, please. So that's where we are. So logging comes here. It's, the oil industry is a combination of everybody's toiling. Everybody's, inputs come into this. Geology, geophysics, drilling. Geophysics, surface, because as I told you earlier, that is surface geophysics, see the structures. And I'm here, well logging. I was heading it in KG offshore for 8 years, well logging section in KG offshore. Okay, next please. So here is the rock. What I do? What is this logging business? Okay, click. Now this is the structure we have. A small part of this I have taken and amplified it. There are rock grains, there are porosity, where the oil and gas sits there. Now my business is to see whether they are the small pores, big pores. What is the porosity? Porosity is the pore space within a rock, wherein the oil can go and sit, or water can go and sit, or gas can go and sit. Only three we have. We are lucky enough because nature has given only 3 fluids. Otherwise, we have to make some other measurements. Okay. Next, please. Okay, NMR, go ahead. Okay, here is an important thing. Whenever you want to measure any of the physical parameter of our formations, formation stands for non-reservoir, reservoir. Sometimes we use a rock. So this rock is composed of a solid frame and a void frame. And the void is filled with fluids, as I told, 3 fluids. So I'm going to activate these fluids, Especially, we are going to activate hydrogen atom. Hydrogen atom is 1 proton. And 1 electron is there, of course. And now I'm not going to talk about the electron, what is its role, but this proton, what is its role? It has half spin. What is this half spin? It acts like as if something is, rotating on its own. Oh, I have 2 minutes, but I request, I'll go faster. So NMR actually manipulates this hydrogen atom, which is plenty in hydrocarbons. Okay. And it has a wonderful NMR active properties. So we apply the static magnetic field, next please, to align next please, next, again next. In fact, just wait. So what we do is that this is the tool, and in the tool there is a very powerful magnet. It aligns on its own direction the hydrogen population in its own direction. But the thermal, the phenomenon is that Some align parallel to that, some align non-parallel, I mean anti-parallel to that. Only two orientations are allowed by quantum mechanical laws. Okay. Why I am doing all this? I'll try to get you. Next, please. Yeah. Now you see, in absence of a static magnetic field, all these they orient themselves as if a teacher is not there. So all students they talk here and there. But once the teacher comes, that means magnetic field comes, and they reorient themselves in parallel and anti-parallel. As I told you, you'll have to believe the quantum mechanics only. I may not be able to talk much on that, though I would love to. Okay, then once this alignment is there, there is a magnetic field generated by the hydrogen atoms within the fluid. I request my chair to give me a little more time so that I'll go fast. Don't worry on that. If the audience doesn't want, I stop at any place. Okay, next please. Yeah, and this also I don't want. Next please. Okay, here I have to do, here everything is there. So while aligning all these hydrogen protons or hydrogen nucleus, they take a little bit of time. They relax. So this is relaxation is what we measure in logging. So this is called a relaxometry. Why they relax? Because the environment around, whether it is in a small pore, it's in a big pore, it's in gas, or it's in oil, or it is in water. Based on its environment, its alignment time varies. So we capture that alignment time and then say this is water, this is oil, this is gas. I try to oversimplify it. I mean, beyond that, I may not be able to do it. So we have a CPMG sequence. I have written in my paper, it may be published perhaps in detail, what is CPMG sequence. This CPMG sequence, what it does is that we not only activate, not only align, supply some energy to that. When energy is supplied, all these protons, they precess in phase. That is called nuclear magnetic resonance. So once they are put in phase, and I leave it, I will not supply any radio frequency. Then they all again reorient. This reorientation takes some time. Again, that is captured in this process. This contains all the petrophysical parametric properties in this. This is what is nuclear magnetic resonance measurement, relaxometry. In terms of time, in fact, that the time constants for longitudinal as well as the transverse relaxation times. Okay, that's what has the petrophysical property imbibed, enveloped into that. I take it out by petrophysics. This is the tool, and please go ahead. Please go ahead. Next. Yeah, next. Okay, so now I want to find out, this is everything, summarization. First is the polarization growth, how the magnetic movement, the bulk magnetic movement grows. It grows there. It takes some time, depending on the environment. So I have a curve here. This gives me the T1. T1 contains the bulk parameters, if it is water, oil, or gas. And this curve gives me the properties of a fluid within a pore, because it's very difficult. A pore fluid, it behaves a different way. So I have the bulk properties, water or oil. I have the porosity here. These are the two main things, students. I'm sorry, the galaxy of human experts here, what we aim at. Apart from that, there are so many things. Okay, next please. Petrophysics. Petrophysics means taking out the required geological parameters, porosity, permeability, porosity distribution, as well as the typing of the hydrocarbons. This is what we do in this. In simple terms, we have done it. Don't think that this is only theoretical part. We have done it in KJ offshore, and we have solved many of the problems based on this. Okay, next please. No, please go ahead. Yeah, if it is a small, there are the three relaxation processes of the pore fluids. I'm not going into details, just note down if somebody wants. Surface relaxation, bulk relaxation, and diffusion. Diffusion gives you whether it is in oil, or it is in gas, or it is in water. Okay, and the rest of the things gives you whether it is a big pore, or a small pore, or a medium-sized pore. Please go ahead. This is what it is. If it is a big pore, the peak comes here. If it is a small pore, the peak comes here. But rock is composed of so many different types of pores. So I get this. And this is a multi-decay curve, and the mathematical methods are there to take out what type of pores they are. So I can give the pore size distribution, very important for the permeability. Please, next. Okay, again, I have shown you the same thing. I think I'm through. Porosity, I can calculate by these equations. Next. Permeability, I can calculate from this only. Next. And hydrocarbon typing, as I told you, I can tell whether it is a very heavy crude, gas, or even light oil, or water, of course. So I can differentiate from this. And the speciality of this tool is that it is free from lithology. Lithology, most of you understand. Lithology is the solid framework of the rock. Okay? I promise you I will not talk irrelevant. I think I did not leave anything relevant. Thank you so much for listening to me. Next, please. Yeah, this is the log we present here. Of course, you may not understand. Even I didn't understand in the beginning when I have seen. After working for so many years, we understand this. T2 distribution curves, that's what we give. Next, please. Okay. Summary. I think my chair and co-chair must be happy that I have done it. So summary, hydrogen nucleus are activated, regulated, and pursued to measure polarization characteristics. Polarization means aligning characteristics. And spin, echo decay, that what contains the petrophysical parameters of all these reservoirs. You give me a reservoir, whether it produces or doesn't produce, I can tell on that. By this. Response changes by, of course, that is the acquisition parameters we change. And these are the end products of mine. Okay, friends, next. This I'm not going to explain because it takes some time if I explain it. Next. These are the different types of rigs in offshore where I worked. As I told you, different types, jack-up. Of course, the Rajahmundry people, they are on the surface, and the rest of the things are in KG offshore we used to. Next. That's what we are waiting for. Thank you. Nice of you for the wonderful listening. I hope I have done my best to make you understand.
Thank you so much, Dr. Rajbabu Garu. I think you have just finished on time, maybe 1 minute. Yes. Okay, thank you so much.
Yeah, please, please. Oh, it's wonderful. What? Sorry? Okay. Yes, sir. Yeah. Oh, that's wonderful. That's very nice. Yeah. CPMG sequence. Okay. Oh no, it's my pleasure. It's my pleasure. Anything, students? I think your Professor Trinath or Professor Naidu, they have my email address. Anything on logging? Please contact.
Thank you very much for your answer. So inspiring. Shall I just a minute? Sir, I request Professor Venkateswara, please come on to the dais. Professor Venkateswara, please come on to the dais. Jai to you. Shal.
Absolutely. Yeah, that's not a problem. This is an advanced geophysics. Sir, I don't know whether I really deserve this or not, but I feel so happy to teach in my own college where even active. It's really a great honor, friends.
He's my classmate.
Thank you. My classmate. Okay.
Thank you so much once again. Thank you.
Thank you.
You made it.
So the next talk is by Dr. A. Venkatrao garu. Yeah. He will be talking on role and potential of artificial intelligence in oil and gas industry, use cases and case studies. Hello. It is a highly emotional moment for me. I am the student of this department and I am here. First of all, let me pronounce to all my gurus, all the present faculty, and all my seniors, and all the best wishes to my contemporaries. And one word I am saying to my youngsters here. Till now we are hearing something in English and something in Telugu. मगर तेलुगु में मैं बोल नहीं सकता, तो हिंदी में बोलता हूँ. एक बात मानिएगा, टान ली तो हम जीत गए, टान ली तो हम जीत गए, मान ली तो हार गए. So never accept the defeat, always go for the win. So another two aspects, he has given me the time, I think must come. Before that, sir, I need 1 minute extra, whatever you say, okay? Because I joined the department with the two distinctions which I would like to share. So in 1980, when I came to the department, the day of my interview, I was asked to go to the Balaji temple, pray the God, and come tomorrow. So the next day when I came and I was told, I am sorry, we are sorry that the person who has given the telegram has come, so you are not having a seat. So next, another of my friend, V. Venkatrao, that person came to me and said, "Yaar, AV, you are interested in geophysics, I am interested in physics. So let me go to the physics. If you are getting the seat, I will go to the physics." So then we both have gone to the department, and then it was assured that I am only getting the next seat. So that person shifted to geophysics and I joined. So in a general category, my first distinction, I joined the geophysics as the last candidate, 27th in the roll number. So that is the distinction, sir. The next distinction to the department is the people who are below me or behind me in my percentages, gone to MSc Physics, Electronics and Applied Physics. So the department stood at the highest percentage. So that is the distinction which I brought to the department. Thank you. So, sir, so far we are talking on artificial intelligence from the morning. Before going into the slides, everybody is talking of artificial intelligence. So, but as our Vice Chancellor Garu is telling, we are mimicking. Means we are having some knowledge, right? Without knowledge, there is no artificial intelligence. Okay, you are having a knowledge which you are putting. So, lot of has been talked. Which made this artificial intelligence go to the next level is the one word which has not come out so far is when I entered into that and working on that big data and cloud. So if I say that big data, is it peta and terabytes of data is the big data? I don't think so. So we are used to when our Bombay High 3D is there, if I am going for its depth migration, it runs into tera and petabytes. It is not a big data. Big data and the data science coming. Again, where from the big data is coming? Big data is coming from multiple sources in different formats. So I don't know what Chandrababu Garu is sending, what Chandra Garu is sending, and what other is sending. I am getting 3 tables with the numbers. I don't know how to combine that. That is where the big data technology has come into this. When we talked of XML and other formats have come. And once the data is in a big data, any application can read and give it to you. Please, next slide. So I'm going to put my knowledge, what I'm having in a scientific way through computers to achieve what I like to have. To reduce my workload, I'm not going to rule out that human is not required. Next, please.
So this also I talked of. What is the machine learning? Mimicking. Mimicking is a word one we heard of. So I am training my system with a lots of data. If this data is like this is my outcome. So earlier we used to talk of prediction. So by seeing I am going to predict, by training my machine a lot, I am going from prediction to prescription. So I am going to say that the work has to go ahead or not to go ahead. I am not going to talk on much one. Please. Others known to everyone. Please, next slide. In offshore, so remote control systems, robotic operations. So earlier, if an asset is to be monitored, a person used to go there and used to write its temperatures. Then a pad has come, used to go, put there, and it send it to the us. Now it is being done by robots. A machine will go, a sensor will send IoT. IoT, see, again I am saying, when these sensors are sending the data, about 80 to 90 sensors in a month, it is not the voluminous data. It is a 3 MB, around 3 MB to 4 MB of a data. If you are having the data can be transferred to you, so it is very comfortable for analyze and use the data. Okay. Next, what I call results, RTOC available. Okay. See, human resources, I have to retire. Here I am only wanting to say one thing. The word phrase there is hire to fire. But I'm not interested to cut off my human resources. So I changed my word hire to retire. So I want a person joins, he has to retire comfortably. So what the system today is doing, from your matching your resume to experience and saying your preliminary level of interview, and even they will explain you that what sort of system will be there in the system, in the organization and so on. So we won't be going further. Okay, AIML, finance. So finance being, I don't think is a much challenge for any AI because history is available, data is available, prediction and analytics is only required, and forecast where you are putting in more and more AI part. Next one. So maintenance, asset maintenance I'm going to talk on as a part of, because now I'm going to talk on the two topics. So I'll be taking up at the next level. Capital planning. So capital planning is main thing is that how I'm going to manage my inventory. If I give a small example with the information available, with the sensors available, how many times my drill bit has gone inside and come, and depending on its life and other manufacturers' information, I'll be in a position to say that so and so drill bits available in that slot are bad, so you change it, and so I'm going to save my time. Next one, environment, health, safety. So as I'm going to talk on green at the time, obviously I'm talking on that only. So I'm not going to read all those things. Next one is a case example. Please. Next go on, please. The slide is going to be shared. Slides are going to be PDF and shared. Anybody can question because the number is available. So here we talk of in oil industry, digital oil fields of the future. Future is past now and we are in the present only digital oil fields are available. What exactly I am going to present a case, how the jobs are going to be done here. So please, just buttons, okay. So in this field, well 3, annular temperature and pressure rising from 115 to 7,000 degrees, the information has come up at the rig site. So this is the sensor made available information. So now automated and the intelligent systems are going to question me. I can configure them to take a decision, or otherwise human interventions also can come. Next point, please. Next. It is an action alert for me. So if you are sitting in a RTOC in a rig, you get bombarded with peeps health. So I'm wanting to avoid them. Next what, please? So a log has appeared. So next. So next, once this log has come, my person at RTOC has seen some red mark there and is not able to decide. So next he got a message at whom you like me to connect. The system is asking whom you want to connect. Mud logger is busy, enjoying a party. Client's representative is away. Drilling in charge is available. And my drilling expert is available, holiday is available, but how you can say available? You open your mobile and you can say that whether a person is available or not. So that system could note that the person is available, enjoying his holiday at Goa. Next please. So this person is connected, asked me to connect the expert. Connect the expert, share the desktop, share the expert. So this information he is seeing on the sitting there on a screen over there, which is the technology today. Saying is that starting annulus pressure is 2000, fluid in annulus, temperature raises from 445 to 115, and pressure is raising 7,700 and etc. So, and other logs are liquid and others with all the information available as on date, my human intervention is there. So, my person is going to say that action, well control operation, stop the work. He has gone for the stop the work. So, by saying is that we stopped a blowout, so all are well, environment well, my green trend is achieved. So, one point of the green trend I am talking about. Next, please. So, what is the earlier situation? Sensors, ground feeds, all wired, gateway, RTOC. Sensors at rig, surface and subsurface data aggregators, and gateway to contactor to RTOC. RTOC concept I explained earlier. Next slide, please. So I'm not going to talk on. These all are these different sensors available at the site. I'm not going to talk. Next. So, okay. Next one, please. So it is a typical example that my survey is happening on. My engine temperature is 85 degrees centigrade. Next. I have just logged at 83 meters and a TVD because by is going for a shallow survey at that place. Next. 2 clicks. Observe. These are the tank information. Okay. Next. Next. All this information has come over there. Next. Just one. Okay, don't do anything. So here why I'm saying is that here from the data has come to my project manager, publisher, to country office, war room, country office, and through a firewall. Yesterday, our Prime Minister Garu is talking outside on AI. We should build in very strong security protocols. That is the firewall will do. This is the clear explanation how AI is going to take. Few use cases I'll show on the slides and I'll conclude this way. Next. How much time? These are the different artificial AI techniques. So all my data coming from different sources is going to put one or through. We have done a testing on borehole, what I call for mud estimation for a well. So we have taken a 12 wells drilled and a 13 well is also drilled already. And we have put the 12 wells data with information in my AI. So, and we predicted which is matching 95%. Next one, please. What is the thing seated next to? I'm not sure, but it appears to be some form of non-artificial unintelligence. AI is talking about us, so we are not one. We have to cut that sometime. Okay. Next, please. See, where AI can be. From morning we are talking of remote sensing. What are phytoplanktons? Okay, these are the microbes which eat our oil spills. Okay, so if we can find out these oil spills, what I call these microbes over one reservoir, similar microbes can be tested all over the world on a single button. The examples what I have been shown in the morning, it is not come. Next. Next. So this is the data is going into, so I'm not going to talk on. Next. So this is where I'm saying is that mud flow in and flow out. There is a big gap. Mud flow in is mud flow, a gap is increasing, so blowout can happen. So I'll be in a position to take up a decision much faster. Next. Next. So here is your knowledge. This is built into the system where I have taken my drilling actual plan, plus or minus 10 and other experiences added up, and that is put into your artificial intelligence network, and my machine has been trained with the different experiences so far. So it will give me saying is that what happened next. Fast quickly. So ultimately I could say 174 hours. So again we talked of shale drilling. So how exactly my drill bit is reading, every moment I will be in a position to monitor and I can deviate. This we have seen in sitting in Houston and what I call operations happening in somewhere in Australia for a BP operation. So again a logging. As one of my friends had talked of logging. My system will be in a position to, I need not do any manual work. I put this data, with this data it will be classifying these origins and everything that easily. And it will be, see here you need maybe a minimum intervention. Next. Production optimization. Next. Sir, here I like to take a 1 minute. Sir, 1 minute? 1 minute, 1 minute, okay. Sir, this top line, what you are seeing is my what I call in-field oil production. Oil, what I say that? In-place oil, okay. So when I am producing without anything, then my production is going to fall and I am going to reach. If I reach it this bottom place, whatever is in-place oil, that red or maroon colored is lost. So what we used to do that every quarterly we will correct. We will monitor the field and correct those triangles. Nowadays, this system will correct every minute. So is that next week. So that I'll be reaching the top line closest to the bottom. Then if you see that, then come. Back please. See here you can see that green and blue. This much accuracy we can forecast and produce of it. This works done by us and we have tested on the data. So next one. Sir, another thing is that I am done with. Only one point I am saying, not going into the slides. For the first set will be completed. Thing is that for seismic digitization, you need a big digiboard, put a seismic section, go to the points. Today you give me an image of seismic, I'll give you segway next moment. You give me a log image, I'll give you a last file next moment. If these facilities are not available, you can never do AI or whatever the technology available. Please, close on. This is asset monitoring. See, again asset I'll be talking about. Push. This is the log and this is the last file. Again, I can't show last year data, so I'll show an image only. Next. See, what is the advantage? Fewer workers, scaled capabilities, I'm not worried on this. Greater speed, I need it. Higher quality, I need it. Newer capabilities. All these three, I need it. Fewer, I don't know. It is not that easy to change. Next, please. Yeah. I'm sorry. Now, at the end, as I'm not wanting to cut the people, AI guy is going to change it with, replace with a human. Next one, please. Yes. Few jokes here are either artificial intelligence or AV's intelligence. Thank you. I'm done with my first paper. Five, 6 minutes. So I can't talk on the other 5 minutes, but 5 minutes I'll try. Next, green.
Yeah, here's another talk. Going green, trends and innovations for clearer technologies in oil and gas industry. Sir, I request you to be very in 5 minutes, just summarize it.
Sure. So you are giving total me 17 or 18 minutes. I'm happy. Done. So if we are here, we all are here doing well, the environment is going to do well, obviously. Next. So next. See again, how exactly we are going to do that? Working procedures. See, before 1994, we used to say that it is not easy that oil industry can work with what I call safeguarding the environment because it is the most polluter. So now the changes have come. So we are working on working procedures. We are changing technical modifications, process modifications. With all these three, we are able to achieve the what I call balance between the environment and my business. If I am talking my business, oil industry. Next, please. So this talking or not talking is okay. Next. Okay. So these are the new techniques. Okay, I used to take logging while drilling, measurements while drilling are being used earlier. So I have to shut down my system. What I call take out, I'll give it to a logger. So unless now when I'm doing logging and MWD, measurements while drilling, unless it is required, I won't be going for a special logging. So I am saving that much hours, that much what I call energy is saved. So green. So next dual gradient. No, next point. That's it. Okay. So dual gradient drilling pads. Okay. Now what happened is most polluting, if we talk of everywhere, is the shale and shale gas. So drilling pads. So drilling pads, how easily, how better you can drill them. Reduced well pad sites, hydraulic fracture. So now even hydraulic fracturing has changed to gas gel filled fracturing. So that when hydraulic fracturing, more water being what I call, which is coming back, backed up water, will say that it has to be treated. Next. These are some. Okay, you come here, it's okay. So see, earlier in neutron, pulse and neutron logging, what we talk about Ambi and cesium are the sources. These are highly radioactive materials and they are tough to transfer, they are tough to carry. So now Schlumbergers and what I call Halliburtons have come up with pulse and neutrons, improved sigma, what I call pulse and neutron tools from these two. These will avoid the problems with those two sources. Okay, these will sigma measurements, density measurements, improve gas detection and other things. Okay, next. This is again in this what I am saying is that entire all your equipment you are having the today tools. You have to monitor third-party certification, etc. Have to be monitored. For monitoring, there are the tools. Otherwise, it will trigger immediately a message to the higher ups, next levels, and what sort of action is to be taken. Even the suggestion that the drilling, what I call that particular BOP has to be changed. So, such as will come up. Next. So, CO2. See, first of all, the industry job is to produce more oil because industry is not here for charity. So, industry has to produce more oil, but it should be in a position to do most economically and environmentally safe. So whatever the CO2 I am producing, I will be in a position to reproduce what I call in situ. I'll send it into the bore so that I'll get back more production. So that is what. So well examination. This also all BOP equipment used in new protein drilling operations have to be checked. Next. This is water from one site. We are drilling about how many wells? 28, 30 wells from one site. And how this is being identified easily. Earlier, your vehicles have to run into the forest, all the fields and everything. Next, please. Now, today morning also we have seen what the possibility of your remote sensing. So your remote sensing data is available. You will be identifying comfortably your paths where that fresh water and other waters and others are not disturbed. Environment is not disturbed. I can explain better, but I'm fast. Okay. Thank you. Next. This is the process, not record. Go ahead. This once shared. If anybody doubt, can approach me. Yeah. See, this is point I want to take a minute or a fraction. See, once we are getting what I call fracking with water, whatever the water reproduced is having a lot of what I call contaminants. So how I am going to save my reservoirs? So I have to test all my groundwater reservoirs. So for that one thing is suggested is that a third casing in case of good reservoirs. And other thing is testing, monitoring a well on the upstream, downstream. Here upstream and downstream are not my industry, but flow. Okay. So when the well is monitored from all the sides, I'll be in a position to say that my frac water is entering into my reservoir or not. So produce treating, that is a different issue. Thank you. I think point got it. Next. This is the process. Next. Next. This I think you read and you will be in a position to understand. This is great. This is few trends, what I call protection of natural waters. And next one is today's industry is wanting to go for a zero flaring. Zero flaring is not possible in certain areas. So there the industry is trying. Next button.
Sir, 1 minute.
Okay. Their industry is trying to convert this into what I call flare into graphene and hydrogen. So the technologies have come up and the industry, whatever the flare is being converted into graphene and hydrogen. Hydrogen is your another resource, what I call it. energy resource. I think these points I'm not going to talk about. Others. Thank you. Phytoplanktons, and thank you once again, friends, for hearing me, though I'm fast enough. So when I went to first time to US, again, point I want to share is, so whatever I'm talking, none is understanding. Because I'm quite fast. Hope at least my team, my friends understand. Otherwise, any questions I'm ready to take up if they.
Thank you, sir. Thank you.
Thank
you, sir. Thank you so much. Sir, a small felicitation for you. Please accept our felicitation. I request Professor V. Chakravarti, HOD of Department of Earth Sciences, Central University, to come onto the dais, please.
Sir, again, before that, I want you to share. Our department has taught us not only the subject. In our final year, I think we are already quite delayed for the exams. In our final year, we are already delayed for the exam. Department has not only just taught the subject, but how to handle the different situations. So we are already delayed in 1980, in almost it is October first week, and we are preparing for the exam on 15th, and there were floods. So I am the day scholar, another of my friends, G.V. Satyanarayana, is the day scholar sitting over here. So all my other friends are in Kodekal, in all these flooding areas, Mandapeta, Rajamandri, those areas. So they are all, I am the class representative. I was asked that we want 5 days off or 10 days off. We have to go see our parents and our properties and come. So first word, nobody accepts. So our friends said that we are going on strike. So as a leader, I have gone to our head of the department, Garu, Sitaputra Garu, with all my friends. Sir, this is the thing. The team wants to go for a strike. Yes. Why? So these are the floods you are seeing. Okay. What about you? Sir, I am here only. No floods for you. What about other? He is also known. And few may not be having. So you write the exam. Whoever is not having floods, write the exam. And exactly you are asking for 10 days. After 10 days, again the paper starts. No what I call like a second exam or something. But exam is going to start on. I am with full sympathy to my other students who are having the challenges. So they can go back, come back and write the exam. No what I call anything negative will be done to them. Sir, we have written the exams on the date. All. So this is the system. System means the sir has trained us, saying is that keep cool. So how we can come out of the situation. So all those people also might be very happy. Thank you.
Thank you, sir. Thank you.
Thank you. Thank you, sir.
See, there's a small thing which I have to discuss with you. See, we are running out of time, so we have to think how to adjust it. So what we thought is, after the tea break, there are 5 talks. So anybody, I mean, we have sorted out Mr. Dr. Sriram will be giving the talk in this session itself. But who else would like to present now itself? Now, okay, all 3. Do you have something? I mean, we would like to shift this session tomorrow. Is it possible? Tomorrow early? Yeah, all 3 10 minutes will be again 1 hour. So it's like that. So that's what we are thinking about. Please, yeah. Yeah. So all the 4 would like to start, would like to give the talk, right? So see, if we carry on, it will be around, I think it will be around 6:30 if we start. So let's go ahead. Okay. Okay. So we have some other, because there is a protocol which is going on here, because until we need to finish the session by 6 o'clock according to 5 o'clock. So it's already 5:30. So that's the issue. I hope, is it possible that we can do it tomorrow morning, first hour? Is it possible?
So as the time is going on, tomorrow some of the people can present the paper. If they want to wish today itself, they can finish. And if they are having some other program tomorrow, now I request N. Chandrababu is there. Would you like to present today or tomorrow? Okay, that's fine. Fine. Shoban Kumar Roy, Shoban Kumar Ray, Sultan Ahmad, and Anil Kumar. Today only. Okay, nice. And one thing is, another thing is a poster, and P. Satyanarayana. Would you like to do it today or tomorrow? 5 minutes. Today you want to do it. Okay, fine. Hasib Rahman and M. Subramaniam. Karimunisa Begum. Is there? Huh? Oh, okay. Notice K. Dhanam. K. Dhanam. High resolution seismic imaging in Gondwana coal basin of India. Characterization of washability of high Asia coals from Elandu. Sanapala Harikrishna. Is here? Everything? And T. Ramprasad, would you like to do today, tomorrow? Huh? You want to finish today? Okay. Sai Krishna, an assessment. Tomorrow. Okay. Thank you for your cooperation.
Okay, so now Dr. Shoban Kumar Ray will be presenting on a topic, geophysical study on coral growth and signature of gas chimney in the gap area of Jakwa sector, Arabian Sea, Gujarat.
So good evening everyone. Since there is a paucity of time, let me straight away go to my topic. My topic is geophysical study that we have carried out in Gujarat coast, and two topics I want to touch. One is the coral growth, second one is the chimney that is related to gas. Next slide. So broadly, this is the outline I am going to cover. What the observation we have in terms of bathymetry and shallow seismic study, what controls the deposition pattern, where exactly the coral growth and why the coral growth is there. To be specific, what is the gas chimney we are talking about, then some references. Next. So let me introduce my area. Instead of introducing me, this is my area that falls in the NHO chart number 202. No, first 202 and 203. And this beautiful location, that bifurcation in the Gujarat, this is the location where the area is located. Next. So the term I used is gap area. So what is the gap area? To justify that, these are the cruises we have taken by Geological Survey of India since last 3 decades. But the comprehensive study of geophysical parameters, for example, seismic, magnetic, was absent in that area. So we have decided to go for a complete study of that area. That's why the term gap. It's not the gap. It's the in terms of the baseline data generation, there is a gap. And this is the transects we have taken. There are 25 transects. L1 means line 1 to line 25 perpendicular to the coast, and 3 parallel to the coast, T1, T2, T3. T means tie line. The utilization is to see the cross at the cross point how the reflectors are varying, and to generate 3D model in our software. This is the utilization of our tie lines, and these perpendicular lines to see the variation of reflectors. I slowly present. Next. So this is the bathymetry map of my area. Any map, since all experts are here and here, the students I am telling directly see the color map. Okay, so the okay. This is the water depth. Bathymetry means water depth. So water depth, you see that northwestern part is somewhat very less compared to, there is a abrupt change over here. The same 3D version, if you see this is the 3D version, right? So in terms of the result, the geomorphological variation and the observed reflectors, we can divide the area into two parts. Domain A, very clear why this is domain A, and there is a contrast feature compared to domain is domain B, where the changes are very abrupt and things are accentuated mainly because of the new tectonic activities. Right, next. So domain well, let's see what we actually get. Most of us talk about seismic, what you do, the thing, this is the final result of any seismic result. At least those my budding geoscientists, this is what we get. So say the sea floor, the variation is very minimal and there is only one reflector. Next. The same thing continues in the other transect as well. First I shown L1, then this is L9 and this is L16. So there is a pivotal change in L18. Up to L1 to L18, there is a uniformity change, that is domain A, and the sudden abrupt changes happens in beyond L18. So we'll introduce ourselves in next domain. Domain B. See, the abrupt change happened. Here the story of coral started. If you see in those coral, in the domain A, the sediment thickness is higher. There is no question of coral growth. But the moment I enter here, L19 up to L25, there is a chances of coral growth. If you see, one of the dimension we have carried out, height is around 6.6 meter and width is 160 meter. It's a huge structure, though in terms of scaling, this is less. And secondly, there we found one reflector. Here there are two number of reflectors, R1 and R2. And why? Because these at some places there is that hard bottom has come up, which is not there in that domain A. So as simple as that. Next. Same story continues the next thing. So beautifully it has mapped. Okay. Now the question is, what actually controls the sedimentation pattern? Do I have something in our hand? So to say that this is the isopath map of my area means the thickness. What is the thickness of sedimentation? And now we see there is a high thickness over there and the thickness loses the moment I come into domain B. So the mechanism, what it explains, there is a very nice publication in JES, Journal of Earth System Science in 2014. What they told, the current, see, the current following that coast, the moment it crosses here, there is a cyclic disturbances. And it is so prominent that is not allowing anything to settle down. That's the reason the thickness is very less over here. Right, next. And secondly, what actually brings the sediment? There are three river types. One is, sir, I have time? 1 minute only. Okay. I have three systems. Indus River system, one branch deposits there. That's why the sedimentation is high. And other rivers are contributing to this factor. Main is due to the tectonic disturbances followed by abrupt changes. There is no sedimentation. That is in L18. Since I don't have time, I'll run next slide. L18, L20. Next. Then out of the possibility, there are two possibilities. The first one is possibly there is a hard rock which is blocking my signal. Am I audible? There is a hard rock which is blocking my signal. That's why I'm getting a blanking. And second option is there is a possibility of gas over there. So since in 2000 SD-263 cruise by GSI, means Saudi Gamma, that scans that west coast, in 2015-16 they have reported some hexane gases through this gravity coring 3, 4, 5, 6, 11 and 12. So there is a possibility of gas. And DGH also reported some gas in that area, GK29A and 22C, but not in that area where we have done, far away from that. So there is a possibility of gas. That prompted us to actually think in that way. Next. So what we did, we tried to find out where is a blanking. This publication is from GSI itself, my senior, Raja Mukhopadhyay. See, this type of thing they got. There is a abrupt truncation and followed by a acoustic blanking. The same concept is utilized, not utilized, is the right hand part, they have done it earlier. In the special edition in the Black Sea, what they have observed, there is acoustic blanking, but enhanced reflection on the upper face front. Right? So we have utilized this thing. Next. So now see, I have a blanking below and accentuated upper front. As simple as that. So we, from our side we say predict that there is a possibility reported and the various parameters telling us to do that.
Sir,
Next.
please conclude.
So just 2 slides only. And for our scientists, these are the parameters I have used: frequency, automated gain control, signature deconvolution, pings, and these are parameters just for your information. In case you want to process it, you can use this parameter. Next, sir. So these are the references I have used. And here, sir, just 1 minute, I'll conclude. So here actually everyone is talking about AI, deep neural network. So here I want to tell you one thing. What I did, I put my profile in DeepSeek. You all know now that Chinese AI bot, they have put that that AI bot. I put a chat bot. I put it and asked to interpret my data. You'll surprise, it gave nothing. Simply the coordinates and these are this thing. Then what I did, I put this share market parameters and asked what should be my target price. You'll be surprised. DeepSeek, ChatGPT, Gemini, Copilot, everything predicted very nicely. What should be the stop loss? What should be the target? What's the candle pattern? Where is bullish? Everything. The thing is that share market, lots of money involved. Algorithm is very nice, so they are able to predict. But in geophysics, the moment I am giving my picture, it's not able to predict because the algorithm we have not produced properly. So think that algorithm, develop it. Possibly one day you will write a code regarding that interpretation of seismic profile. So we are doing that. So thank you so much.
Well, I have it's not only the algorithm which is doing here, it is also the the amount of data which is being produced.
Yes,
it's nothing but cluster analysis, fuzzy. It's all it interprets the data based on different.
Sir, I have done that. I have done that. Yeah. I have around 20,000 X-rays to predict whether the pneumonia or not. It's successfully predicted through machine.
But in this case, where you have used the chat.
Yes.
In ocean, there is no.
I wanted to see what the response. It means garbage in and garbage out is still continuing. We have to change it. That's what I wanted to do.
Thank you. Very nice talk. Thank you so much. Thank you. So please accept our felicitation. I would request Dr. Y.V. Subbarao Garu, please come out to the dais and please felicitate himself. He's the president of RGS. Please, sir, please come on to the dais.
Okay, so I invite Dr. Satyanarayana Garu for the next talk. He'll be talking on He'll be talking on search for untapped hydrocarbons from basement hard rock.
Good evening to you all. Please appear. Okay, good evening to you all, and good evening to coordinators of this session. I am P. Satyanarayana from the same department of Geophysics, Andhra University, 7780 batch. After that, I joined ONGC and worked in different basins: Bengal Basin, Krishna Godavari Basin, Assam, and Mumbai offshore. And after that, I was posted in OVL, and I had an opportunity to see many more basins and for doing the due diligence for offering the blocks. Now, this is the most of the work was done first time in basement. To study the basement, the then Director Exploration, T.K. Pandey, introduced a task force, constituted a task force. Further, Dr. G.C. Agarwal used to be the, you can say, first person to identify the basement as the reservoir, and where he has particularly seen the oil, and he took the oil to the then chairman. He used to say this thing to Kamal Wahi, and he told that this particular reservoir should not be taken just lightly. And how does it matter whether it is from sandstones, limestones, and shale and basement oil? Sunil Gavaskar used to say, we are all cricket lovers, used to say, how does it matter where from the line runs come, whether it's sticky shots or back foot shot or front foot shot, whether the scoreboard is moving or not, that only we have to see. So like that, irrespective of any reservoirs, the so-called conventional reservoirs, that is the sandstone reservoirs and all. So let us not bother. Reservoir means where the oil you get, that is the reservoir, that's all. Tap means which can stop the oil not to migrate from that particular lab. So with that simple definition, if we go, we can find miracles. So next please. A large portion of world oil proven reserves are from naturally fractured reservoirs. For basement exploration, two things are very, very important. Structure are fractures and faults. Fractures are the drivers from the fault. If the faulting is heavy, then only there will be chances of fractures. So natural fractures are important, of course. And if the fractures are open fractures, then only oil can migrate, go and sit there, and if the proper mechanism is there. It also follows the same principles: source, reservoir, and capping mechanism. But basement is unconventional reservoir, and there are so many challenges. Whatever we are all doing for the sandstone reservoirs, limestone reservoirs, everything should be different from that particular process. So for this, all even data also, if we are all depending on computational wave data, in the absence of shear wave data, we can go for computational wave data. But there are many challenges right from the exploration to drilling and estimation of reserves. Next. The potential of reservoir, if you see, and as on according to the available data estimates for the world's basement oil and gas, geological reserves are 21 billion barrels of oil and equivalent. You cannot leave it just like that. So everybody should think how to go about basement. Next. So these are world basement oil scenario. Production rates, if you see, 3,900 to 11,500 BOPD per day. To see how the productions are going on. So when Mara field, California, and all these things. Next, please. So Indian context, we see Borhala, Champang, Assam, Rajor, Mumra, that is technical basin, basement. Basement means don't think that it's only granitic basement. Even volcanic basement is also this. That is technical basement, basalt also in Rajor, Mumra, that is intertrappeans you have seen, and Kaveri basin and Padra. The best example is Western offshore, that is Mumbai high asset.
Next. So basement oil, of course, next. Is it the basement exploration? Is it just by accident? So the answer may not be, certainly not yes. The basement oil and gas accumulation are not fixed, but obey the rules of origin, migration, and entrapment as in the kinds of convention. Please. Next. So these are some of the wells quoted here. So what Dr. G.C. Agarwal, geologist, he used to say that he has taken the oil from the BH37 well, 1746, and I think we have produced for 57 days. Afterwards, there was production drop. Next. The favorable conditions, there are only two, that is upliftment of the basin. If it is shallow one, definitely we have to go for that one. And if it is close by the faults, heavy faulting, tectonic activity is there, means so there are every chance for developing of the fractures. So those are the two favorable areas how to get to drill basement for the basement oil. Next. So methodology, of course, observations. During that task force, I was the core member in that. So we have personally gone to see the outcrops. First of all, outcrops is the first clue. So we have to nearby whether we will definitely go for basement oil exploration or not. Next, observation, previously. The same thing, that is natural things on core stages, geological understanding, geophysical data interpretation, seismic attribute, integrated analysis, casing. Next. These are the outcrop studies, for example, previously. So these are the clear that we have gone there, rock, water, sea rock, water. Those who stayed in Bombay, they can understand. This place we have gone, we have seen the outcrops. You see how nicely the basement, at the basement outcrops level, the fractures, and interconnected fractures should be there. That is another condition. So fractures, if it is just open fractures, if they are not connected, again we will have failures. So there should be interconnectivity because natural porosity is not there. So that's what I told in the first statement itself. That natural way, whatever we are looking for, sandstone reservoir, limestone reservoir, that methodology will never work in basement oil exploration. This is entirely different. So everything should be different. Next. So outcrop study, this again, this is exposed banded. This is also near Mumbai only. Next. These outcrops, world examples, columnar joints you can see, and this is the weathered top columnar joints. Next. Just to have the feel how the fractures look like. Next, crisscross vertical fractures, you can say. These are field, generally even when we were studying also, we used to go to field nearby areas. So field is very, very important for the basement study. Field studies definitely should be there. As geophysics, we should do the field work also. Next. So these are interconnected 60 degrees fractures. Next, please. Yes. In the course, next thing is core studies. If we happen to see the drill well, in the core cuttings, we see oil. In the course itself, oil is there. Cyst and high angle and cyst vertical fractures. Next. These are all MH wells only, and that white patches are oil only. Next. And these are some of the examples for the fractures. Next. This one is another example for the same angular fractures. Next, please. So, okay. That I told only two examples, that is structural. Where the more the structuring, the more the fractures. This is the fundamental thing we have done. The more the structuring, the more the fractures. Brittleness will be there. If it is negative fracture, negative load, that indicates low. That is not helpful. So this will be explained by the mean curvature attribute. So attribute studies are also important that we did when we were studying this one. This is the example, best example for the top of this. That is in the northern part of the Mumbai field. This is the best example. Well, A was built, it was successful. And the down dip shales are the main source rock, and it is juxtaposed with the structural height. And exactly at the vertical position, we got the oil. Next. And this is the fault configuration of the Mumbai field. Each and as much as, because in normal interpretation, we can leave some of the faults, no problem. But we are always interested in the structure, whether it is formed against the faults or not. But in basement, each and every one, whatever you can see with the naked eye, you have to plan, you have to map them. As many faults as much. You have to map so many faults so that you can make the areas, you can say. It is not fault, it is fault areas.
Sir, 1 minute. 1 minute, sir.
Next, let me complete because I am running with the time. Please, next. This is a structural map. Previous map. This structural map with the fault imposition. Next. This is the dip and change. Wherever dip changes are there, it will be identified with this particular attribute, and it is superimposed with it. So wherever dip changes are, all the dip changes are taken care with the fault mapping. You see, all the faults are very well matching with the dip changes. This attribute works very well. Next, and this is curvature. All negative curvatures indicate the lows. All the positive curvatures indicate the highs. Next. And these are the sum of this is reflection strength. This reflection strength indicates that the wherever the blue marked areas, those are the areas are faulty areas. We can say fracture areas, develop lot of development. When you move towards western side, whatever wells we have drilled all are dry, and when whatever wells we drilled very close to the eastern fault, all are hydrocarbon. When we tied up with the wells, very well matching. Next. This the same thing, uplifted basement height and the fault structure. Next. And this is another example, of course. Next. So well big. So this is the again fault. Whatever we have drilled very close to the fault and all are oil bearing. This summary, the basement, same thing, this everything I have to. Finally, key to the success is in the basement reservoir lies in the fractures and the interconnectivity. Thank you very much.
Okay, so I think you are just on time. Thank you so much. You are just on time. Thank you so much.
Quickly, any one question?
So this is down dip shapes are source structure, and it is migration and structural bit is there. It is the same principle, sir. There is nothing. Only thing holding hydrocarbon is important. Source is as it is, only down dip shapes only. Juxtaposition with the structure. Cap rock the overlying sedimentary section. That is Oligocene section. So everything in principle is same, sir. Only thing how it can hold. That is the main challenge. Okay.
I think we had the last talk for today. That is by Dr. T. Ramprasad, and he'll be speaking on gas-sided exploration in Indian offshore, scientific studies carried out, challenges and future prospects.
So good evening all. I'm 2005 and 7 batch of this department, and I'm the PhD student of Professor Amara Garu. I've done my PhD from NIO Goa, and my main supervisor is Dr. Pavan Devanga. So glad to see all my seniors, all my juniors, and also my professors here. So I'll be talking about a different concept, that is gas hydrates. Since morning, a lot of discussions, talks are happening about remote sensing, oil and gas. And this is the concept where all the industries are looking to look for an alternative. I was a part of this, and I was taken a step ahead to understand, look at the alternates, not only the oil gas or it's like a methane gas, it's all about the understanding of the ecosystem. So people are talking about geophysics in terms of oil, gas exploration and climate. Now I'm talking about ecosystem. Geophysics has gone way forward to look at the biological ecosystem in the offshores. So here you can see, this is the classical example of AUV data, like advanced technology we have with NIOT. 23, we connected a survey in Krishna Godavari Basin, and we have seen a lot of gas ships are happening. And that is on the right left corner, you can see the kind of biological community which we discovered in 2018. There's the first coal ship discovery happened in India. Next slide. So if I go back to the background of the gas edits, this is the National Gas Edit Program by ONGC. They have done 2 drillings activities in Krishna Godavari Basin, Andamans, Mahanadi. And they have seen 2 dominated systems of deposits. One is the clay dominated, the second one is the clay and sand deposits. And huge amount of hydrate was discovered, but there was a technology lag to exploitations. So a lot of science is going on, but there are concerns about the ecosystem there, because the sea which is giving is a methane, and most of the ecosystem lives on the methane gases. So it's extreme environmental. We have 2 systems in extreme environment. One is the hydrothermal vents, the second one is the coal ships. Both the systems exist with a lot of biological community. Here, they sustain on the methane gases. They don't require any kind of oxygen. And if we try to understand the ecosystem growth, they are generating active biomolecules. And those bioactive molecules are very important in the field of medicine. So Geophysics has reached to the medicine level also. In one level I can go. Next slide. So this is the program of NIO. Like we are a team of 25 people. And we have done 4 recent discoveries. That is, in 2006, we identified the first paleo coal ship. 2018, we discovered 2 coal ship discoveries. One is off Godavari, but second one is off Krishna Delta. The third one is the coal discovery we have done in the Manar Basin. Fourth is recently we have done in Andamans. So NIO has a lot of geological, geophysical facilities with all the advanced technologies and geological stuff. Next slide. So these are the 3 areas where NIO works mostly. Like one is the Krishna Basin, Manar, and Andamans. So in next slide. So this is the first discovery that we have done. You can see this is the water column image, the red color and blue color which you see. The red patches are shown as gas ships. These are the backscatter image of the multi-beam system. And this is the geological signature from the seismic data. We are seeing a lot of folding and faults are seen, and a lot of chimneys are there. And these chimneys produce a lot of gases. And across this area, we see a lot of biological community. We call it as chemosynthetic communities. They exist both in the hydrothermal vent system and the coal ship systems. Next slide. And this is the second discovery of Krishna Delta. We have seen linear poke marks. Most of these linear poke marks we see in the Nigeria Delta. Recently, we have seen in Krishna Basin also, and we are trying to understand the genesis of this system, how these linear poke marks are forming. And we have seen a lot of gas migrations are taking place, and a lot of communities there, and carbonates also. The carbonates talks about the kind of precipitation that happens in that locations, so which can be a future resource. And this one particular example, if you see, this is the patch where you see high amplitude patches. So that itself shows the amount of reservoir of gas hydrate sitting just below the surface. Next slide. And this is the second discovery, like in the Manar Basin, we have seen a lot of chimneys which are controlled by the erosions also, and we have seen this kind of 2 black bombs. These 2 black bombs are mostly seen in the hydrothermal vents, and now they are existing in the coal ships also. Now you can see the kind of diversity we see in different locations. Next slide. And this is Andaman. This is mostly the tectonic driven system, where we have seen the Delgen fault, which is the prominent fault in Andaman area, which has created a lot of faults and foldings. We have seen a ridge-like system, which is almost like 8-kilometer length, and we have seen more than 6 to 7 gas shield locations. So we try to look at the biological community, but unfortunately we are unable to test the surface. But we have some kind of rock samples in that area. So next slide. So in conclusion of this coal ship system, if you see, the very first slide shows about the paleo coal ship, which is almost like 50 million years old coal ship, which was sitting down, and then it was buried with the sedimentations. And the second slide, which is by Majumdar et al., he's my senior, that shows the present coal ship discovery, what we have done, and it is existing there. Now, Ministry of Earth Science is trying to declare this location as the biologically preserved zones. We have to give it to UNO to identify a few of the extreme ecosystems, and we have to declare they are to be preserved. And these are kind of rock samples we discovered from the Andaman area. We have seen a lot of seepings also. And here you can see next slide. And this is the recent survey we have conducted with NIOT. They have a AUV system where we conducted a lot of underwater surveys. And the major advantage of this system is like we mostly conduct the surveys based on shipborne. So the kind of data we acquire multi-beam or anything, that the resolution is 100 meter. But this data is resolution of 25 centimeter. You can see on the left side the kind of bathymetric surface you can see, which is a 1 meter resolution. The below is the 25 centimeter resolution. These kind of geological features, you don't see anything from the shipborne. So whatever we are seeing in the reality of the geology there, it's very quite different. And what we have observed from the camera data is like, you can see this is the white patch of hydrate, which is almost a 6.5 meters thick, which is rightly sitting on the surface. So within the stability zone of hydrate formation with high pressure and low temperatures, the hydrate is popping on the surfaces. And there we can see a huge amount of biological community, like NIO we are working, and we have a project now with Ministry of Health Science and the Ministry of Medicine, Ayush, that to extract the bioactive molecules from these biological communities. So now Ministry of Health Science is developing Matsya, which is an underwater vehicle. They are planning to visit this place. Next slide. So till now I was talking about the kind of hydrate preservance energy and the kind of biological, but hydrate is also a hazard. So this is the recent publication of myself and my senior. Like this is one of the catastrophic event which has happened across the Antravedi region. Like we are keep on collecting a lot of multi-beam data very often for past 20 years. And this is the Krishna Delta, the Godavari Delta area. On the right side, you can see the slide which was marked in the blue. So when we are conducting a lot of surveys in KG Basin for gas hydrate exploration, one of the important understanding what we saw is there is a changes in the geomorphology in the deep waters. Then we started back and look into the shallow areas, what is the process that is happened there. And then we came up with 2020 data. Yeah. So this is the area where the slumping was happening. And this is the kind of deposit was taken place. Nearly 168 meters of deposit sediment was wiped out. It's almost the height of the Statue of Unity. And the deposit almost like that. And the deposit was almost like 70 to 80 meters. When we see at the kind of publications across the world, Storega slide is the largest slide which was happened in the last glacial maximum. In recent times, this is the major slide which was happened in offshore. And this issue is a major concern for the future prospects for oil and gases, because we have a discussion with ONGC recently, and they have a declaration to go for a shallow gas exploration. This is the site, and we suggested them not to go ahead because there is no reservoir left. So already we have done ROV survey recently last week, and we are seeing a lot of shallow gases are popping out, bubbling is happening, and we believe that this process may extend further and it may go to the shallow waters. So we suggested the Kakinada office to look into the data sets again, and we are trying to look into the kind of possible reasons. Now we have 3 reasons that we identified. One is the cyclone which has passed across this region in 2013, that is Helen cyclone, category 1. The second one is the earthquake which was happened in Paradip, 2014. And third one is the major floods across the Godavari. Recently with GSA we have discussion, we identified that the cyclone is the reason. And the strange point is that the cyclone is a category 1 cyclone, which even it cannot push down a tree. But this zone was pressurized with the internal conditions that the gas chamber is sitting down. There is a pulse of trigger by the cyclone, and there is a turbidity circulations. So possibly there is a freshwater intrusion into the fault, and that have created the slide. So it is not gas, it is not only a source of economy, but also concern of hazards. Next slide. So implications of this cold ship discovery, the major thing is like widespread occurrence of methane gas flares in Krishna, Godavari, Manar and Andaman areas. So it's a good news to all to try to explore the methane gases. So methane migration into the water column. So the second kind is methane should not come into the atmosphere because more hazardous than the CO2. Modern coal ships like biodiversity, potential novel bioactive molecules, what I am saying, like it's useful for more medicines. And a proven effective tool for exploration of shallow gas hydrate deposit and methane leakage. The natural laboratory for gas research and for the biodiversity studies. And the major thing is the monitoring of gas migration, the seafloor stability. So earlier it is like a theoretical concept, gas migrates, the seafloor may stabilize, destabilize. but there is no more a myth or kind of theoretical. It is proven now, and we are going for advanced studies on this region, which is a natural laboratory. So these are the references from for my presentation. So next, and I thank my director NIO and also the funding agencies like NIOT, Ministry of Earth Science, ONGC, Oil India also, DGS. And we have two vessels like Sadhana and Sankalp. And I request all the university students, my juniors, take a chance to visit NIO. If you want to come for internship, you are welcome. So take the opportunity. Getting into vessel is not a joke. So NIO is the biggest lab along with NGR. Think about NIO also. And it's not far away. Nowadays, Goa is not far away from anyone. I request even the university professors to send more students to NIO so they can explore new scientific ventures. Thank you, sir.
Thank you, Sriram. Thank you so much. Any one quick question to Sriram?
So earlier the bathymetry depth was 20 meters. Right now it is 230 meters. No, all over the world exploration is done. India is also done. We have two, and one more planning is going on for the exploitation. So the best examples like the Alaska and the Nankai Trough. Alaska, they have done the production. They have done for, they're able to do for 7 days. Nankai Trough, they're able to do for 7 days. There, what they're doing is that they're pumping the hot water and they're releasing gases. Now the challenge is that they are the sand deposits. Once the suction is happening, suddenly the sand comes into the well. The production stops. They're choking in the wells. That was happened in the Nankai Trough. Alaska, it is in the permafrost region. And if you know the recent example of BP in Gulf of Mexico, the kind of accident which was happening, because of high pressurization, the N2 converted into natural gas rate, and there was a blasting. So now people are planning to look into pump the CO2 and replace the methane. No. Yeah, that was. In that case, Japan is successful, India is successful in terms of exploration, but exploitation, still the engineering technology is backhand. No. Exploitation, Australia was not done much. New Zealand is the group where they are looking for Australia also, with the GNS group. So I work with GNS. So now the concept of hydrate has changed into ecosystem. That's what I am showing. Like this is the prospective zone. It's for multidisciplinary field it is coming. Yes. So in Indian context, for the continental margin, the water depth of 700 and more is the hydrate stability zone. So, but now what is happening? The methane that we are seeing in the shallow gases. So they are methane. Again, the shallow methanes, they are creating a mat, bacterial mats also. Sir? More than 700 meters water depth.
Sir, if you don't mind, we'll discuss this after the session. Yeah. We are almost concluding this session. We already delayed by almost 2 hours. Around 3 invited talks and 4 papers were presented in this session. And 2 very fortunate things, and 1 very fortunate thing and 1 unfortunate thing also happened here in the session. Very eminent personalities, retired persons, experienced persons, they came and they gave the invited talks. We are very fortunate in that. And the unfortunate thing is we could not give enough time to them. And the session, I'm quickly concluding this session. It is well received by the field. We thank all the speakers and particularly the audience patiently sit here. And now we are concluding. The remaining papers will be postponed for tomorrow
after the plenary session, the organizers will decide the time. Particularly, we thank who cooperated to postpone the things to save at least some time. Thank you very much.
Wait cheyala. We have alumni meeting today. We'll wait for some time, sir, because the delegates, president of the function, and the rector is our chief guest of this function. So we'll wait for some. Yes, kindly cooperate, sir.
Good evening.